All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. So, my dear NEET aspirants, I believe all of you are doing great, having a good time. We have successfully completed class 11th part 1, class 11th part 2. I know 2 chapters are left. That is SHM and oscillations, SHM and waves. Don't worry about that. I'll finish that too. Okay, don't worry about that. But in the today's session, we will be completing class 12th part 1. And when it comes to the class 12 part 1, this is extremely important for your NEET examination because class 12th part 1 contains extremely high weightage chapters like electrostatics. 4 to 5 questions are asked from electrostatics chapter every single year. Let me just tell you, my dear NEET aspirants, 4 to 5 questions. Current electricity, 4 to 5 questions every single year. Magnetism, 3 questions every single year. EMI AC, 3 questions every single year. So this is the weightage of these chapters. So my recommendation to each and every single student is, if you are leaving any of the chapters in physics, but please do not leave these chapters. This is considered to be the highest weightage chapters in the entire NEET physics. So I'm going to complete all of these 6 chapters in the today's marathon from the scratch. Even if you have not studied these chapters before, doesn't matter. But I am going to start from the scratch and I'll take you to the level which you actually need. Is that clear, my dear NEET aspirants? So I would want you guys to smash the like button, because liking the session means marking the attendance. Okay, so you guys are supposed to like the session. You guys are supposed to mark the attendance. That is extremely important. That is extremely mandatory. Okay, that's great. That's great. And my dear NEET aspirants, one more important thing. I have already shared the PDF of the part 2 class 11th marathon. That is already shared in the Telegram. But let me just tell you, this is my Telegram channel. That is t.me/YAWARMANZOOR. You can search this link. You can join this Telegram channel. And I'll be sharing the notes, updates, every single thing. I share it over here only. Make sure everybody of you join this Telegram channel because this is very important. Now, without wasting your time, let's dive into the first chapter. That is what we call the electrostatics. This is the first chapter that we are supposed to study in the today's marathon. So, my dear NEET aspirants, the first one we need to discuss over here, that is charge. This is the first topic that we need to discuss over here, that is charge. In electrostatics, we basically talk about the charges. Now, my dear NEET aspirants, I want you guys to focus over here and understand each and every single thing from the scratch. Listen to me very carefully. I'm starting the session. Everybody of you, look at the board. Let's suppose I'm taking a comb over here. This is a comb I'm taking. Okay? The same example that I give every single time. And I'm rubbing this comb with my hair. You might have done this experiment in your school, at your home. I'm rubbing this comb with my hair. When I rub the comb with my hair, and if I place small piece of papers over here, small piece of papers, okay? Now, if I rub this comb or this pen with my hair, then if I take this comb near to the piece of papers, what is going to happen? Everybody will say, sir, this comb is going to attract these piece of papers. We have seen this. It is going to attract. So these piece of papers will stick to the comb. If I ask you the simple question, what if we don't rub the comb with our hair? What if we don't rub the comb with our hair? Do you think that these piece of papers will stick to the comb? No, sir. So means after rubbing the comb with your hair, these piece of papers are attracted. So why is it like that? It is because when you rub the comb with your hair, something is occupied onto this comb. Okay. And this, due to this thing, we say these piece of papers are attracted. And this something is what we call charge. So my dear NEET aspirants, when you rub the comb with your hair, charge is occupied onto the comb. Because of that charge, it attracts the piece of papers. So now, can I define the charge? Something. It is a property, okay, of matter due to which a body attracts other body, or we say repels also, due to which a body shows magnetic effects. Okay. So my dear NEET aspirants, charge is something due to which a body shows magnetic effects, due to which a body attracts other body or repels. That also we will be seeing. So it is because of the charge only one body attracts or repels the another body. That's what I can say in this particular case. Now there are two types of charge. We say positive charge and you have got negative charge. So there are two types of charges, positive charges and negative charges, my dear NEET aspirants. And when I place the positive charge over here, and when I place the positive charge over here, this is a positive and this is a positive charge. Like, let's suppose this is one pen. On this pen, positive charge is present. By any means, we have positive charge on this pen. And there is one more pen, positive charge is present on this pen also. We say these two pens are going to repel. So means like charges repel, positive will repel. And if you place a negative charge and negative charge close to each other, we say negative is also going to repel. If you place a positive charge over here and you place a negative charge over here, we say positive and negative are going to attract. So this is how we define. So we say unlike charges attract and like charges repel. One more important thing, my dear NEET aspirants. If I say symbol of charge, symbol, you say symbol of charge is Q. Like my dear NEET aspirants, if you say, sir, there is an object over here, you say mass of this object, you say M is equal to 2 kgs. What does this M mean? M signifies over here the symbol. M means the mass. Symbol of mass is M. And kg is SI unit. You do not measure the mass in liters, 2 liter mass, 3 liter mass, no, 2 kg, 3 kg. So this is what we call SI unit. So symbol is charge and SI unit over here is, SI unit in this particular case is coulomb. SI unit is coulomb. So my dear NEET aspirants, if I say I have got a comb over here, we say on this comb Q is equal to plus 2 coulomb charge. So this is how we write this charge present on the comb. Q is equal to 2 coulomb charge. Q means a symbol and coulomb means SI unit. Please tell me in the chats if this is crystal and clear to each and every single student. Come on guys, smash the like button if you're not like the session yet. Tell me quickly in the chats if this is crystal and clear to each and every single student. Quick. Tell me guys, is this clear? Is this clear? That's great. That's great. Let's move on to the first topic. That is what we call the Coulomb's law. Coulomb's law. What does Coulomb's law actually say? Listen to me very carefully, guys. I'll make you understand what is Coulomb's law all about. Let's suppose, my dear NEET aspirants, we have got two charges over here. This is plus Q1 and this is plus Q2. And they are separated by some distance R. Okay. You have two charges separated by some distance R. Whenever two charges are placed at certain distance, they apply a force on each other. And that force is called Coulomb's force. Arey bro, you have two charges, they repel each other. Positive, positive. Positive, negative attract each other. We say two charges repel each other with a force called Coulomb's force. Coulomb's / electrostatic force. Electrostatic force. So this Q1 is going to repel this Q2 with a force called electrostatic force. This Q2 is going to repel this Q1 with a force called electrostatic force. If you ask me, how much is this electrostatic force? You say this electrostatic force is K. Listen carefully. Then we say Q1. Then we say Q2 divided by, I would say, R square. K in this particular case is Coulomb's constant. So from now onwards, if somebody says, sir, how much force the two charges apply on each other, that is K Q1 Q2 by R square. K Q1 Q2 by R square. K is Coulomb's constant. Q1 is first charge. Q2 is second charge. R is the separation between the two charges. And this value of K, my dear NEET aspirants, is 1 by 4 pi epsilon naught. This epsilon naught is what we call permittivity of free space. Permittivity of free space. Please do remember whatever I say in this particular session. And value of epsilon naught is, we say 8.85 into 10 raised power minus 12 Coulomb square upon Newton meter square. This is the value of epsilon naught. You have to remember this. So K is equal to 1 by 4 pi epsilon naught. Epsilon naught is 8.85 in 10 raised power minus 12. Now guys, 1 by 4 pi, pi is 3.14. And epsilon naught is 8.85 in 10 raised power minus 12. If you put all these values over here, and then if you solve, the value of K will come out to be, 9 into 10 raised power 9 Newton meter square upon, we say, Coulomb square. This will come out to be the value of K in this particular case. This is the value of Coulomb's constant, and this is the value of epsilon naught. You can put all of these in the box. You can put all of these in a box. Okay, I believe this is clear. Two charges apply a force on each other, K Q1 Q2 by R square. Value of K and everything I have given you over here. Now, my dear NEET aspirants, what I want you guys to understand in this particular case, listen carefully. Listen carefully. Listen carefully. The first question that I am going to show you over here is this one. This is the first question. And in this question, you have a square, okay? And in the square, you have charge 2 coulomb, minus 2 coulomb, minus 2 coulomb, plus 4 coulomb. You are supposed to find the net force at 2 coulomb charge. At this plus 2 coulomb charge. This is plus 2 coulomb charge. You are supposed to find net force on plus 2 coulomb charge. Now, on this plus 2 coulomb charge, how many charges are going to apply the force? 1, 2, and this is 3. Listen carefully. This charge is going to attract this charge. Why? Because this is negative, this is positive. So it is going to apply the force towards itself. And let's call that force as F1. F1 is the force applied by minus 2 on plus 2. Can you tell me what is the value of F1 in this particular case, guys? You would say, sir, this F1 is K Q1 Q2 divided by R square. Because this is how we find the force between the two charges. So you'll say, sir, K. What is the value of Q1? That is 2 coulomb. What is the value of Q2? That is also 2 coulomb. Don't consider negative sign because you are finding the magnitude of force only. When you find the magnitude of force only, in that case, you consider minus 2 also as plus 2. Divided by R square. What is this distance? This is a square. This is 2 meters. So this is also 2 meters. So R square is 2 square. Now 2 into 2 is 4. 2 into 2 square is 4. So it will come out to be K. Value of F1 came out to be K. Now this minus 2 coulomb is going to attract it towards itself with a force. I call that F2. This F2 is also equal to K Q1 Q2 by R square. Now K. Q1 is 2. Q2 is minus 2. So this will be also as plus 2. Divide by R square. R square is 2 square. 2 into 2, 2 into 2. So this will also come out to be K. So value of F1 came out to be K. Value of F2 came out to be K. Now this positive charge plus 4 coulomb. Plus 4 coulomb is going to repel this plus 2 coulomb in this direction. With a force, I call that as F3. Because positive repel. Let's find the value of F3. F3 will come out to be K. Q1, Q2. So consider this Q1, that is 2. Q2 is 4. Divided by R square. If the side is 2, how much is the diagonal? 2 root 2. So we'll be saying 2 root 2, its whole square. Now guys, I can write it like this. 2 into 4 is 8. This is 8K upon. Now 2 square is 4 into root 2 whole square is 2. So 4 into 2 is 8. 8 cancel. So this will also come out to be K. So value of F3 is also K. Now boys and girls, I can make it like over here. Listen carefully. Listen carefully. Let's suppose you have over here, this is F1 in this direction. F1 is towards right and it is K. F2 is in the downward direction. This is also K. F2, this is also K. And F3 is something like this. This is also K. All the three vectors are K. All the three forces are K. You have to find resultant. Now see, if this is K and this is K, a resultant of this vector and this vector would be like this. And how do you find, listen carefully, how do you find the resultant of two vectors? Understand this very carefully. Resultant of two vectors, let's write R. Resultant of this and this will be under root of, how do you find the resultant of two vectors? Under root of F1 square, F2 square, that is K square plus, I would say K square plus A square plus B square plus 2AB cos theta. K square plus 2K into K cos of theta. What is the angle between this vector and this vector? This is 90, so cos of 90. Now guys, this term would become 0. So what I can say in this particular case, this resultant would be K square plus K square is root 2K square. Root 2K square. K square plus K square is 2K square. Now guys, tell me, square and root will cancel, so this will come out to be root 2K. So resultant of this and this came out to be root 2K. How do you find it? Under root of F1 square plus F2 square plus 2 times of F1, F2 cos of 90. Because angle between this one and this one is 90. Now, my dear NEET aspirants, can I write it like this? One vector is root 2K in this direction. Another vector is K. Now, you have mentioned the resultant of this one and this one. So, one vector is in this direction, that is root 2K. And another vector is in this direction, that is K. Now, tell me, what is the resultant of this one and this one? Guys, these two are in the opposite direction. When the two vectors are in opposite direction, in order to find the resultant, we subtract bigger vector minus smaller vector. Sir, what if they are in the same direction? Then we add bigger vector plus smaller vector. Sure, we can say net force will come out to be, this is bigger, this is smaller. So you will say root 2K minus K. So you can take K common, so it will be root 2 minus 1. This is the answer to the question. Please tell me in the chats if this is crystalline clear. Tell me guys, is this crystalline clear? Smash the like button if you don't like the session. Come on, quick. Is this clear? I need the signal in the chats. If you get any sort of problem at any question, I would recommend you one thing. Please listen carefully. If you get any sort of problem in any question, I would recommend you one thing. What is that? That is, you mark that particular question and watch the recording later on. Okay, because now is not the time to repeat these things, because these are the basic things. You would be able to understand these easily if you watch the recording later on of that particular question. So right now you are supposed to move on to the next question with me. Now, boys and girls, let's move on to the next pattern of question. This was the question asked in NEET 2019. Okay, absolutely, sir. Take a look, my dear NEET aspirants. 2-point charges A and B having charge plus Q and minus Q. Listen carefully. You have 2-point charges plus Q, and you have another point charge that is minus Q, plus Q and minus Q. They are separated by some distance, and this distance is R. Okay. Force acting between them is F. Force between this and this is F. Could you please tell me what is the value of F? K, Q1, Q2, that is Q square divided by R square. This is the force between the two charges. If 25% of charge of A is transferred to B, now this is very important. It says that if 25% of charge is transferred from A to B, so means positive 25% of Q is transferred to B. Okay. Now, if you transfer 25% from here to here, listen carefully. If I say I have got pen in my hands, how much pen? 50% or 100%? 100%. If I say this is a box, how much box? 100%, 50%, 75%, 100%. If it was 50%, I would have told you initially this is 50%. It is 100%. If I say this is a phone, means it is 100%. Absolutely. Now, if I say this is a positive charge, it means 100% positive charge. Now, if you are transferring 25%, how much will be remaining? 75%. 100 minus 25 is 75%. So what I can say in this particular case, my dear NEET aspirants, we say finally, if you are transferring 25%, how much will be the final charge? You can say finally charge on A will be 75%. Finally charge on A will remain 75%. 75% of Q. Now, how to write the 75% in mathematics? We write it 75 divided by 100. Sir, how to write 25%? 25 by 100. How to write 20%? 20 by 100. So 75 by 100 into Q. Now 25 3s are, 25 4s are. So this will come out to be 3Q divided by 4. This will be 3Q by 4. Okay. Now, my dear NEET aspirants, when you transfer the charge onto B, so you would say QB will come out to be, charge on B will come out to be. Already it was 100%, negative 100%. Guys, listen carefully, negative 100% of Q. You are transferring 20 plus 25%, positive 25%. This is very important. When you add charges, you have to add these along with the sign. Now, minus 100 plus 25, it will be minus 75. So, charge on B finally is going to be minus 75% of Q. Oh. Sir, what if this was positive? This was also positive. In that particular case, guys, if I'm saying this is positive, this is positive. So, you are transferring 25. So, here remains 75. So, how much charge will be here finally? Plus 100% plus 25%. That will be 125%. If both were positive, then I would have said this is plus 125%. But since this is negative, so that's why I'm subtracting. So this QB will come out to be, that is minus 75% will be negative of 75 by 100. Negative of 75 divided by 100 Q. Again, it will come out to be, that is minus 3Q by 4. Minus 3Q by 4. Then it says, if the charge 25% of A is transferred to B, then force between them will be. Now you have to find the force between these new charges. Now guys, this is first charge. This is 3Q by 4. And this is second charge, minus 3Q by 4. And distance between them is, I would say, R. If I say new force F dash, that will be K. Q1. Q1 is 3Q by 4. Q2 is minus 3Q by 4. Minus 3Q by 4. Divided by R square. Divided by R square. Now, my dear NEET aspirants, this F dash will come out to be 3 into 3 is 9. Then you have this K. Q into Q is Q square. 4 into 4 is 16. Divided by R square. Now, KQ square by R square is how much? F. So, this F dash will come out to be 9 divided by 16F. So, this is the force finally. This is a very important question. So, I would recommend you guys to please focus on this particular question. And one more question I'll give you of this sort as homework. Please do solve this question from your end. In this particular case, if we increase 10% charge on one charge and decrease 10% charge on another charge. So, here on first charge will be 90%. On second charge will be 110%. Please do solve this from your end because this is very important. This is your homework question. I hope this is crystal and clear. Now comes on to this particular question over here. Now comes on to this particular question over here. Okay. Now, boys and girls, listen to me very carefully. A particle of mass m, okay, carrying a charge minus q is moving around plus q2 charge. Okay. A particle of mass m carrying a charge minus q1 is moving around charge plus q2. Listen carefully. There is a charge present over here that is plus q2. Okay, this is very important. And there is another charge over here that is plus q1. So plus q1 is revolving around plus q2. So this is revolving around plus q2. This is plus q1. Okay, it is minus q1. Minus q1 and its mass is m. It is revolving. Okay. It is revolving around this charge. It is revolving around this charge. So this is the distance between the two charges. Let's suppose r, around this charge. In a circular path, find the time period. Time period means in how much time you guys are supposed to find out in how much time it is going to complete one circle. That is what you guys are supposed to find out. Now see, since you have these two charges, we say electrostatic force is going to act over here. Electrostatic force between the two charges, kq1 q2 by r square. Now my dear NEET aspirants, in this particular case, we say the charge is revolving in circular path. Whenever an object is revolving in a circular path, we say centripetal force acts on the particle. Whenever a charge revolves in a circular path, centripetal force is acting at that particular particle. Yes. Now, since you have two charges over here, q1, q2, so electrostatic force will act. Now, because of this electrostatic force, only the charge moves in a circular path. Remember this directly. And because of that circular path, we say centripetal force will act. So here, centripetal force will be equals to the electrostatic force. So two forces will act, electrostatic and centripetal. Both will be equal. Now tell me, electrostatic force will be equal to how much? K q1 q2 divided by r square. And centripetal force. What is the value of centripetal force, my dear NEET aspirants? Centripetal force will be, that is mr omega square. Because whenever a charge moves in a circular path, we say force acting will be centripetal force. And my dear NEET aspirants, listen carefully. Here, when on this charge, electrostatic force will act. Because of that electrostatic force, it will move in circle. And when it moves in circle, centripetal force will act. That's why I made them equal. Now tell me one thing. M means mass of this charge, R is the radius, and omega is the angular velocity, angular speed. Now I can say in this particular case, this omega square will come out to be, this is K, this is Q1, Q2 divided by, take this in the denominator, M into R cube, because R square into R is R cube. Now take this root over here. So omega will come out to be K Q1 Q2 divided by M R cube. And then you have this root. Now one thing I would want you guys to focus over here, guys. Omega is also equal to, that is 2 pi divided by t, where t is the time period. So you can write over here, this is 2 pi divided by t is equal to under root of K Q1 Q2 divided by M R cube. Now do the reciprocal. If you do the reciprocal, this will come out to be t divided by 2 pi is equal to under root of, take this in the numerator, it will be mr cube divided by K Q1 Q2. Now take this 2 pi over here, t will be equals to 2 pi under root of mr cube divided by K Q1 and Q2. This is going to be the time period of a particle in which it moves in a circle. This is the time period of the particle in which it moves in a circle, in which it completes the circular path. Guys, tell me in the chats, is this clear? Quick. Is this clear? Is this clear? Come on, everybody out there. Is this clear? Is this clear? Absolutely. Absolutely. Smash the like button if you're not like the session yet. Come on, do it. That's great. That's great. That's good. Now take a look, guys. Equilibrium of suspended charges. Equilibrium of suspended charges. I would want you guys to focus exactly over here. Equilibrium of suspended charges. My dear NEET aspirants, let's suppose you have this ceiling and there is a thread connected to the ceiling and there is a charge attached to it. Okay. This is charge, let's suppose plus Q, and this is charge, let's suppose plus Q. Now tell me one thing. Let's say initially these two charges were something like this initially here. Now since the two charges are positive, they repel each other. Now when the two charges repel each other, they go away from each other. When they go away from each other, they will come to rest at this particular position at an angle theta. When they come to rest, like it is like this. Yes, now they come to rest something like this. Now this position is what we call the equilibrium position. That's why we call the equilibrium of suspended charges. When the two charges come to rest, they remain here only. This is called equilibrium of two suspended charges. We are supposed to find the value of theta. At what angle the two charges are at rest or in equilibrium. We are supposed to find value of the charge Q. We are supposed to find value of X, distance between the two charges. We are supposed to find the tension in the string. These are the four questions. Find Q, theta, X, T if the charge is in equilibrium. If the charge is in equilibrium. Okay, yes. Now, my dear NEET aspirants, what I want you guys to understand over here is this length of the string is given as L. This length of the string is given as L. Listen carefully, I'll make you this understand. Everybody of you. First and the foremost thing, boys and girls, whenever the charge is in equilibrium, equilibrium means net force on the object is zero. If I say this charge is in equilibrium, it means net force on the object is zero. And here, condition will be given in the question. Theta is very small. Theta is very small. Means this angle will be very small, very small. So, whenever the charge is in equilibrium, so net force is zero. Net force is zero means upward force is equal to, guys, if I say there's a block, I'm pushing it from this side, I'm pushing it from this side. So we say this force is equal to this force. Okay. This force is equal to this force. So my dear NEET aspirants, we say net force in this particular case is zero. Okay. Now, if this is in the equilibrium, what is the force acting in the downward direction? You can say, sir, M into G. Now, this charge is repelling this charge with electrostatic force that is equal to K, Q1 into Q2, K Q square divided by X square. And from this side, you have got tension in the string. This. Because whenever you have a string, this is a rope. Sir, what kind of force is created in a rope? That is called tension force, this tension. So this is tension T. And if this is theta, boys and girls, listen to me very carefully. This will be also theta, vertically opposite. So this component will be T cos theta. Force has two components, horizontal component, vertical component. If theta is made from this side, so this will be T cos and this would be T sin theta. Now, boys and girls, listen to me very carefully. So you have resolved this tension. If I say how many forces are acting on this charge? 4. F, mg, T sin, T cos. Is the charge in equilibrium? Yes, charge is in equilibrium. What does that mean? That means upward force is equal to downward force. Left side force is equal to right side force. So what I can say in this particular case over here, you can say T sine theta has to be equals to, that is K Q square divided by X square. Then we say T cos theta has to be equals to M into G. So I believe this is crystalline clear. Now, my dear NEET aspirants, I want you guys to divide the two equations. So T and T will be cancelled. Sine by cos is tan theta. Tan theta will come out to be K Q square divided by X square into mg. This is the value of theta that you were supposed to calculate. This is how you calculate theta. This is the value of theta. This is the value of theta. This is the value of theta. Now, my dear NEET aspirants, I want you guys to understand one thing. If this is the value of theta, okay, at what angle they are in the equilibrium, this is the theta. In the question, theta is given as very small. So I can say if theta is very small, please listen carefully. If theta is very small, then my dear NEET aspirants, in mathematics we say sine theta will be equals to cos, sine theta will be equals to tan theta, or this tan theta will be equals to sine theta, will be equals to, I would say, theta. Guys, in mathematics we say if the value of angle is very small, then whatever is the value of tan, same will be the value of sine. So can I say, my dear NEET aspirants, by using this logic, so this I can write over here as sine theta will be equals to, that is K Q square upon X square into mg. Yes sir, 100% I can say it like this without a shadow of doubt. Now from this triangle, this is a triangle. Could you please tell me what is the value of sine theta? Sine theta. Guys, if this is theta, this would be base, this would be perpendicular, this would be a hypotenuse. If angle is made with this side, we consider this as base. If angle is made with this side, we consider this as base. Sine theta is perpendicular upon hypotenuse. Perpendicular is this. Now if total is x, how much will be this? X by 2. So this is x by 2. This is perpendicular. Hypotenuse. Hypotenuse is this L, x by 2L. So you can put it over here. You can write x divided by 2L is equal to K Q square upon X square into mg. This equation. Now, can I write it like this, my dear NEET aspirants? I can take it over here. Guys, see. X into x becomes x square. Sorry, x square into x becomes x cube. Take this 12 over there. So, it will be x cube is equal to 2L KQ square upon mg. This, okay, from here, 2L KQ square upon mg. So what will be the value of x? Value of x will be 2L KQ square upon m into g. So whole raised power 1 divided by 3, because if you take this 3 over here, so cube root. So my dear NEET aspirants, this is the value of x, and this was asked in JEE 2021. Please tell me in the chats if this is crystalline clear. Please tell me in the chats if this is crystalline clear. So we got the value of theta, we got the value of x. Now let's find the value of q. Okay, from this equation only. Consider this equation 1. From equation 1. From equation first. Guys, take this x square mg over here. It will become x square, it will become x cube m into g. X cube m into g divided by 2L is equal to KQ square. Take this K down. So Q square will come out to be x cube m into g divided by 2L. So Q will come out to be, instead of this, it will be square root. Square root will be 1 by 2. So x cube mg divided by, okay, this is K also, 2L into K whole raised power 1 by 2. This is the value of charge when the two charges are in equilibrium. And this was also asked in JEE 2021. I hope this is crystal and clear. I hope this is crystal and clear. So we got the value of Q. This is a combination of 4 questions actually. Q theta x. Now we have to find tension. Is this clear till over here? Is this clear till over here? Simple maths I'm doing over here, guys. Is this clear? Smash the like button. Is this clear? Give me the signal in the chats, everybody. That's great. Now, guys, one more important thing. Let's find tension. Let's find tension. Listen carefully. Listen carefully. Guys, I told you if you get any sort of confusion at any point, so please do watch the recording of that point later on, but not right now. Right now, you go with the flow. Right now, you go with the flow. Because these are the bigger chapters, heavy chapters that I need to complete. Let's find tension. Let's find tension. My dear NEET aspirants, what I want you guys to understand over here is, listen carefully. Let's suppose you have this charge which was in the equilibrium. What was the force acting from this side, sir? Electrostatic force. What was the force acting from lower side? Tension, mg. And force from this side was tension. These were the actual and original three forces, T, Fe, and mg. These are the components. Don't write the components. When you mention tension, then no need to mention the components. Now, guys, listen to me very carefully. You have these two forces. Can you tell me the resultant of this one and this one? So that will be this. This is R. How do you find the resultant of two forces? Sure, I told you. Whenever you have two forces at an angle of 90 degrees, the resultant in that case will be under root of F1 square, F2 square plus 2 times of F1, F2 cos 90. So this term would become 0. It is basically under root of F1 square plus F2 square. It is basically under root of F1 square plus F2 square. So it is under root of this square plus this square. So that would be F square plus, I would say, mg whole square. This. Now, my dear NEET aspirants, if the charge is in the equilibrium, means the force acting from this side would be equal to this side. If you're writing the resultant of this one and this one, that is R. Now these two are gone. Now you don't have to mention this again and again. Now this force is acting and this force is acting. If this charge is in equilibrium, force acting from this side will be equals to force acting from this side. So can I say this tension will be equals to R and will be equals to what? That is F square plus mg whole square. This is the value of tension. So this question was the combination of 4 questions. I hope everybody of you have understood each and every single thing from this one. Let's move on to the next one, my dear NEET aspirants. Let's move on to the next one. I hope this is crystal and clear. Now comes the concept of electric field. Tell me, is this clear? Everybody out there? Is this clear? Is Coulomb's law clear? That's great. That's great. Take a look. Electric field. I'll mention over here electric field. Take a look, my dear NEET aspirants. What does electric field actually mean? Let's suppose if I say we have a magnet over here. Let's suppose we have a magnet over here. This is a magnet. This is a magnet. This is a magnet. Okay. Now, if you place a coin or piece of iron over here, what is going to happen with the piece of iron or this coin? Sir, this magnet is going to attract this coin towards itself. If you place it here, it will attract. 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 So can I not say this magnet is basically creating some sort of field around it? And if in that field, any piece of iron is placed, it experiences force. So this field is what we call magnetic field. Magnetic field. So my dear NEET aspirants, a magnet creates magnetic field around it. And if in that field, a piece of iron or a coin is placed, it experiences force. It experiences force. As simple as that. Now, let's suppose if we place a charge over here, let's suppose this is plus Q. And I am placing one more charge over here, that is over here minus Q. Okay, or let's suppose this is plus Q naught. Q naught. Sure, another charge. What is going to happen with this Q naught? Sir, this positive charge is going to repel this positive charge, obviously. So if we place it over here, here also it will be repelled. If you place it over here, here also it will be repelled. If you place it over here, here also repelled. If you place it over here, here also it will be repelled. Now, my dear NEET aspirants, what I can say in this particular case, this charge also creates the field around it. If in that field another charge is placed, it also experiences force. And this field is what we call electric field. So, my dear NEET aspirants, a charge creates electric field around it. And a magnet creates magnetic field around it. And the charge which the force, due to this charge, the force which is created over here, that is electrostatic force. And this force you can consider over here magnetic force. So this is how we define electric field. So electric field is a space around a charge in which if any other charge is placed, it experiences force. It experiences force. Okay. So it is a space around a charge in which any test charge comes, in which if any test charge comes, it experiences force. Now see, you have positive charge and negative charge. Always remember this. What is the direction of electric field due to a positive charge? Direction of electric field due to a positive charge is always away from the charge, like this. Always away from the charge, away from the charge. And direction of electric field due to a negative charge is always towards the charge. This is, you guys need to understand. Direction of electric field due to positive charge is away. Direction of electric field due to a negative charge is towards the charge. Means if you place a positive test charge over here, it will be repelled. If you place a test charge over here, it will be attracted. That's what is the meaning of the direction of electric field. Absolutely, sir. Now see, if somebody says, sir, yes, I understand a charge creates electric field around it. How much electric field is created by a charge? Since this is a charge, how much will be the electric field created by this charge at r distance? Like, sir, since you say this charge creates field around it, so since you say this charge creates field around it, if I say how much is the field at r distance, what is the value of this electric field at r distance? Magnitude, intensity, how much? Sir, at r distance, electric field will be simply, guys, please do remember this directly. Please do remember this directly. Electric field will be kq by r square. K, Coulomb's constant. Q is the charge divided by r square. And what is the relation between electric field and r? We can say E is inversely proportional to r square. So what would be the graph? Graph would be rectangular hyperbola. As you move away from the charge, guys, E is inversely proportional to r square. As you move away from the charge, electric field decreases. I hope this is crystal clear to each and every single student out there. I hope this is crystal and clear to each and every single student out there. Tell me, guys, is this clear? Is this clear? So electric field due to point charges, KQ by R square. Now there is a question on this. That question is on graphs. Okay. Before that, I need to show you something. Sign conventions. Sign conventions. Listen carefully. They might ask you the question from the graphs. That's why I'm showing you this. Take a look. Let's suppose this is a positive charge. Tell me, due to the positive charge, electric field is away from the charge or towards the charge? Away. So this is away. Electric field direction is away from the charge. If the direction of electric field is away from the charge, away means this is electric field towards the right. If electric field is towards the right, we consider it positive. Towards the right. Towards the right. If the electric field is towards left, we consider it negative. Towards the left. Now, boys and girls, if you have a negative charge, due to this negative charge, we say electric field is towards the charge. So this is how we show it. Towards the charge, towards the charge. Now, boys and girls, if this is towards the charge, we consider this electric field as positive. If this is away from the charge, we consider this electric field as negative. Because this is towards right, this is towards left. Now see, how do we draw the graph? If I say plot the graph for two positive charges, this is plus Q and this is plus Q. So this is y-axis and this is x-axis. On y-axis, you will be placing electric field and here it would be minus electric field. So here, electric field plus E, here it is going to be minus E. And this in this particular case will be R. E versus R. Now, if I say, my dear NEET aspirants, due to one charge, electric field versus R is this graph, inversely rectangular hyperbola, but you have two charges over here. So you'll be making y-axis and x-axis. So first of all, you draw the sign convention. Sign conventions will be electric field due to this charge will be away from the charge. So this is away, this is away. This is towards right, positive, this is towards left, negative. So I'll make it over here. So this is electric field. This is positive, this is negative. And electric field due to this positive charge, away, away. This is positive and this is negative. Because this is towards the right, this is towards left. Now, what I want you guys to understand in this case over here is, my dear NEET aspirants, listen carefully. Okay. We say on the right of this electric field is positive. On the right side of this electric field is positive. Shall I make the graph from the upper side or lower side? Sir, since electric field is positive, I have to make the graph from upper side. So this would be the graph. It will be rectangular hyperbola always. Rectangular hyperbola always. And on the left of this electric field is negative. So graph is from upper or lower side? Lower side. So it would be rectangular hyperbola. It would be rectangular hyperbola. Now guys, on the right of this electric field is positive. So graph will be from upper side. So they will meet exactly at this point. This is called neutral point. That point where net electric field is 0. And if you make the graph from this side, electric field is negative. So the graph will be from this side. This is the graph between two positive charges, between E versus R. I hope this is crystal clear. And this question was previously asked in JE. Is this clear? Or tell me, or tell me. Is this clear? Smash the like button if you're not like the session. Now I'll give you a homework question. This is a question homework. Plot the graph between, this is plus q. Okay. This is plus q. And this is minus q. Plot the graph between plus q and minus q placed at r distance, between E versus R. This is your homework. Plot the graph between minus q and minus q. Okay, they are placed at r distance. So what is the logic? First draw the sign conventions. First draw y-axis, then x-axis, then sign conventions, then you can make the graph. This is your homework. Let's move on to this one. Electric field, okay. These are the infinite number of charges. Plus q, minus q, plus q, minus q, plus q, minus q. You have to tell me electric field at the origin, electric field at this point, due to all these charges. What is the electric field due to a point charge? Kq by r square. Now see, when I say net electric field at the origin, boys and girls, you will simply say electric field due to first charge, vector form, plus electric field due to second charge, okay, plus electric field due to third charge, plus electric field due to fourth charge, and so on. Now, my dear NEET aspirants, can I say in this particular case, if I write net electric field, guys, smash the like button. You would be simply saying, what is the electric field due to this charge? This is origin. With respect to the origin, it is at what distance? 1 meter. Electric field due to the charge, point charge is kq by r square. You'll be saying k, this charge is q, divided by, from here to here distance is r square, that is 1 square. 1 square is 1. Then plus. Electric field due to this charge at this point, it is minus. Why? Because we are doing vector sum. When you do the vector sum, you have to take the sign along. So minus kq by r square. R square is how much? 2 square. 2 square is how much? 4. From here to here it is 4. Then plus electric field due to this charge, kq by 4 square, that is 16, minus electric field due to that charge, kq by 8 square, that is 64, and plus so. Now, what I want you guys to understand in this particular case, my dear NEET aspirants, you can take this kq common. So you can write over here, net electric field will come out to be kq if you take common. Then we say 1. What remains here? 1 minus. What remains here? 1 by 4 plus 1 by 16 minus 1 by 64 plus so on up to infinity. Up to infinity. Now, boys and girls, this is what we call the GP series. This is called the GP series. GP series. So, if this is a GP series, you have to add. These are up to infinity, my dear NEET aspirants. So, there is a formula to basically add this sum. Sum is A upon 1 minus R. Sum is A upon 1 minus R. A means the first term. What is first term over here? 1. And R means the common ratio. How to find the common ratio? Common ratio means take any term. Let's suppose I'm taking 1 by 16. Divide it with the term which comes before it. That is minus 1 by 4. 4 ones are 4, 4s are 16. So minus 1 by 4. Now, if you put it over here, so this sum will be A. A is 1. 1 upon 1 minus 1 by 4. Minus into minus plus, plus 1 by 4. Array 1 minus R is minus 1 by 4. Okay. That is 1 plus 1 by 4. 4 into 1 is 4. 4 plus 1 is 5. 5 by 4. So this sum comes out to be 1 upon 5 by 4. So take it in the numerator, it will become 4 by 5. So sum of all of this came out to be 4 by 5. So you can say, my dear NEET aspirants, net electric field will come out to be. Now, this is KQ, this, and instead of all of this, you can write 4 by 5. If you write 4 by 5 instead of all of this. So don't you think, boys and girls, I can write net electric field would be K is 1 by 4 pi epsilon naught. This is 4 by 5 4 and 4 will be cancelled. So net electric field will be Q divided by 5 pi epsilon naught. Q divided by 5 pi epsilon naught. Tell me, boys and girls, is this clear? Is this clear? Come on, quick, 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 quick. Is this clear? That's great. That's great. Now, guys, see. One more important thing I just want to say. Electric field due to a ring on its axis. Take a look. Let's suppose, boys and girls, listen carefully. You have a ring. This is a ring. You have a ring. This is a ring. And charge is placed on this ring. By any means, we are placing the charge, distributing the charge on the ring. Is it going to create the electric field? Obviously, sir. Why? Because whenever there is charge, it creates electric field. If that charge is placed onto this ring is going to create the electric field. This ring is going to create the electric field. Now, if the radius of the ring is R and charge on the ring is Q, Q charge is distributed. This is center. From center to X distance, what is the electric field created? At X distance, electric field will be K, Coulomb's constant. Q is the charge on the ring. X, distance, divided by R square plus X square whole raised power 3 by 2. This is the electric field due to a ring at X distance. Now see, if I say you move from this point to the center, at center, we say what is the value of X? X will be 0 because you measure X from center only. If you put X is equal to 0 here, entire electric field will be 0. Electric field due to a ring at the center will be 0. Yes. Now, guys, case 1. Case 1. Case 1. Case 1. What I want you guys to understand over here, that is, let's suppose you have a ring over here. Let's suppose you have a ring over here. This is a ring. And you are supposed to find the electric field very close to the ring. Very close to the ring. This is the ring and this is the radius R. This is the ring. And a radius of the ring is, boys and girls, R. You have to find electric field at X distance. You have to find electric field at X distance. If you have to find electric field at X distance due to this ring, we say here X is much less than R. X is much less than R. This X is much less than R. So in this particular case, guys, see, if there is a quantity X which is very smaller when it compared to R, R is very big quantity. It is adding a very small quantity to a very large quantity. Will it create any difference? No. It is like adding a bucket of water to the ocean. Adding a bucket of water to the ocean, will it create any difference? No, sir. Because ocean has got billions of liters of water. So if you add one bucket, it is not going to make any sort of difference. So we can neglect this X over here. So what will be the electric field? E is equal to, sir, KQX upon, I would say, R square whole raised power 3 by 2. So we neglect this small quantity. If you add with some other quantity or subtract, we don't neglect here. It is going to create a difference in multiplication. Now this and this will be cancelled. So electric field will be KQ upon, I would say, R cube. KQX upon R cube. Now, close to the ring, electric field and X has direct relation. Very important point. Next case. Case 2. Very far from the ring. Very far from the ring. My dear NEET aspirants, if let's suppose there's a ring over here. If let's suppose there's a ring over here. If I ask you in this particular case, there's a ring. There's a ring. This is the radius of the ring. You have to find electric field here, very far. In this particular case, you can say R is much, much less than X. So what will you neglect? You will neglect this R. So it will be X square whole raised power 3 by 2. So electric field in this case is KQX upon, I would say, X square whole raised power 3 by 2. Now you can say this square and square will be cancelled. So it is KQX divided by X cube. X and here it will be X square. So electric field will be KQ divided by X square. So this is the electric field which is very far from the ring. And this electric field is inversely proportional to X square. So very far from the ring, electric field and X has inverse relation. So my dear NEET aspirants, if I try to make the graph between electric field versus X, listen carefully. This graph is very important. This graph is very important. If I make the graph between electric field versus X, so this is electric field, this is X. So value of X is 0 here. X is 0 means center. Now, if I place the ring here, so these points are close to the ring and these points are far from the ring. So very close to the ring, my dear NEET aspirants, graph will be the straight line. E is directly proportional to X. This is when X is much, much less than R. Close. And when you move very far from the ring, graph will come out to be like this. This is very far. E is inversely proportional to X square. When R is much, much less than X, or you can say when X is much, much greater than R. So join this with a smooth curve. Now, if this is a ring, this will create the electric field from front side also, from back side also. So left side electric field we take negative. From the upper side electric field is positive. From the lower side electric field is negative. So similar graph will be made from this side, but from the negative side. This. And my dear NEET aspirants, this is the point where electric field due to a ring is maximum. So this is electric field maximum. At what distance electric field is maximum? X is equal to R by root 2. R is the radius of the ring. If somebody says, sir, at what distance electric field is maximum? You say X is equal to R by root 2. And from this side, my dear NEET aspirants, this is the maximum electric field. So here X will be minus R by root 2. So electric field due to a ring, from this side will be maximum at R by root 2. From this side, minus R by root 2. Please tell me in the chats if this is clear. Quick. Smash the like button if you're not like the session. Quick. Is this clear? So this is graph between E versus X. Is this clear? Tell me quickly in the chats, everybody out there. Tell me. Now guys, see. Electric field due to a charged ring. Take a look, my dear NEET aspirants. Listen to me very carefully. Take a look. Listen, guys. Let's suppose there's a rod you have. This rod has length L and charge on this rod is Q. Length of the rod is L and how much charge is occupied onto this rod? Q. In this particular case, if I say, how much is the charge present on the unit length? How much is the charge present on the unit length? On small, if this is 10 meters, how much is the charge on 1 meter? Charge on unit length. That is called lambda. This lambda is charge divided by length, Q divided by L. Lambda is equal to Q divided by L. Charge per unit length. So this lambda tells you how much will be the charge present on the unit length of the rod. Yes. If this is area A. This is area A. Sheet. This is a sheet. On this sheet, charge is present. Yes. How much charge? Q. If I say how much is the charge present on the unit area? This is 10 meters square. What is the charge on unit area? 1 meter square. So you can say that is sigma. Sigma is equal to total charge divided by total area. How much is the total charge divided by total area? That will be charge on unit area. This is called charge per unit area. This is called linear charge density, surface charge density. Then you have a sphere. You have a sphere. This is a sphere. Okay. And charge present inside the sphere, boys and girls, is Q. Inside the sphere, charge is present as Q. This is Q. And volume of the sphere, my dear NEET aspirants, is how much? V. So in this case, charge is present on length. In this case, charge is present on area. In this case, charge is present in the volume. If I say how much charge is present in the volume, you say, sir, rho. Rho is equal to Q divided by V. Charge per unit volume. Q by V. Okay. So total charge by total volume. So simply I'm saying, if from now onwards charge is given on the rod, you'll be taking lambda. If charge is present on area, you'll be taking sigma. If charge is present in volume, you'll be taking what? I would say rho. You'll be saying rho. Now guys, take a look. If I say electric field due to a segment of ring. This is a ring, complete ring. This is a complete ring. Okay. And my dear NEET aspirants, if this is a complete ring, listen carefully. My dear NEET aspirants, if I say this portion of the ring is called a semicircular ring. This portion of the ring is called chord. This is called chord. Cool? Yes. And if I say, okay, in one complete ring, how many semicircles? 1, 2. Chords, 1, 2, 3, 4. If I say you cut this portion of the ring, this portion of the ring is called segment of ring. Some portion of the ring. Some portion of the ring. Now you are taking some portion of the ring and charge per unit length on this is lambda. Unit charge per unit length is lambda. And this is radius R, this is radius R. Join this with one end of the wire, join this with another end of the wire, this is R. Angle between the two is theta. If somebody says, sir, will it create electric field? Obviously. Why? Because charge is present on this. So how much electric field it is going to create, boys and girls? It will create the electric field that is 2k lambda by R sine of theta by 2. Now, my dear NEET aspirants, if you have a semicircular ring like this, semicircular ring, you have to find electric field here. Join this with one end of the wire, join this with another end of the wire. So this angle is theta. And theta is how much in this case? 180. Now this is the general expression. Can you find electric field due to this? So you'll be saying, sir, electric field will be 2k lambda by R. R is the radius. Then you say sine of 180 by 2. Sine 180 by 2. 180 by 2 is 90. Sine 90 is 1. So this is 1. So electric field will be 2k lambda by r. So this is the electric field. This is the electric field due to a charged ring. This is the electric field due to a charged ring. Which ring? Semicircular ring. If you have a cord, this one. Now you have to find electric field due to this cord. Charge density is lambda at this point. Join this with one end. This is radius r. Join this with another end. This is radius r. Angle between the two is 90. So can I say, boys and girls, electric field will be simply 2k lambda by r. Then I can write sine of 90 by 2. Sine of theta by 2. Sine 90 by 2 is sine 45. So electric field will be 2k lambda by r. Sine of 45. Sine 45 is 1 divided by root 2. Now do one thing, boys and girls. Multiply with root 2 and divide with root 2. Now root 2 into root 2 becomes 2. Root 2 into root 2 is root 2 whole square. That becomes 2. So I can say this 2 will be cancelled with this 2. Electric field will be root 2k lambda by r. So due to a cord, electric field is root 2k lambda by r. Okay. Now, what is the electric field this portion at center? Join this with one end of the wire. This is radius r. Join this with another end. This is radius r. This angle over here is theta is 120. Now, you'll be using again the same formula. That is 2k lambda by r sine of 120 by 2. 120 by 2 is sine 60. So electric field will be 2k lambda by r sine of 60. Sine 60 is how much? Root 3 by 2. 2 and 2 will be cancelled. So electric field will come out to be root 3k lambda by r. Root 3k lambda by r. Root 3k lambda by r. Okay. Cool. Yes. What is the electric field due to this at the center? Now you see, guys, in this case, charges present something like this. Charges present something like this. Now, clearly you can see in this case, charge is distributed in semicircular rings. So, better is to consider two semicircular rings over here. Guys, charge is distributed in the semicircular rings. In upper semicircular ring, charge is positive. In lower semicircular ring, charge is negative. So, it is better if you consider this as semicircular ring, this as semicircular ring. Now, electric field due to the upper portion at the center would be away from the charge. Electric field due to the lower portion would be, guys, due to this positive charge, electric field is away. And this is a semicircular ring. It will be 2k lambda by r. Because recently you have seen electric field due to a semicircular ring is how much? 2k lambda by r. So here it will be 2k lambda by r. Due to the lower semicircular ring, electric field is towards. And this is also 2k lambda by r. Boys and girls, see. Due to this portion, electric field is 2k lambda by r. Due to this portion, electric field is 2k lambda by r. But due to this, it is away. Due to this, it is towards. That's why. So I can say net electric field would be 2k lambda by r plus 2k lambda by r. So it will be 4k lambda divided by r. 4k lambda by r. 4k lambda by r. 4k lambda by r. Okay. If I say you have this question, this is a semicircular ring. Now, here this portion of the ring has got positive charge. This portion of the ring has got negative charges. Don't you think that logic says it is better to break this into two chords? Don't you think that logic says it is better to break this into two chords? Yes. This is one chord and this is another chord. Now tell me, due to this chord, positively charged chord, electric field at this point is away from the charge or towards the charge? Away from the charge. How much? root 2k lambda by r. This is root 2k lambda by r. Due to this chord, electric field at this point would be how much? Root 2k lambda by r. Okay. Now the resultant of this one and this one would be like this. This would be r. Because this is chord, it will be, due to this, it is root 2k lambda by r towards the chord. Due to this chord, it would be root 2k lambda by r. Now due to this and this angle is 90, boys and girls. How to find the resultant? Tell me. Under root of one vector square plus another vector square. Yes. f1 square plus f2 square, 2 times of f1, f2 cos 90. Cos 90 will be 0. So under root of one vector square, root 2k lambda by r, its whole square, plus this square, root 2k lambda by r, its whole square. So this is how many times? 2 times. So this would be under root of this square, this plus this. So it is 2 times of root 2k lambda by r, its whole square. Square and root will cancel, but 4 it will remain. So it will be root 2. Then we say this root 2 k lambda by r. Guys, for this portion, root and square will cancel. But for this 2, root will remain. So root 2 into root 2 is 2k lambda by r. This would be the electric field at the center. Okay. Are you getting me, boys and girls? Is this clear? Is this clear? Oh? Tell me, is this clear? Smash the like button if you don't like the session yet. Quick. Now guys, take a look. Electric field due to an infinitely long wire. Let's suppose you have an infinitely long wire. Directly remember, and its charge density is lambda. This is up to infinity, this is up to infinity. Due to an infinitely long wire, electric field is 2k lambda by r. Directly remember. R is the distance where you have to find the electric field. If you have semi-infinite wire, semi-infinite wire means which has one end finite and another end is going till infinity. This is called semi-infinite. So at r distance, electric field will be root 2k lambda by r. That's it. That's it. Now take a look at the question. This is the question which was asked in NEET 2019. You have two infinitely long wires. You have to tell me electric field due to these two wires at r distance, from here to here r, from here to here r. So total is 2r. This is infinity, this is infinity, this is infinity, this is infinity. If I say, my dear NEET aspirants, net electric field would be due to this wire, electric field at r distance would be away from the wire. How much? How much? 2k lambda by r. Because this is infinite wire. Due to this wire, electric field at r distance will be 2k lambda by r. Because this is infinite. Now, why did I show you away from the charge? Because this is positively charged wire. This is negatively charged wire. That's why due to this it is towards, due to this it is away. Now tell me, these two vectors, these two electric fields are in the same direction. So net electric field would be this plus this. So that would be 2k lambda by r plus 2k lambda by r. So total will be 4k lambda by r. So total would be 4k lambda by r. Total would be 4k lambda by r. Electric flux. Electric flux. Electric flux. Take a look, boys and girls. How do we define electric flux? See, let's suppose, my dear NEET aspirants, you have a surface over here. This is a surface. You have one more surface over here. This is a surface. Means there is a sheet placed over here. There is one more sheet placed over here. And I'm placing a charge at this point, a bigger charge. Now, due to this charge, my dear NEET aspirants, electric field will come out. So this is the electric field due to this charge. Electric field due to a charge, we represent with electric field lines. Now, this is the electric field. This is the electric field. This is the electric field. Now, this is the electric field. If I say, if you take both the surfaces, how many number of field lines are crossing through first surface? You say 1, 2, 3. How many number of field lines are crossing through second surface? 1, 2, 3, 4, 5. So I can say flux through the first surface is 3. Flux through the second surface is 5. So how do you define flux? Flux is the number of field lines crossing the surface perpendicularly. Number of field lines crossing the surface perpendicularly. This is how you define flux. And this flux, it is equal to, if somebody asks you, how do you find the flux? So you say this flux means phi. This phi is equal to electric field into area into cos of theta. Okay, this is the flux created through the surface. How much is the field crossing the surface? What is the area? And what is the angle between electric field and area? So you can say where theta is the angle between E and A. So you can also write it like this. This phi is equal to electric field E dot A. E dot A. Because AB cos theta is A dot B. Okay. So EA cos theta means E dot A. EA cos theta means E dot A. Now guys, let's suppose I say, listen to me very carefully. Let's suppose I say, you have a closed surface over here, this cylinder. And inside this cylinder, you have a charge present. Listen carefully. Inside the cylinder, you have a charge present. Now, what I'm trying to say is that due to this charge, electric field is going to come out of the charge, something like this. Electric field is going to come out of the charge, something like this. Yes. Electric field is going to come out of the charge. Now, this electric field is crossing the walls of the cylinder. So this is going to create flux. Now, if I say you calculate flux, it will take us huge time in the calculation of the flux here. So directly you remember, Gauss said, if a charge is placed inside a closed surface, how much will be the flux through the closed surface? You say, sir, flux through the closed surface. This is closed surface. Closed surface can be any surface. Is equal to, how much is the charge inside divided by epsilon naught? That's it. It says flux through any closed surface is equal to the charge inside upon epsilon naught. Let's suppose you have 10Q inside. What will be the flux through closed surface? Flux through this closed surface will be charge inside. That is 10Q divided by epsilon. That's it. Take a look at this. Take a look at this. Flux through the closed surface is 10Q by epsilon naught. Q inside divided by epsilon. Now take a look. Let's suppose, my dear NEET aspirants, you have a cube over here. And you have placed a charge on the surface, on the face of the cube. This is a cube. You have placed the charge on the face of this cube. It is not inside. This charge cannot be considered as the enclosed charge. This charge cannot be considered as the enclosed charge. So in order to make this charge enclosed, what we do here is we add one more cylinder here. Sorry, one more cube. Add one more imaginary cube over here. Imaginary. In reality, you don't do it. You are adding one more imaginary cube over here. Now, guys, this charge behaves like an enclosed charge. Why? Because now this charge comes inside of these two cubes. So this is done when charge is not enclosed. So, my dear NEET aspirants, when you have the charge placed on the face, I would say add one more charge. Sorry, add one more cube. So, enclose the charge. Now, my dear NEET aspirants, for this charge, closed surface will be made up of how many cubes? 2. So, you can say flux through closed surface. Now, this flux will be flux through 2 cubes. Like here, boys and girls, for this charge, closed surface will be made up of how many cubes? 1. So, you can say this flux through closed surface is also equal to flux through 1 cube. It's one and the same thing. But here, it is made up of 2 cubes. That's why I'm writing 2 cubes. It will be how much? Q by epsilon naught. If flux through 2 cubes is Q by epsilon naught, so flux through 1 cube will be how much? Half of this. If flux through 2 cubes is 100, flux through 1 cube will be how much? 50. So you can say flux through 1 cube will be Q divided by 2 epsilon. Half of this na, Q by 2. So when the charge is present on the face, you directly remember you have to add one more charge to make the charge enclosed. If the charge is present on the edge, this is the edge. This is called a face. This is edge. So in this case, we add 1, 2, 3. 3 more cubes. Add 3 more cubes to make the charge enclosed. Now tell me, if you are adding 3 more cubes, now you can say flux through the closed surface will be flux through how many cubes? 1 is already there. 3 you are adding. 3 plus 1 is 4. So this will be flux through 4 cubes. And it will be Q by epsilon naught. So Q divided by epsilon naught. This is flux through 4 cubes. Now this is flux through 4 cubes. You have to find flux through 1 cube. So flux through 1 cube will be Q divided by 4 epsilon. Now if the charge is present at the corner, so we say add 7 more cubes. Guys, please remember directly. 7 more cubes to make the charge enclosed. So you can say flux through the closed surface will be flux through 7 cubes. Flux through the closed surface will be, oh, not 7. 7 plus 1 is 8. Total of 8 cubes. It will be Q divided by epsilon naught. So this flux through 8 cubes. Now, if you have to find flux through 1 cube, that will be Q divided by 8 epsilon naught. I hope this is crystalline clear. I hope this is crystalline clear. Is this clear? Now take a look. This is a cylinder over here. This is a cylinder over here. And in this cylinder, my dear NEET aspirants, it has got how many surfaces? 3. This is a cylinder. It has got how many surfaces? 3. 1, 2, and 3. And it says that, guys, charge is present inside. Because of this charge, field lines will come out something like this. Because of this charge, field lines come out something like this. Now, these field lines cross all the 3 surfaces. All the 3 surfaces. It says flux passing through the curved surface, right? Curved surface. Curved surface is phi naught. Flux passing through this curved surface is phi naught. Guys, this is called curved surface. This is plane. This is plane. Flux passing through the curved surface is phi naught. You have to tell me flux through one plane surface. Now listen carefully. In this particular case, if I say flux through the cylinder, tell me one thing. You will say, sir, flux through the cylinder. Cylinder is made up of 3 surfaces. 2 plane, 1 curved. So it means this flux will be through 2 plane surfaces and 1 curved surface. So I can write flux through 2 plane surfaces plus flux through 1 curved surface. So this will be actually the net flux through the cylinder. And cylinder is a closed surface. How much will be the flux through closed surface? Sir, that we know, that is Q divided by epsilon naught. Oh, cool. Now flux passing through the curved surface is phi naught. So this is given as phi naught. If this is given as phi naught, so you'll say flux through 2 plane surfaces plus this is phi naught is equal to Q by epsilon naught. Alright, total net flux through the closed surface is Q by epsilon naught. So now here closed surface is made up of 2 plane and 1 curved. So 1 curved is phi naught. Take it over there. So flux through 2 plane surfaces will be, if you take it over there, Q by epsilon naught minus phi naught. So this is flux through 2 plane surfaces. If I say flux through 1 plane surface, that will be half of this. Because this is through 2. Through 1 surface, it will be half of this 1 by 2 of Q by epsilon naught minus, I would say, phi. I believe this is crystal and clear. This is the flux through 1 plane surface. This is the flux through 1 plane surface. Okay, yes. Now take a look, guys. This is important. Electric field due to a hollow sphere or metal sphere. Listen carefully. Guys, hollow sphere means football. Hollow sphere means football. Hollow sphere means football. Hollow means which is hollow from inner side. Mass is present on the surface only. Okay. And solid sphere means cricket ball. Cricket ball is not hollow from inner side. Cricket ball is filled. Yes. Now guys, take a look. If I say you have a football and you distribute the charge on the football, it will be distributed on the surface. Sir, how much will be the charge inside? Inside the football, it will be 0. So in case of a hollow sphere, charge is stored on its surface. Charge is stored on its surface. Now, if there is a charge, there is electric field. You have to tell me the electric field due to this hollow sphere at outside point, at small r. Okay. And then on the surface, then inside. Guys, see. Outside, directly you remember, due to a hollow sphere, electric field is kq by r square. Sir, but this is the formula of point charge. Yes, because from a very large distance, let's suppose if I give you a big balloon and you are standing 1 kilometer far from me, away from me. If I say 1 kilometer away Do you think that it will look like a balloon to me, or it will appear to me as a point? It will appear to me as a point. From a very large distance, it looks like a point. So that's why from a very large distance outside, we consider this a point charge. So that's why electric field is kq by small r square. Now, if you move from this surface to from this point to surface, now this is the value of small r. Small r becomes capital R. At surface, small r is capital R. So put the value of small r is capital R. So it becomes kq by capital R square. And if I say, boys and girls, inside electric field is 0. Why? Because there is no charge inside. So effect of this charge inside will be 0. Keep this thing in your mind. Now if I make the graph, guys, see. Electric field inside is 0. Means from center to surface electric field is 0. Now see graph, E versus R. If this is a sphere, from center to surface electric field is 0. So graph will be on this line. So this is surface. On surface, value of small r is equal to capital R. And electric field outside the surface is rectangular hyperbola. Because electric field outside the surface is inversely proportional to r square. So guys, directly you will be remembering this graph would be E versus R. E versus R. It would be like this. Electric field inside, electric field outside. Inside it is 0, outside it will be rectangular hyperbola. Now you have electric field due to a solid sphere. Okay. Hollow sphere is also called metal sphere, conducting sphere. This is called non-conducting sphere. In case of solid sphere, charge is filled inside. Charge is filled inside. In case of a solid sphere, charge is present inside also. In case of a solid sphere, charge is stored in its volume. Now guys, you have to tell me electric field outside, surface, inside. See, from a very large distance, either if it is hollow sphere or it is a solid sphere, both will appear to you as point charges. So that's why, due to this sphere, at our distance outside, electric field is how much? kq by small r square. Okay. Now at surface, if you move, and small r is the distance from the center to that point. Now if you move from this point to the surface, value of small r becomes equal to capital R. So on the surface, electric field is kq by capital R square. And when I say inside at what distance? From center to small r. Sir, this is also small r, this is also small r. Yes, small r is variable. For outside point, small r is greater than radius. For inside point, small r is less than radius. So inside electric field will be kq, q is the charge, into r. R is the distance of that point from the center. Okay, divided by r cube. R is the radius. Capital R cube is the radius. Now see, electric field inside, guys, electric field inside is directly proportional to small r. So inside graph will be straight line. Electric field outside is inversely proportional to small r square, rectangular hyperbola. Now see. So this is where r is 0. And here r is equal to capital R. This is the surface. At surface, electric field is equal to, at surface, small r is equal to capital R. From center to surface, it is directly proportional to r. And outside, it is inversely proportional to r square. Very important graph. Very important graph. There is a question which was asked on this in JEE Advanced 2014. I need to show you this particular question over here. Before that, you tell me, is this clear? Tell me, guys, is this clear? And smash the like button if you're not like the session yet. Quick. Smash the like button. Quick. Now guys, take a look. So you have to tell me the electric field at point P in all the three cases. These are the solid spheres. And this solid sphere is having radius r by 2, charge q. Radius r, charge 2q. Radius 2r, charge 4q. And you have to find the electric field at r distance. Guys, see, in all the three cases at r distance. If r is the distance where you have to find the electric field, so don't you think for this sphere, r will come out to be the outside point? R will be the outside point. Why? Because its radius is 2r, r by 2. So r will be outside. Its radius is r, so r will be on the surface. Now if radius is 2r, so r will be inside. Chalo, we'll apply over here. So electric field at point 1. So I can say we'll use kq divided by small r square. Electric, we'll use outside formula. Electric field due to a solid sphere outside is kq by r square. Now see, charge is k is k, charge is q divided by, what is the distance from this point to that point, small r, that is capital R. So capital R square, this is outside. Absolutely. Now in the second case, I would write kq divided by capital R square. R is the radius, because potential electric field on the surface is kq by capital R square. Kq by capital R square. So it is going to be k. Charge on this is 2q divided by distance from this point to this point. That is R square. This is surface. And in the third case, I can say inside, that is kq into r divided by r cube. So inside the solid sphere, this is the electric field. Now small r is the distance from the center to that point. So here, this is the value of small r and this is the value of radius. So you can say this is k and charge on this is 4q. And small r means capital R here upon radius cube. So 2r whole cube, that will be 8r cube, because 2 cube is 8. So 4 1s are 4 2s are r, and this will be r square. So it will be kq upon 2r square. This is the electric field in all the three cases. This is the electric field in all the three cases. I believe this is crystalline clear. I believe this is crystalline clear. Now guys, take a look in this particular case. Motion of a charged particle in uniform electric field parallel to the field. Listen carefully. Listen carefully. Let's suppose you have the electric field over here. I would want you guys to give me 100% attention. You have the electric field over here. Okay, this is the electric field. And in this electric field, you are placing a charge q and its mass is m. In this electric field, you are placing a charge q and its mass is how much? Its mass is m. Absolutely, sir. Charge q and mass is m. Okay. Charge q and mass is m. Yes. Now, guys, this is the external electric field. Like this external electric field, you are placing a charge. Whenever I place a charge in the external electric field, first thing you must remember, force acts on it. And that force is equal to Q times of E. Q is the charge, E is the electric field. Directly remember. That force is equal to Q times of E. And if the charge is positive, force will be in the same direction of electric field. And if the charge is negative, force will be in the opposite direction of electric field. This is you guys are supposed to remember. Now, whenever force acts on a body, it will have acceleration array, because we say F is equal to m into a. So acceleration will be force divided by mass. Now, this is the acceleration of the charge. This is the acceleration of the charge. So QE divided by m. Q is the charge, E is the electric field, m is the mass of the charge. Now, guys, tell me, if force is acting on this charge, it will start moving. Array, you are pushing an object, it starts moving. So we say after some time t, what is the velocity of this charge after time t? So I can write over here, my dear NEET aspirants, velocity after t, after time t. This is the velocity of the charge after time t. QE by m into t. Q is the charge, is electric field, m is mass, t is time. After 2 seconds, put t is equal to. Now, what is the relation between V and t? V is directly proportional to t. And if I say what is the graph between V and t? Guys, graph will be the straight line. V is directly proportional to t. Now, my dear NEET aspirants, you tell me one thing. If force acts on this body, it will move. So it will cover some distance. What is the distance covered by this charge after time t? Displacement in time t. Displacement will be 1 by 2. Charge Q, E electric field divided by mass M into t square. If I say in this particular case, my dear NEET aspirants, you can say this displacement is proportional to t square. S is proportional to t square. What will be the graph between S and t? If y is proportional to x square, graph is upward parabola. If S is proportional to t square, graph will be upward parabola. This is the graph. Now, guys, if somebody says, what is the momentum of this charge after time t? Momentum after time t. Momentum is QE into t. Q is charge, E is electric field, t is time. So clearly I can say in this particular case, this momentum depends upon time directly. So if somebody says, what is the graph between momentum versus time? It is going to be directly proportional. P is directly proportional to t. P is directly proportional to t. If I say, what is the kinetic energy of this charge after time t? I'll write over here kinetic energy after time t. So kinetic energy after time t will be Q square, E square, T square divided by 2m. Now tell me, guys, this kinetic energy is proportional to T square. What is going to be the graph between kinetic energy and T? It would be like this upward parabola. Okay? Yes. Then velocity after displacement x. Velocity after displacement x. So velocity of this charge, guys, two things. If I say velocity after 2 seconds, it means velocity in terms of time. If I say velocity after 2 meters, this is velocity after displacement. So that will be v square is equal to 2qe by m into x square. Take the square over here. V will be 2qe x divided by m. It's root. It's root. Now, guys, we can say v is proportional to root x. So what is going to be the graph v versus x? When v is proportional to root x, graph will be downward parabola. Graph will be downward parabola. Graph will be downward parabola. Okay. Yes. Now take a look at this. Find the time of fall of electron in comparison to the time of fall of proton. This is a question of NEET 2019. 80. See, guys, what does the question say? In this particular case, listen, guys, there is an electric field in the upward direction. Electric field is upward. And in this upward electric field, you are placing a charge, positive charge, proton. Oh, this is electron. My dear NEET aspirant, this electron is released. It will fall down. This electron is released. It will fall down. Yes. So it takes some time in falling down. That is TE, time of fall of electron. Now, there is same electric field over here. Whatever is the value of electric field here, same is the value of electric field over here. But the direction of electric field is downward. And in this downward electric field, you are placing a proton. On this electron, forceful negative charge. On negative charge, force acts opposite to the direction of electric field. On positive charge, force acts in the same direction. Now, if this proton is released, it will fall down. It will take time of fall of proton. How much height it will cover? H. How much height this will cover? H. How much electric field? E. How much electric field? E. You have to compare which of the two will take less time or more time. Take a look. We say as simple. We say S is equal to ut plus 1 by 2 at square. If we release an object, we consider its initial velocity 0. Releasing means you release this. Throwing means you throw this. In case of throwing, initial velocity is not 0. When you release the object, we consider initial velocity 0. Here also, here also. So initial velocity is 0. And how much is the displacement from top to bottom? That is h. Initial velocity is 0. That is 1 divided by 2. What is the acceleration of the electron? What is the acceleration of a charge? QE by m. You can say QE divided by m into t square. Now take it over here. So this will be 2m into h divided by 2m into h divided by q into e. This will be equals to t square. So value of t will be under root of 2m into h divided by q into e. Now you tell me one thing, boys and girls. I would want you guys to focus over here. In these two cases, what is constant? Sir, electric field. Same electric field. Electric field is same. Constant. This is coming down height h. This is coming down height h. Height is same. Okay. Charge on electron is 1.6 into 10 raised power minus 19 coulomb. Charge on proton is 1.6 into 10 raised power minus 19 coulomb. Even charge on both is same. Okay, charge on both is same. So this is same, this is same, this is same. So I can say this T only depends upon root of mass. Okay? Time cannot depend upon the constant term. So time depends upon the variable terms. That is mass. Because mass of electron and proton is different. So you say mass of electron is much less than mass of proton. So time is directly proportional to mass. The one which has less mass will take less time. So time of fall of electron is much less than time of fall of proton. So electron will take less time in falling. Proton will take large time in falling. So this is basically the question which you guys are supposed to find out. I hope this is crystalline clear. I hope this is crystalline clear. There is one more question which I would like to show you on this pattern. If proton, deuteron and alpha particle are placed in a uniform electric field, proton, deuteron, alpha particle. Okay. Guys, see, proton has got charge E, deuteron has got charge E, alpha particle has got charge 2E. 2 times charge of proton. Proton has got mass m, deuteron has got mass 2m, 1h2. Alpha particle has got mass 4m. Please do remember this table directly from now onwards. Mass of alpha particle is 4 times mass of proton. Mass of deuteron is 2 times mass of proton. Now see, it says if proton, deuteron and alpha particle are placed in the external electric field. This is the external electric field. Proton is placed here. Deuteron is placed over here. Alpha particle is placed over here. Now, my dear NEET aspirants, in this particular case, you have to find the ratio of momentum. Find the ratio of momentum. We'll find the ratio of kinetic energy also. Guys, we say momentum of the charge is equal to QE into T. Now tell me, for these three, listen carefully. They are placed in the same electric field. Electric field is same, even time is same. Because if you say Momentum of this after 2 seconds. For this also you're asking after 2 seconds. For this also after 2 seconds. Electric field is same. Time is same. So this momentum only depends upon charge. So you can say momentum of proton is to momentum of deuteron is to momentum of alpha particle. You will be writing it like this. Momentum of proton. So it depends upon charge. Charge on proton is E and 2E. You can write E is to 2E. So now this would be E and E will be cancelled. So it will be 1:2. This would be the ratio. Let's talk about kinetic energy. Guys, when we say kinetic energy, we say kinetic energy is equal to Q square, E square, T square divided by 2m. This is the kinetic energy of a charged particle after time t. Okay. Now tell me, which of the things are constant? I think electric field is same. I think time is same. Mass is not same. These two quantities are same. So this kinetic energy is only proportional to Q square divided by m. This kinetic energy is only proportional to Q square divided by m. Okay. Kinetic energy is only proportional to Q square by m. So can I say kinetic energy of proton is to kinetic energy of deuteron is to kinetic energy of alpha particle is equal to Q square by m. What is the charge on this proton? That is E divided by m. E square by m is to charge on this E square by 2m is to charge on this 2E square, 2E whole square. That is 4E square by 4m. What can you cancel over here? Sir, I think E square by m, E square by m, E square by m. 4 ones are 4 ones are. So what remains over here? 1 is to 1 by 2 in this is to 1. Multiply over here. 2 into 1 is 2 is to 1. 2 into 1 is 2. 2 is to 1 is to 2. This would be the ratio. This would be the ratio. Is this clear? Tell me quickly in the chats, is this clear? Is this clear? Guys, smash the like button if you're not like the session. Quick, make it fast. Now guys, take a look. Electric dipole. Electric dipole. Electric dipole. See guys. Electric dipole. When two equal and opposite charges are placed at very small distance, it forms dipole. When two equal and opposite charges, like this is a minus Q charge, this is a plus Q charge. Two equal and opposite are placed at certain distance, it forms electric dipole. Like if I say minus 4Q plus 4Q, is this a dipole? Yes, equal and opposite. dipole has a dipole moment. Guys, directly remember, dipole moment kind of gives the strength of the dipole. And this dipole moment is equal to magnitude of charge multiplied by separation between the charges. Like, if I say, listen carefully, guys, you have a charge over here, minus 4q. You have a charge over here, plus 4q. Distance between them is d. If I ask you what is the dipole moment will be magnitude of charge. Magnitude of charge is 4q. Separation is d, 4qd. Oh, yes or no? And this dipole moment is always from negative charge to positive charge. Dipole moment is always from negative charge to positive charge. Okay? Yes. Now, guys, listen to me very carefully. The question is something like this. And we make it like this. Guys, see. This dipole moment is from negative charge to positive charge. So this would be the direction. Now, see. The question says find the net dipole moment in this particular case. Find the net dipole moment in this particular case. Okay, find P net if dipoles are made along the diameter. Okay, see guys, if I say, sir, do you see any dipoles over here? 100%, sir, I can see the dipoles over here. Minus q plus q. Minus q plus q. So one dipole is this, another dipole would be this. Call this as P and call this as P because dipole moment is from negative to positive, from negative to positive. Minus q to plus q. And you have to make the dipoles along the diameter, along the diameter. Now see, one dipole is in the downward direction. Another dipole is in the forward direction. This is P and this is P. So you can say resultant of this and this. This dipole and this dipole would be this. This is going to be P net dipole moment. Now, how can I find the value of this dipole moment? Guys, see, dipole moment will be, if this is P, this is P. This would be under root of, I have told you this, under root of this factor square plus this factor square, P square plus P square plus 2 times of P, cos 90. Cos 90 is 0. So that term would be. So this will be 2p square and then we say root. Square root will cancel. This will be a root 2p. This would be root 2p. This would be root 2p. Now, boys and girls, what I want you to understand in this particular case is, this is root 2p. What I want you guys to understand in this particular case is, listen carefully. So we can say net dipole moment will be a root 2 of, what is the value of P? P means charge multiplied by distance. If this is P, what is the magnitude of charge? Q, distance, this is R, this is R. R plus R is 2R. So this is Q into, I would say, 2R. So this would be 2 root 2 Q into R. Like this. Find P net, find the net dipole moment. Guys, see. How can I find the net dipole moment? I want you to understand this. Redraw. Do you see the dipoles are made over here? No, sir, dipoles are not made over here. Dipoles are not made over here. Dipoles are not made over here. Now, boys and girls, do one thing. Can I write this minus q charge as minus q as it is? This plus 3q I'll write as plus q and plus 2q. And this minus 4q I can write as minus 2q and plus 2q. Minus 2q and minus 2q. Array, minus 2 is minus 4. Minus 2 plus 1 is, plus 2 plus 1 is plus 3. So we can write it like this. And this would be over here plus 2q. Now, don't you think that, boys and girls, in this particular case, this would be one dipole, equal and opposite charges. This would be another dipole, equal and opposite charges. This is another dipole, equal and opposite charges. Now, guys, see, dipole moment of this, it would be from negative to positive. Dipole moment of this would be from negative to positive. Dipole moment of this would be from negative to positive. Dipole moment of this would be P. Dipole moment of this would be 2P. Dipole moment of this would be 2P. Why? Because the magnitude of charge is doubled, so dipole moment is doubled. So here it is QQ, so it is P. 2Q, 2Q, it is 2P. Now guys, let's redraw it over here. So this vector in the backward direction, I can make it like this, 2P. This vector upward, I can make it like this. This vector downward, I can make it like this. So this is going to be 2P. This is going to be P, 2P, and 2P. I can write it like this. Now tell me one thing. Can I say the resultant of this dipole and this dipole? Guys. If the two sir, can we make it like this? Yes, array, it is acting on square, na? So you can make it like this. No problem in that. Resultant of this and this. When the two vectors are in the opposite direction, we subtract bigger vector minus smaller vector. So 2P minus P, it will be P. 2P minus P, it will be P. But direction would be downwards. This is P. 2P minus P, it would be P. But direction would be downwards. Why? Because bigger vector minus smaller vector. Whatever is the resultant, the direction of the resultant is always the same as the direction of bigger vector. And this is 2P. Now tell me, what is the resultant of this one and this one? That would be this R. What is the value of R? R would be under root of this vector square plus this vector square. So this would be 2P whole square plus P square plus 2 times of P1, P2 cos of 90. That cos 90 is 0 because this is cos 90. So it would be under root of 2P whole square, that is 4P square plus P square. 4P square plus P square is 5P square. Square and root will cancel, so it will be root 5P. So root 5P is the correct answer. Now you can put the value of P also. P is Q into, this distance is L, Q into L. Is this clear? Oh? Is this clear? Let's move on to the next one. Take a look at this, boys and girls. Take a look at this. Electric field at an angle theta from the ideal dipole. Now see. Sir, does a dipole create electric field? Guys, smash the like button if you're not like the session yet. Does electric dipole create an electric field? Obviously. Why? Because electric dipole has charge in it. So if it has charge in it, it creates electric field. Now this is a negative charge, this is a positive charge. This is the dipole moment. So this is a dipole. You have to find the electric field at x distance at this point at an angle theta. Angle between this x and dipole moment is theta. Directly remember, electric field at this point would be This is called arbitrary point. This is called arbitrary point. Arbitrary point means any random point. Kp, P is the dipole moment divided by x cube. X cube is the distance into under root of 3 cos square theta plus 1. Theta is the angle between dipole moment and x. Now, boys and girls, what I want you guys to understand, if you move from this point to this point, this is called axial point. Axial point. Axial point is that point which lies on the same line upon which dipole is present. Axial point is that point which lies on the same line upon which dipole is present. If dipole is present on this line, so we say, my dear NEET aspirant, this will be considered as the axial point. Okay, yes. And then, my dear NEET aspirants, from here to here, this would be the arbitrary point. This is the this would be the equatorial point. This is the equatorial point. And this would be what? Axial point. Okay, this would be what? Axial. This is the equatorial point. Now tell me, if you have to move from arbitrary point to axial point, do you have to decrease theta or increase? You have to decrease. So exactly at axial point, guys, see. So from this arbitrary to axial point, we can say, my dear NEET aspirants, value of theta would be 0 degrees. See? So I can say this is the axial point. We can say at axial point, theta is equal to 0. If you put theta is equal to 0 over here, electric field will be Kp divided by x cube under root of 3 cos square of 0. Cos 0 is 1. 3 into 1 is 3. 3 plus 1 is 4. So this will be root 4. Root 4 is 2. So electric field will be 2 Kp divided by x cube. So directly remember, electric field at the axial point is 2 Kp by x cube. Now if you move to this equatorial point, I'll write at equatorial point. What is the value of theta? Theta is 90. Guys, so if you make this is the equatorial point. How much is this angle? Theta, 90. So put 90 over here. Electric field will come out to be Kp divided by x cube under root of 3 cos square of 90 plus 1. Cos 90 is 0. This term would be 0. 0 plus 1 is 1. This will be root 1. Root 1 is 1. Electric field will come out to be Kp divided by x cube. So electric field at axial point is 2 Kp by x cube. Electric field at equatorial point is Kp by x cube. Now see, one more important point. The direction of electric field at axial point would be same as the direction of dipole moment. If direction of dipole moment is forward, at axial point direction of is forward. But at equatorial point, direction of electric field would be backward. Not backward, opposite to the direction of dipole moment. Now see, on axial point, electric field is how much? 2 Kp by x cube. What is the direction? Direction would be the same as the direction of dipole moment. At equatorial point or perpendicular bisector, electric field would be Kp by x cube or minus Kp by x cube. Minus is because it is opposite. It is opposite to the direction of dipole moment. Take a look at this particular question, guys. Take a look at this. Find the electric field at A, B, and C in the given figure. This is A, this is B, and this is point C. Now, first and the foremost thing, let's talk about point A. I would say point A, guys, this is which point? Sir, if this is the dipole present over here. My logic says that this is an arbitrary point. And how much is this angle? Angle is theta. Theta is equal to 45 because total is 90. Half of 90 is 45. And this distance, my dear NEET aspirants, if this is L, this is going to be root 2L. This is going to be root 2L. This is going to be root 2L. Now, point A is arbitrary point. Arbitrary point. Point A is arbitrary point. Now, what I want you guys to understand, if you have to find the electric field at point A, you will be using the formula E is equal to Kp divided by x cube under root of 3 cos square theta. Theta is how much? 45 plus 1. So electric field would be Kp divided by x cube. X is distance from this point to this point, that is root 2L. Root 2L whole cube under root of 3 cos square theta. Cos square theta, cos 45 is 1 by root 2. 1 by root 2 whole square, it will become 1 by 2. So it will become 3 by 2. Guys, cos 45 is 1 by root 2. If you do the square, it will become 1 by 2. So 3 into 1 by 2 is 3 by 2 plus, I would say, 1. So 3 by 2 plus 1 is 5 by 2. So electric field would be Kp divided by root 2L whole cube root 5 divided by root 2. Now this is root 2 whole cube into root 2. So 4 times root 2. It means root 2 into root 2 into root 2 into root 2. Root 2 into root 2 is 2. Root 2 into root 2 is 2. 2 into 2 is 4. So basically, this root 2 whole cube into root 2 becomes 4. So it would be a root 5 divided by 4 Kp divided by L cube. This is the electric field at point A. If you have to find the electric field at point B, now don't you think that this point B lies on the same line on which dipole is present? Yes. So this is the axial point. Point B is an axial point. Point B is an axial point. Now tell me, boys and girls, what can I say? Electric field at axial point is 2 Kp divided by x cube. Now x is the distance from dipole to that point. How much is that? That is L. So this will be 2 Kp divided by L cube. Now point C. Point C is an equatorial point. Equatorial point. So if I say electric field at point C, it would be Kp by x cube. It would be K, dipole moment is P, x cube, x is L cube. Kp by L cube. Kp by L cube. Okay. Now take a look at this, my dear NEET aspirants. We'll take the break exactly at 1 o'clock. We'll take the break exactly at 1 o'clock. Now see, find the net electric field at point A in the given figure. You have two dipoles, P and 8P. You have to find the electric field at point A. Guys, see. Electric field due to this dipole at point P. Now see, guys. With respect to this dipole, this point A is the actual point. Sir, are you sure? 100% sure. Why? Because this point lies on the same line upon which this dipole is present. See? So angle is 0. Now see, with respect to this dipole, this point is the equatorial point. Why? I will show you. This is R. And this is the dipole moment. How much is the angle? 90. So when angle is 90, we say then the point is considered as the equatorial point. Now take a look. I have told you one thing to remember. At equatorial point, electric field is in the opposite direction of dipole moment. At axial point, electric field is in the same direction of dipole moment. So what you can say over here is, due to this dipole, electric field will be in the same direction. And how much is the dipole moment? 2kp by x cube or 2kp by r cube. So this is 2kp by x cube. X is how much? R cube, in the same direction. And due to this, electric field will be kp by r cube, but in the opposite direction. If the dipole moment is upward, electric field would be downward. Now how much? kp, but instead of p, I'll write 8p divided by r cube. R is how much? This r plus this r. So total distance till dipole is 2r. So 2r whole cube. So this would be 8kp divided by 2 cube is how much? 8r cube. This and this will cancel. Now guys, see. This came out to be kp by r cube. This came out to be 2kp by r cube. 2kp by r cube, kp by r cube. What is going to be the resultant? The resultant would be under root of this square, 2kp divided by r cube whole square, plus this factor square, that is kp divided by r cube whole square. Now tell me, 2 square is 4, 1 square is 1. So 4 plus 1 is 5. So this will come out to be under root of 5 kp divided by r cube, its whole square. Guys, you are doing square for 2 only. Here you are doing square of 1 only. For the rest of the term, square will remain. So square and root will cancel, but for 5 it will remain. So root 5 kp divided by r cube. This is the net electric field. Is this clear? Tell me quickly in the chats. Is this clear? Is this clear? Is this clear? Come on, quick. Smash the like button if you're not like the session. Quick. Now guys, electric potential energy or electrostatic potential energy. Guys, simply remember one thing. I'll make you understand a simple topic over here. What is that? Take a look. I'll write over here electrostatic potential energy. Electrostatic potential energy. Take a look, my dear NEET aspirants. See, let's suppose you have a charge over here Q1, and there is one more charge over here which is Q2, and this charge is at infinity. Now, if I say you have to bring this charge from infinity to r distance, you have to bring it here. So you have to do the work done. So you have to basically push it. You have to push it. So while you were pushing, my dear NEET aspirants, you were applying the external force by doing the external work done. And this positive was repelling this. Q1 was repelling Q2 in this direction with what force? Electrostatic force. So you were pushing the charge by external force and you brought it here. Now, if I say the amount of work you did in bringing the charge from infinity to r distance, where will that work go? That work done will be converted or stored in the form of potential energy. So I'll write the work done in bringing the charge from infinity to r distance is stored in the form of potential energy between the two charges. So my dear NEET aspirants, if I ask you what was the potential energy of this charge at infinity, we say at infinity potential energy is 0. What is the potential energy at, I would say, r distance? Sir, when you brought the charge from infinity to r distance, you did the work done. Due to that work done, potential energy is stored. So how much potential energy is stored as r distance? So K, Q1, Q2 divided by r. This is the potential energy stored in the charge between the two charges at r distance by doing the external work done. So can I say, my dear NEET aspirants, when you did the work done, potential energy changed from 0 to K, Q1, Q2 by r? Yes. So I can say due to the external work done, potential energy is changed. So change in potential energy means delta U. This you guys need to remember. So due to the external work done, potential energy is changed from 0 to K, Q1, Q2 by r. And my dear NEET aspirants, we can also say here, whatever is the electrostatic force acting on the charge, same amount of external force you are applying. So whatever is the electrostatic force, okay, same is the external force, but in the opposite direction. Guys, so whatever is the work done by external force, same will be the work done by electrostatic force, but negative. Why? Because this force is opposite to this force. So you can say work done by electric force will be negative of change in potential energy. So this is also important. And this electric force is called conservative force. So you can say work done by conservative force is equal to negative of change in potential energy. This also you guys need to remember, my dear NEET aspirants. Work done by conservative force is equal to negative of change in potential energy. So basically, when you brought the charge from infinity to r distance, you did the work. Because of that work, potential energy is stored, K, Q1, Q2 by r. So due to that work, potential energy is changed. Now, this is the work done due to this external force. Now, if I say external force and electric are same, so same will be the work done by electrostatic force, but negative. Why? Because this is opposite to this one. Now take a look, my dear NEET aspirants. First, basic question. So whenever you see charges, two charges from now onwards, you can say potential energy is K, Q1, Q2 by r. Now, if this is the question over here, if I say find the U net, U means potential energy of the system. Find the net potential energy of the system. Take a look. Guys, net potential energy would be, whenever there are two charges, there is potential energy. What is potential energy between this and this? K, Q1, Q2 by r. So that is K, Q into Q is Q square divided by r. R is, I can say, L. Now between these two, K, Q1, Q2 by L, K, Q square by L, K, Q square by L, K, Q square by L. So how many times? 4 times plus. Now, this and this is also making a pair. Hey, you check the number of pairs now. Between this pair and this pair is K, Q into Q becomes Q square divided by how much is this distance? This is a root 2L. Okay. Now between this and this, same. So it will be 2 times. 2 times kq square by root 2 into L. 2 times kq square by root 2 into L. Okay. Now, take a look, guys. Listen carefully. This is a question from, I would say NEET 2022. This is a question from NEET 2022. What does the question say? Listen. 6 charges plus q minus q plus q minus q plus q minus q. This are fixed at the corners of a hexagon. 6 charges are placed fixed at the corners of a hexagon. Okay? Yes. 6 charges are fixed at the corners of the hexagon. Now, guys, the work done in bringing a charge q0 to the center of the hexagon from infinity. One charge is at infinity. Its name is q0. You have to bring this from infinity to the center. So in order to bring the charge from infinity to center, you have to do the work done. How much work you need to do? Work done. So whenever they ask you to find the work done, you say change in potential energy. So you say this work done is equal to final potential energy minus initial potential energy. As simple as that. Work done is equal to final potential energy minus initial. Guys, initially it was here. Finally, it is at the center. Now, we say initially it is at infinity. So at infinity, we assume potential energy to be 0. Finally, it is at center. So final potential energy will be, when this is at center, final potential energy will be, guys, see, between this and this, this and this, this and this, this is this and this, this and this, this is and this. Now tell me, what is the potential energy between this and this? K, Q1, Q2 by R, Q0 divided by. Guys, if this side is D, in case of hexagon, if the side is D, from center to corner, this distance is also D. KQ, Q0 by D. Now this is between positive charges. Between this and this, same potential energy. Between this and this, same potential energy. So positive will be how many? 3. Then, what is the potential energy between this and this? In case of potential and potential energy, you do not ignore the negative sign. K, Q0 into Q. So it will be minus K, Q0 into this Q. K, Q0 into minus Q. That minus I'm taking over here, divided by D. Now, negative charges are, how many charges are negative? 1, 2, and 3. So you will be right, 3. Now tell me, boys and girls, this and this will be cancelled. So final potential energy will be also how much? 0. Now tell me work done. Work done would be 0 minus 0. That will be 0. No work is done in moving the charge from infinity to the center. Now potential. Guys, see. If I say, my dear NEET aspirants, electric potential. Let me make you understand over here. Electric potential. Let's suppose, guys, you have a charge over here Q. And there is another charge over here at infinity. Its name is Q, small q, and its value is 1 coulomb. 1 coulomb means unit charge. Now, if I say you have to bring this charge from infinity to R distance, do you have to do some sort of work? Yes. Where will that work go? Will that be wasted? No. That work will be stored in the form of potential energy. And if I say how much is that potential energy? Guys, the work done in bringing unit charge from infinity to R distance is stored in the form of potential energy. That potential energy will be K, Q, this Q divided by R. Now, if you put the value of Q over here, you would say U is equal to K, Q. Value of Q is 1, small q, R. U is equal to K, Q divided by R. Now, this is the potential energy stored when you brought 1 coulomb charge from infinity to R distance. So this potential energy, we gave it a new name that is called potential. Sir, it means potential is also the potential energy. Yes, potential is also the potential energy in bringing 1 coulomb charge from infinity to R distance. So this is the potential energy of 1 coulomb charge. So I can say this potential is potential energy per unit charge. Per unit charge. So potential energy of 1 coulomb charge is called potential. You can write it like this also. Guys, potential is nothing but potential energy per unit charge. Potential energy divided by charge. Now tell me V is equal to, how much is potential energy? K, Q, small q divided by R, divided by this Q. Q and Q will be cancelled. So I can write over here, V will be KQ divided by R. So this is the potential of 1 coulomb charge. This is the potential energy of 1 coulomb charge. So V is equal to KQ divided by R. Potential energy per unit charge is called potential. So from now onwards, if I say, sir, define the potential of an object, you say KQ divided by R. When you define potential energy, there must be 2 charges. Okay. Take a look. Let's suppose, my dear NEET aspirants, these are the charges, infinite charges. You have to tell me the potential of these charges at the origin. Now tell me, net potential at the origin. What is the potential due to a point charge? KQ by R. I can write over here. Due to this, it will be KQ divided by R. Guys, if I say this is a charge Q, at R distance potential is KQ divided by R. What does it mean? It is actually potential energy. There is one more charge over here, that is 1 coulomb. Now you don't show this. In reality, 1 coulomb charge was at infinity. In bringing that charge from infinity to here, the potential energy stored will be this. Now due to this, potential is KQ by R. Charge is Q, R is how much? 1 plus. Due to this, potential is KQ by, what is the distance from here to here? 2 plus. What is the potential from distance from here to here? KQ by 4 plus KQ divided by 8 and so on. Now guys, when it comes to the net potential in this particular case, you can say take KQ. Now here, this is 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 and so on. Now this is a GP series. How do you find the sum of GP series? Sum is equal to A upon 1 minus R. A means the first term. Here first term is 1. And R is the common ratio. How do you find common ratio? Take any term. Let's suppose 1 by 4. Divide it with the term which comes before it. That is 1 by 2. 2 1s are 2, 2s are 4. So it is 1 by 2. Put it here. So sum will be 1 upon 1 minus 1 by 2. So 1 upon 2 into 1 is 2. This is 1 minus 1 by 2 is 1 by 2. So this will be 2. So can I say, boys and girls, potential net in this case would be, this is KQ. And instead of all of this, I can write how much? 2. So this would be, this is Q upon, instead of K, you can say 4 pi epsilon naught into, I would say 2. 2 1s are 2, 2s are 4. So this would be Q upon 2 pi epsilon naught. This I'll give you as homework. What is the net potential at the center? When I say potential, it is a scalar quantity. And when I say electric field, it's a vector quantity. What is the net potential at the center and net electric field at the center? Guys, see. Due to this, electric field is a vector quantity, okay? This is a vector. It has direction as well as magnitude. This is a scalar. Now see, due to this electric field at the center would be away. Due to this electric field at the center would be away. Due to this electric field at the center would be away. Due to this electric field at the center would be away. This is cancelled with this. This is cancelled with this. So I can say net potential at the center would be 0. Net electric field is 0. If I say net potential, guys see, net potential is simple. This is charge Q. This side is L. What would be the distance of center to corner? L by root 2. Half of the diagonal. So potential due to this would be KQ upon L by root 2. Potential due to this, KQ upon L by root 2. Potential due to this, KQ upon L by root 2. KQ upon L by root 2. So 4 times. Take this in the numerator. 4 root 2 KQ upon L. Potential due to a sphere. Take a look, guys. Potential due to a sphere. Smash the like button, guys, if you want to like the session yet. Potential due to a hollow and solid sphere. First of all, we'll find the potential due to a hollow sphere. Okay. First one would be potential due to a hollow sphere or hollow conducting sphere. We also call it hollow conducting sphere. Hollow conducting sphere. Now, guys, I'll give you the break at 1 o'clock. Wait. Let's suppose you have this surface over here. This is the surface you have over here. This is a sphere. In case of a sphere, hollow sphere, I already told you potential is placed on the, charge is placed on the surface. You have to tell me potential outside, surface inside. Outside potential will be KQ by R. Similar as point charge. Because at outside point, we consider this a point charge. So KQ by R. Now on surface, don't you think that we make small r is equal to capital R? So put capital R over here. On surface potential is KQ by capital R. Now K is constant, Q is constant, radius is constant. Radius of the sphere is also constant. And when I say inside, inside will be same as on the surface. So whatever is the potential inside, same will be, my dear NEET aspirants, on the surface. So graph between potential versus R, V versus R for hollow sphere. Guys, see, what is the value of small r at this point? 0. So means this is center. And this is surface. From center to surface, I already told you potential is constant. So if potential is constant, this is the graph of constant. So V is constant. And when you move outside, potential is inversely proportional to R. So potential outside is inversely proportional to R. So you can say graph would be rectangular hyperbola outside. Very important graph. Solid sphere. In case of solid sphere, my dear NEET aspirants, please do remember this directly. This is a solid sphere. Charge is filled in its volume. I have already told you, in its volume. Potential outside would be at small r distance, KQ by small r. Because at outside point, we consider both as point charges. Potential on the surface would be KQ by capital R. Because on surface, value of small r is equal to capital R. And potential inside would be, guys, see, KQ by 2R cube. Just remember it. 2, after 2 it is 3, so 2R cube. Now interchange the position. Take 3 down, 2 up. So 3R square minus small r square. Small r is the distance inside where you have to find the potential. Okay. And r is the radius. Capital R is the radius. This is the potential inside. And if I say at the center exactly, at center. Potential at center is 3 by 2 KQ by R. This is outside. This is surface. You have to remember these expressions. 3 by 2 KQ by R. Now, guys, If I say potential at center is greater than potential at surface, why? 3 by 2. 3 divided by 2 is 1.5. So it is 1.5 times kq by r. This is 1 kq by r. So 1.5 is greater than 1. 1.5 is greater than 1. That's why potential at center is greater than potential at surface. Now, if you see the graph, boys and girls, take a look. If you see the graph over here, now see guys, if I say, what is the value of r over here? This is 0 because this is v versus r. So this means this is center. Here value of r is capital R. This is surface. Now if I say potential at center is maximum, so potential at center would be, this is potential at center, maximum, 3 by 2 kq by r. Then it decreases. This becomes potential on the surface, kq by r. Then this is inside. So inside potential is maximum at center. Then after surface, this is outside. So outside V is inversely proportional to R. That's why rectangular hyperbola. This graph is also very important. Okay. Now guys, there is a question on this, which I need to show you. There is a question on this. Question is, find the potential and electric field at P and Q due to the given holospheres. Please, guys, we have 3 to 4 slides and we are done with this chapter. So before break, I just want to finish those 3 to 4 slides. It is right now 1 o'clock. So it will take us 10 more minutes. Okay, please wait for 10 more minutes, because then after the break, I want to start the new chapter. Now guys, these are the holospheres, concentric shells. One holosphere. Inside this holosphere, there is another holosphere. Okay, concentric spheres. Now guys, see, listen to me very carefully. Potential outside the holosphere, that is kq divided by r, small r. Okay. Yes, kq divided by small r. Potential on the surface, it is kq divided by capital R. Potential inside, it is kq divided by capital R. Whatever is on surface, same will be inside. Let's talk about electric field. Electric field outside the holosphere is kq by small r square. Electric field on the surface of the holosphere is kq divided by capital R square, radius square. Electric field inside the holosphere is 0. Now take a look. Let's first find potential. If I say at point A, potential at Q. First, let's find potential at Q. My dear NEET aspirants, you say, when we talk about this inner holosphere, so for this inner holosphere, this point is outside point. So outside point potential is kq by r. K is K, Q is charge. Now you say, sir, K, charge on this is small q divided by r. R is the distance from its center. Both have got the same center. From its center to that distance, that is 2r. So it would be 2. kq by 2r. Now, with respect to the bigger sphere, this point is outside. So again, the same formula, kq by small r. So plus k. What is the charge on the bigger sphere? 3q divided by. Now, distance. What is the center of this bigger sphere? Same center. From here to here, distance is 2r. So now tell me, 3kq by 2r, kq by 2r. 3 plus 1 is 4. So 4kq divided by 2r. 2 ones are 2 twos are. So 2kq divided by r. I hope this is clear. Now, my dear Nita, this is potential at Q. Potential. Now, if I say potential at P, boys and girls, with respect to this sphere, this point P is outside. So potential would be K. Q, charge on this is Q divided by distance from its center to this, it is R plus. Now, with respect to this sphere, this point is inside. So potential inside would be KQ by R, where R is the radius of the sphere. So it would be K. Charge on this is 3Q divided by, guys, radius of this sphere, radius, its radius is given as B, KQ by B. So you can take here common. KQ you can take common. What remains over here? 1 by R plus T by B. Now let's talk about electric field. Electric field. Now, electric field at point Q. Guys, see, this point Q is the outside point of the small sphere. So what is the electric field outside? KQ by small r square. So you would say K, charge of this is Q divided by distance from here to here, that is 2r whole square. So it would be K, Q, 2 square is 4r square. Okay. Okay, this is due to the bigger sphere. Wait. Plus, what is the potential due to the inner sphere at this point? Okay, this is the small. What is the potential due to the bigger sphere? This point is outside. K, charge is 3Q divided by distance from here to here is 2r. So it is again 2r whole square. 2r whole square. So 3 times 1 times 3 plus 1 is 4. 4kq divided by 2 square is 4. 4r square. This and this will cancel. So kq divided by r square. Okay. Now, if I say potential at point, electric field at point P, guys, see, when it comes to, due to this sphere, this point is outside point. What is the outside formula? KQ by small r square. So it would be K, charge on this sphere is Q divided by distance from this point to this point is small r square plus. Now, guys, this point lies inside of the bigger sphere. So electric field inside is 0. So due to this sphere, electric field inside is 0. I hope this is crystal and clear to each and every single student. This is crystal and clear to each and every single student. Tell me, guys. Is this clear? Is this clear? Now, there is a small topic and we are done with the chapter. This is equipotential surfaces. This is equipotential surfaces. Now, what does equipotential surface mean? That surface upon which potential is same everywhere is called an equipotential surface. Like, let's suppose, my dear NEET aspirants, this is a charge Q. Due to this charge Q, 3 minutes more and we'll take the break. Due to this charge Q at r distance, guys, see, this is a charge Q. This is a charge Q. This is a charge Q. At r distance, potential is KQ by R. At r distance, potential is KQ by R. KQ by R. KQ by R. So at r distance, KQ by R. So if you go at r distance, potential is KQ by R at every point. This is in 3D, guys. In 3D. In 3D. Okay, in 3D. KQ by R, KQ by R, KQ by R, KQ by R. Now, if you add all of these points, if you join all of these points, it becomes a sphere. So for a point charge, this sphere becomes the equipotential surface. Why? Because if you find potential at this point, it would be KQ by R. Potential at this point, KQ by R. Potential at this point, KQ by R. So the surface Here, for this point charge, where potential is same everywhere, is known as equipotential surface. Now, the potential difference between 2 points on equipotential surface is 0. On an equipotential surface, we say potential is 0. Potential difference is 0. Guys, see. Let's suppose this is charge Q. So you draw the equipotential surface of this charge. That would be this spherical. Now, at this point, potential is how much? KQ divided by R. At this point B, let's suppose this is A. What is the potential at point B? KQ by R. So for a spherical, for a point object, equipotential surface is spherical. Now, if I say potential difference between A and B, VA minus VB, you would say KQ by R minus KQ by R. It would be 0. So that's what I said. Potential difference between any 2 points on equipotential surface is 0. Electric field is perpendicular, and this was asked in NEET 2022. Electric field is perpendicular to equipotential surface at all the points. Like if I say due to this charge, electric field at this point would be away from the charge. What is the angle between equipotential surface and this electric field, sir? That is obviously 0. That is obviously 90. Theta is equal to 90. Perpendicular. At this point, this is the electric field. What is the angle? 90. At all the points, equipotential surface makes 90 degrees. No work is done by the electric force in moving the charge on equipotential surface. If let's suppose you have a charge at this point, you move the charge from this point to this point. So work done by electric force would be 0. You directly remember it. Work done in moving the charge on equipotential surface is how much? 0. This is basically all about the equipotential surfaces. Okay. Now, boys and girls, we are done with this chapter. These were the 2-3 important points in case of equipotential surfaces. Next chapter is basically the capacitors. So this is after the break. After break. Okay. So we'll take a break. Break till 2:05 p.m. Okay. Because after the break, we'll stretch go till 3 more hours. Then one more break, then 3 more hours. This is how we are supposed to go. So guys, let's get back to the business. Just a second, guys. Now, guys, let's dive into the session. Okay. Let's start the chapter capacitors. I would want you guys to focus exactly over here. Okay. Now, guys, take a look exactly over here. Now, guys, take a look exactly over here. We have the chapter capacitors. We have the chapter capacitors. I would want you guys to focus. Listen to me very carefully. I'm starting from the scratch. So listen, everybody of you. See, guys. When it comes to the chapter capacitors, okay, what does a capacitor actually mean? What does a capacitor actually mean? See, guys, we say capacitor, it is a device. It is a device used to store electrical energy. It is that device which is used to store electrical energy. Or it is a device which is used to store charge. I can say it something like that. It is a device which is used to store charge. Now, my dear NEET aspirants, what I want you guys to understand in this particular case, let's suppose you have a capacitor, you have a sphere over here. Either you call it a sphere or you capacitor. You are storing charge Q on the sphere. You are storing charge Q on the sphere. And radius of the sphere is R. Now, we know when there is charge, there is potential. What is the value of the potential? V is equal to KQ divided by R. If you store Q charge on the capacitor, if you store Q charge on this sphere, potential V will be developed. And this V is directly proportional to Q. If you increase the value of charge, Q potential will be developed. Large will be the potential. Now you can say Q is directly proportional to V. So Q is equal to C into V. This is what we call the capacitance, where C is the capacitance of a capacitor. Where C is the capacitance of a capacitor. I'm simply saying one thing. Let's suppose you have a sphere over here. On this sphere, you are storing charge Q. Due to this charge Q, potential V is developed. We say this Q is proportional to V. More is the charge, more is the potential. We say this Q is equal to C into V. Q is equal to C into V. Where C is what we call the capacitance of a capacitor. Now, if you ask me, sir, what does this capacitance actually mean? This capacitance means capacity of a capacitor. Ability to store the charge. How much charge a capacitor can store, that is what we call the capacitance of a capacitor. Okay. How much charge a capacitor can store, that is called a capacitance of a capacitor. Like, this capacitor has got little capacitance. This capacitor has got large capacitance. Okay. Absolutely, sir. We can say it something like that. Now, guys, capacitance of a spherical capacitor. Let's suppose you have a spherical capacitor. Guys, when it comes to the capacitance, where C is a constant and C is called a capacitance, I'll write over here. C is capacitance of a capacitor. Capacitance means how much charge it can store. More is the capacitance, more charge it can store. As simple as that. Now, we say capacitance of a spherical capacitor. This is a spherical capacitor. Radius of the spherical capacitor is R. Now, this is the capacitance of a spherical capacitor, 4 pi epsilon naught R. Now, guys, see. What is the type of question that is asked in this capacitor's first one? Let's suppose you have small capacitors and small capacitors. These are combined to form a big capacitor. You have n small capacitors. These are combined to form a big capacitor. Now, what is the capacitance of small capacitor C? Charge on this capacitor is Q. Potential is V and radius is R. If they are joined together to form a big capacitor, they would ask you to find the capacitance of big capacitor, C dash. Potential of big capacitor, charge of big capacitor, radius of big capacitor. You would directly remember it over here. Charge of the big capacitor will be n times of charge on the small capacitor. Directly remember. Radius of the big capacitor will be n raised power 1 by 3 radius of small capacitor. Directly you remember this over here, my dear NEET aspirants. Okay. You directly remember this in this particular case, boys and girls. You directly remember this. Then if I say capacitance is n raised power 1 by 3 into capacitance of small capacitor. Potential V dash is equal to n raised power 2 by 3 potential of small capacitor. I can say it something like this. Now, boys and girls, listen carefully. There was a question which was asked in NEET 2021. Listen carefully. 27 small drops. Sometimes they would mention drops. Sometimes they would mention capacitors. 27 small drops. Like you have a drop over here. Small capacitors over here. Value of n is equal to 27. Okay. Are charged at 220 volts. Potential of this is 220 volts. They combine to form a bigger drop. They are combined to form a bigger drop. Calculate the potential of bigger drop, V dash. Now tell me, how do we find V dash? V dash is equal to n raised power 2 by 3 into V. V dash is equal to n raised power 2 by 3 into V. So you can say V dash is equal to n, value of n is 27. 27 raised power 2 by 3 into V. V is 220. So V dash will be 27, we can say 3 cube. 3 into 3 into 3. So 2 divided by 3. 3 and 3 will cancel this into 220. Now 3 square is 9 into 220. So this will be 1980 volts. This will be the potential of the bigger drop. Tell me, boys and girls, is this clear? This will be the potential of the bigger drop. Simply, even if they ask you to capacitance, what will you say? Capacitance of the bigger drop, guys, n raised power 1 by 3 into C. Because you can clearly see over here, capacitance is n raised power 1 by 3 into C. So can I write, boys and girls, here? C dash is equal to n is 27 raised power 1 by 3 into C. So C dash would be, that is 3 cube raised power 1 by 3 into C. 3 and 3 will cancel, so it will be 3C. So capacitance of the bigger drop will increase by 3 times. Will increase by 3 times. Is this clear? Is this clear? Is this clear, boys and girls? Yes, 100%, sir. Now comes basically the next topic, that is called parallel plate capacitor. Guys, listen. Let me make you understand what does a parallel plate capacitor actually mean. Listen. Parallel plate capacitor is you would be having two plates. Okay, this plate and this plate. Two plates are placed parallel to each other. This forms a parallel plate capacitor. When two plates are placed parallel to each other, this forms a parallel plate capacitor. Now guys, area of the plates is A and distance between the plates is D. This is the separation. And my dear NEET aspirants, you have attached a battery to this capacitor. Please listen carefully. This is called positive terminal of the battery. This is called negative terminal of the battery. Positive terminal, and this is positive and this is negative. Absolutely, this is positive and negative. Now, if I say positive terminal is connected to this plate, it will occupy positive charge on this. Directly remember. And if negative terminal is connected to this plate, it will occupy negative charge on this plate. Yes, sir. So this will be plus Q will be occupied over here, minus Q will be occupied over here. So electric field will be set up from positive to negative. So this is the electric field set up from positive to negative. This is called a parallel plate capacitor. So here we store the energy between the plates of the capacitor. Now see, if somebody says what is the capacitance of a parallel plate capacitor, you say it is epsilon naught A by D. Epsilon naught A is the area of the capacitor, D is the distance. Now see, what was the question asked in NEET 2022? See the question. The capacitance of a capacitor if area of the plates becomes A by 2 and separation is 2D. Guys, see. It says that you have a capacitor. Let's suppose area is A, separation between the two is D. What will be the capacitance? C is equal to epsilon naught A by D. Then finally, it says area becomes A by 2. Area A dash becomes A by 2. And this separation D dash becomes 2D. Separation is doubled, area is halved. What is the new capacitance? C dash will be epsilon naught A. Instead of A, I can write A divided by 2. Into D, instead of D, I will write 2D. So this would be epsilon naught A divided by 4D. Now, epsilon naught A by D, that is C. So C dash will come out to be C divided by 4. C dash will come out to be C divided by 4. Energy stored in a parallel plate capacitor. Take a look, my dear NEET aspirants, if we talk about energy stored in a parallel plate capacitor. Now, boys and girls, listen carefully. If I say this is a parallel plate capacitor, this is a parallel plate capacitor. There is a battery connected to this. This battery will occupy positive charge on this plate and negative charge will be occupied onto this plate. If somebody says what is the energy stored in the capacitor? Energy stored in the capacitor would be Q square by 2C. Q is the charge stored in the capacitor. C is the capacitance of parallel plate capacitor. This is in terms of C and V. Sorry, Q and C. In terms of capacitance and potential difference, it is 1 by 2 CV square. In terms of potential and voltage, it is 1 by 2 Q into V. In terms of, charge and voltage, charge and potential, 1 by 2 Q into V. Now take a look, my dear NEET aspirants, at this question. A capacitor of 700 picofarad. And by the way, my dear NEET aspirants, you measure the capacitance of a capacitor in farad. You measure the capacitance of a capacitor in what? In farad. In farad. Okay. You measure the capacitance of a capacitor in farad. Just a second, guys. You measure the capacitance of a capacitor in farad. Okay. Like in this particular case, it says that a capacitance of 700 picofarad. So when you write this capacitance over here, boys and girls, listen carefully. When you write this capacitance, 700 picofarad. So it will be 700 into 10 raised power minus 12 farad. When you convert pico to farad, multiply with minus 12. Is charged by a 100 volt battery. Potential difference is 100 volts. It is like this. This is the symbol of capacitor. And it is charged by a 100 volt battery. This is 100 volt battery. This is 100 volt battery. The energy stored in the capacitor, U will be equals to 1 by 2 CV square. Because C and V is given. U will be equals to 1 by 2 C. C is 700 into 10 raised power minus 12 into V square. V square is 100 into 100. Okay, this would be 100 square. Okay. Now guys, in this particular case, so this is going to be 100 into 100 in this particular case. So this will be 100 square, 100 square. So my dear NEET aspirants, and 700 divided by 2, that is 350, that is 350. So this is going to be 350 into 10 raised power minus 12 into, I would say, 10 raised power 4, because 10 raised power 100 square is 10 raised power 4. Now this will become U is equal to 350 into this is 10 raised power minus 12, 10 raised power 4, so 10 raised power minus 8. Okay. Now you can say in this particular case 3.5 into 10 raised power minus 6 joules. So this would be the answer. Let's move on to the next one. Let's move on to the next one. Force between the plates of a capacitor. Take a look, guys. Let's suppose, my dear NEET aspirants, you have a parallel plate. On one plate, due to the battery is connected, due to the battery on one plate, positive charge is occupied. On another plate, negative charge is occupied. Don't you think that these positive charges and negative charged plate, they attract each other? Why? Because opposite charges are occupied. So I can say two plates will attract each other because of opposite charge. So when they attract each other because of the opposite charge, we say force will act. So how much is that force? You can say that force is Q square divided by 2A epsilon naught. Q square by 2A epsilon. Q is the charge on the plate, A is the area of the plate. In terms of sigma, because when charge is present on area, we define sigma, charge per unit area. In terms of sigma, you say sigma square A divided by 2 epsilon naught. This is in terms of sigma. In terms of sigma, it is sigma square A divided by 2 epsilon naught. Now guys, take a look. Okay, one more important thing I just want to discuss over here. One more important thing. What is that? Just a second. Just a second, guys. See guys, since this is the force on the plate, now if somebody says what is going to be the pressure on the plates? Pressure on the plate. Guys, when it comes to the pressure on plate, so pressure will be equals to force per unit area. What will be the value of force? Force is sigma square A divided by 2 epsilon naught. Sigma square A divided by 2 epsilon naught into A. Now boys and girls, I can say this A and A will be cancelled. So this pressure will be sigma square divided by 2 epsilon naught. Now same is the expression. The same is the expression for energy density. Same expression is for energy density. Energy density. Energy density means energy per unit volume. So you can say energy per unit volume is equal to sigma square by 2 epsilon naught. Guys, see what is energy density. Let's suppose this is a sphere. I say how much is the energy stored in the sphere? E. This is the energy in the total sphere. If I say what is the energy present in unit volume of the sphere, that is called energy per unit volume. So that is how we define as energy density. That is how we define as energy density. So that is energy per unit volume. So this energy would be basically U. Volume of sphere. Guys, how do you find the volume? This is the parallel plate. Area is A, separation is D. A volume will be area multiplied by separation is equal to sigma square divided by 2 epsilon. So energy would be sigma square divided by 2 epsilon naught A into D. This is also the energy stored in a capacitor. This is also the energy. This is also the expression of energy stored in a capacitor. Okay. So this expression is energy density. Energy density. Energy density. And this expression is total energy. This is total energy. Okay. Let's move on to this question. The electrostatic force between the metal plates of an isolated parallel plate capacitor of charge Q, area A. You have to tell me electrostatic force between the plates of a capacitor. You'll say, sir, it is simple. F is equal to Q square by 2A epsilon naught. But the point is, in this particular case, the electrostatic force, okay, yes, we have to find the options. Now, guys, this force depends upon charge, it depends upon area. Does it depend upon the separation between the plates? No. So it is independent of the distance between the plates. So which option? Option A. Because that D is not mentioned in the expression. Guys, is this clear? Is this clear? Give me the signal in the chats. Is this clear? Is this clear? Now, there is a concept of common potential. There is a concept of common potential. Let me make you understand what does common potential concept actually mean. See, you have got capacitors over here. C1, C2, C3. One end of this C1 has potential V1. This has one end potential V2. This has one end's potential as V3. And another end is VC, another end is VC, another end is VC. This is called common end. This is called common end. If somebody asks you, find the potential of this common end. Okay, you would be simply saying potential of this common end would be C1 V1, C2 V2 plus C3 V3 upon C1 plus C2 plus C3. C1 V1, C2 V2, C3 V3 upon plus C1 plus C2 plus C3. This will be the common potential. Like, take a look, my dear NEET aspirants. Let's suppose the question is something like this. You have to find the charge in 4 microfarad capacitor. This. See, guys. Whenever you have to find the charge in a capacitor, you say you have the formula Q is equal to C into V or C delta V. Capacitance multiplied by potential difference. So capacitance you know, but potential difference you don't know. Potential difference means potential of this point, potential of this point. They're difference. So before finding the charge, we have to find the potential difference. Whenever you see a question of this sort, do one thing always. Assume the potential at a point 0. Take any point, assume the potential 0. Sir, will it create any difference? It is not going to create any difference. This is a trick. I am saying let this potential be 0 at this point. Let the potential be 0 at this point. Okay? Yes. Now, my dear NEET aspirants, what I want you guys to understand in this case, please listen carefully. I would want you guys to focus first over here. Just give me a second and you would be able to understand everything. Take a look. I am making a battery over here. See, guys, I'm making a battery over here. This is a battery. Let's suppose this is a 20-volt battery. This is positive, this is negative. This point is connected to higher potential, positive. Positive terminal means higher potential. This end is connected to lower potential. So we always say this higher potential, let's suppose this is VA, this is VB. We always say this VA, higher potential minus lower potential, must be equal to this. Must be equal to this delta V, potential difference, delta V. So here we say VA minus VB is equal to 20 volts. Let's suppose if I say VB, value of VB is 0 volts, potential of this end is 0. What will be the value of VA? You will say, sir, VA minus 0 will be equals to 20. So VA will come out to be 20 volts. Like another example. Let's suppose you have a battery. This is 40 volt potential. Potential of this is plus 40 volts. You have to find potential of this. Now guys, this is higher, this is lower. You always say, since I told you higher potential, this VA minus lower potential VB must be equal to delta V. Higher potential is 40 minus lower potential you have to find out is equal to delta V. Delta V is 40. Take it over there, take it over here. So you would say 40 minus 40 is equal to V. V will be equals to 0. This is how you calculate the potential of a point. Now guys, come over here. Come to this question again. If you assume 0 volt potential here, this is a 20 volt battery. Could you please tell me what is the potential of this point? Sir, it is simple. How? Guys, this is higher potential. So this will be a higher point. This is the lower. So higher minus lower. So you would say, in this case, VA minus VB must be equal to 20 volts. VA you have to calculate, minus VB is equal to 0 volts is equal to 20 volts. So VA will come out to be equal to 20 volts. So potential of this point came out to be plus 20 volts. Potential of this will be how much? Guys, if this is 10, this is 0, this will be plus 10. Same logic you have to apply now. This is plus 10 volts. Now, boys and girls, what I'm trying to say in this particular case is, from here to here, it is a wire only, simple wire. So whenever there is only wire, potential remains the same. So potential of this end will be also plus 20. Here it would be plus 10. Now you have to find the potential of this end. Take a look. Sir, can I say if this is 20, this would be 20? No. Why? Because the load is in between. If this is wire only, then potential remains same. Now see, a redraw. If you redraw this, boys and girls, it would look something like this. Three capacitors I'm making. This one, and this one. Potential of this is 20, 10 and 0. 20 volts, 10 volts, 0 volts. Capacitance 5, 4, 1. 5 microfarad, 4 microfarad, 1 microfarad. You have to find the potential of VA or VC, V common. Don't you think this VC is the common end to all the three capacitors? Yes. So how do you find the value of VC? VC will be C1 V1 plus C2 V2 plus C3 V3 upon C1 plus C2 plus C3. C1 V1. C1 is 5 into V1 is 20. 5 into 20 plus C2 V2, that is 4 into 10 upon plus C3 V3. C3 is 1 into 0. C1 plus C2 plus C3. 5 plus 4 plus 1. So 5 into 20 is 100. 100 plus 40, 140 divided by 10. So this would come out to be 0, 0. It would be 14 volts. So potential of this point came out to be 14 volts. So potential of this point came out to be 14 volts. Now, whatever the capacitor you take, I can find the charge in each capacitor. Sir, which one? This one? Okay, just a second. Charge in 4 microfarad. This is the capacitor. This is plus 10 volts. This is plus 14 volts. Now, how do you find charge? Charge is equal to C delta V. Delta V is the potential difference. Higher potential minus lower. Q is equal to charges. Capacitance is 4. Potential difference. Potential difference will be higher minus lower. 14 minus 10. 14 minus 10. That is 4. 4 into 4 is 16. So 16 microcoulomb. Sir, I want to find the charge in this capacitor. Okay. Take this 5 microfarad. Take this 5 microfarad. Potential of one end is 14, potential of another end is 20, plus 20 volts plus 14 volts. Q is equal to C delta V. Q is equal to C is 5 delta V, that is 20 minus 14. That is 6. So Q is equal to 6 5s are 30 microcoulomb. Guys, tell me, is this question clear? Is this question clear? Come on, I need the signal in the chats. Is this clear? Now guys, see. Dielectrics and capacitors. Dielectrics and capacitors. Okay. Like you have conductors, insulators, there is a one more type of question, that is material, that is called dielectrics. Let's suppose you have this plate, positive plate of the capacitor. And this is the negative plate of the capacitor. Positive plate and negative plate. Since the two plates attract each other, so when the two plates attract each other, they stick to each other. So when they stick to each other, this gap is no longer there in between the plates. When there is no gap, it will no longer remain a capacitor. So to overcome this problem, the two capacitors should not stick to each other. The two plates should not stick to each other. We use dielectrics. Okay. The two plates should not stick to each other. We use dielectrics. The two plates should not stick to each other. We use dielectrics. Now guys, see, this dielectric has got positive as well as negative charge. Now positive plate of this plate, positive charge of this plate is going to attract the negative charge of the dielectric. See, positive charge of the plate is going to attract the negative charge of the dielectric, and negative charge of this plate is going to attract the positive charge of this dielectric. So after some time, it will look like this. Negative charge will be onto this side, positive charge will be onto this side. Now the two plates will not stick to each other because these positive charges have attracted the negative, these negative charges have attracted the positive. This is what we call the induced charge. This is what we call what? Induced charge on the walls of dielectric. Induced charge on the walls of dielectric. How much charge has been occupied onto the walls of dielectric? And if somebody says, what is the value of this induced charge? You say this. Qi is equal to Q. Q is the charge on the plates. Charge on plates. 1 minus 1 by K. K is the dielectric constant. K is the dielectric constant. Qi is equal to Q into 1 minus 1 by K. Now, if somebody says, what is the charge density? How much is the charge present on unit area? Charge density would be sigma I is equal to sigma into 1 minus 1 by K. 1 minus 1 divided by K. This is the induced charge density. How much is the charge present on the unit area of the walls? How much is the charge present on the unit area of the walls? That is called induced charge density. Sigma I. Okay. Yes. Now, guys. Okay. One more important thing. Whenever dielectric is placed in a capacitor, its capacitance changes. Whenever a dielectric is placed between the plates, its capacitance changes. How much will be its capacitance? K times of C. Dielectric times the old capacitance. Okay. Yes. Now, boys and girls, very important topic, series combination of dielectrics. I would want you guys to focus over here. Series combination of dielectrics. See, guys. Series combination of dielectrics. My dear NEET aspirants, what I want you guys to focus in this particular case, listen. This is a plate of a dielectric, of a capacitor, this is another plate. If you place the dielectric in between the plates, but the width of the dielectric is given as T, this is the width of the dielectric, and separation between the plates is given as D. Separation between the plates is given as D. And if somebody says, find the capacitance of this capacitor. Guys, see. When I say this is the plate, listen carefully. When I say this is the plate, in between the two plates, you have placed a dielectric, which has dielectric constant K. Every dielectric has a dielectric constant. And this dielectric has width D. Separation is also D. Here capacitance becomes K times of C. When the dielectric is filled in the entire width of the capacitor, then capacitance becomes K times of C. Now, if I say the dielectric is not filled in the entire width of the plates, but width of the dielectric is T, separation between the plates is D. In this case, capacitance would be, listen carefully, epsilon naught A is the area, D minus T. D is the separation between the plates, T is the width, T divided by K. This is the capacitance. This is the capacitance. Now, guys, one more important thing. Let's suppose the question is something like this. You have got a positive plate of the capacitor. You have got the negative plate of the capacitor. And multiple dielectrics are placed in series. First dielectric, second dielectric, third dielectric, fourth dielectric. And width of this dielectric is D1, D2, D3, D4. K1 dielectric constant, K2, K3, K4. If they ask you to find the capacitance of this dielectric, capacitance will be epsilon naught A. A is the area. D1 by K1, D2 by K2, D3 by K3, D4 by K4. This is the capacitance. Even also, you would need to find the equivalent dielectric constant. Also, equivalent dielectric constant means if you have to find the net dielectric constant of these dielectrics, guys, when you have resistors in series, you find their equivalent resistance. Here you have dielectrics in series, you have to find equivalent dielectric constant. So K equivalent in this particular case will be D upon, I would say, D1 by K1 plus D2 by K2 plus D3 by K3 plus D4 by K4. This is the equivalent dielectric constant. Take a look at this question. You have a capacitor, and this is a question from JEE Mains 2021. You have a capacitor in which you have multiple dielectrics. K, 3K, 5K, D, 2D, 3D. You have to find the equivalent capacitance. Tell me, guys. What will I say? So you would say, sir, C would be epsilon naught A D1 by K1. What is the value of D1? D, K1 is K. D divided by K plus 2D by 3K plus 3D by 5K. Now this would be C is equal to epsilon naught A upon D divided by K is common. 1 plus 2 by 3 plus 3 by 5. Okay. Now this will come out to be C is equal to epsilon naught A divided by D divided by K. This would be epsilon naught A upon D divided by K would be 34 by 15. When you solve this, it would be 34 by 15. Now, when you take this in the numerator, see guys, take this K and 15 in the numerator. It would be like this. 15 divided by 34 K epsilon naught A divided by D. 15 by 34 K epsilon naught A divided by D. Option first. Okay. Now guys, if the dielectric is used as a conductor, like this is a dielectric which is used as a conductor. For conductor, we consider dielectric constant as infinity. So you would say, you would be using this expression. This one. So instead of K, you need to put infinity over here. So when you put infinity over here, it would become epsilon naught A D minus T plus T divided by K. Okay. So instead of K, I would put infinity. Anything by infinity is 0. So this term would become 0. So it would become epsilon naught A D minus T. Epsilon naught A D minus T. Okay. Yes. Yes. Now guys, take a look. Take a look. Okay. Take a look, guys. See, now my dear NEET aspirants, what I want you guys to understand in this particular case, let's suppose the dielectrics are placed in parallel. These are the three dielectrics, and in this particular case, this is the plate, positive plate of the dielectric. This one. This is the negative plate of the dielectric. Sorry, positive plate of the capacitor, negative plate of the capacitor. In between the plates, you have these dielectrics placed in parallel, not in series. Dielectric constant of K1, it is width is A1, A2, A3. In this particular case, when they say find the capacitance of this capacitor, because after placing the dielectric capacitance changes, this will be the capacitance. Epsilon naught by D, A1 K1 plus A2 K2 plus A3 K3. Also, if I say K equivalent in this particular case, my dear NEET aspirants, when we define K equivalent in this particular case, boys and girls, K equivalent means equivalent dielectric constant. K equivalent simply means what? Equivalent dielectric constant. That is going to be, I would say, A1 K1 plus A2 K2 plus A3 K3 upon, I would say, A over here. Upon, I would say, A over here. Okay. Upon, I would say, A over here. This is going to be the equivalent dielectric constant, A1 K1. A1 with this K1, A2 K2, A3 K3 upon A. This is the equivalent of these three dielectrics over here. Now guys, see, take a look at this question. You have got two capacitors. You have got two dielectrics over here placed parallel. These are the two plates. This is a plate. This is another plate. You have to find capacitance. What would you say? Capacitance is equal to epsilon naught divided by D, A1 K1 plus A2 K2. You would say C is equal to epsilon naught divided by D, A1. What is the value of A1? That is A by 2. K1. Guys, for air we say dielectric constant is 1. So it is 1 plus A2, that is K, and K2, that is A by 2. Now I think in this case C will come out to be C dash, C dash, C dash. It will come out to be epsilon naught divided by D. And A by 2 is common. So this is A divided by 2 is common. So here it would be 1 plus K. So epsilon naught by D. Guys, what is the capacitance of a capacitor without dielectric? Epsilon naught divided by A by D. So C dash will come out to be C divided by 2, 1 plus K. C divided by 2, 1 plus K. Okay. Absolutely. Combination of capacitors. Combination of capacitors. Take a look, guys. Combination of capacitors. If you have 3 capacitors connected in parallel, series, you have to find their equivalent capacitance. Always remember, this is the way by which we can find their equivalent capacitance. 1 by C equivalent is equal to 1 by C1, 1 by C2, 1 by C3. It is not like resistors. It is opposite of resistors. Okay. Now, my dear NEET aspirants, if you have two capacitors only, for 2 capacitors, what will you say? 1 divided by C equivalent would be 1 divided by C1 plus 1 divided by C2. Now do the cross multiplication. 1 divided by C equivalent would be C1 plus C2 upon C1 into C2. Now do the reciprocal. So C equivalent will come out to be C1 C2 upon C1 plus C2. This is going to be the equivalent capacitance in this particular case. Next, take a look at this. If you have parallel combination, capacitors are connected in parallel. Their C equivalent in this case would be simply C1 plus C2 plus C3 and so on. Now guys, see, if they ask you to find the equivalent capacitance here, it looks like these are connected in series. Okay, let's suppose C1 is C, C2 is C, C3 is C. No, these are not in series. Take a look. Do one thing. Whenever you have a question of this sort, assume the potential of this point is A. What will be the potential of this point? A. Array, it is simple wire, so it is A. What would be the potential of this point? A. It will directly go here. What will be the potential of this point? A. What will be the potential of this point? A. Cool. Now, what is the potential of this point? B. Potential of this point would be B. Directly potential of this point would be B. So if you see over here, all the capacitors are connected between A and B. If you see in this particular case, all the capacitors are connected between A and B. First capacitor A and B, B and A, A and B. So you can make this point over here A, you can make this point over here B. This is connected between A and B, something like this. This is connected between B and A, something like this. This is connected between B and A, something like this. So this is called parallel combination of capacitors. In parallel combination, when we say equivalent capacitance, it is going to be C1 plus C2 plus C3. So it is going to be 3C. So it looks like these are in series, but in actual reality, these are connected in parallel. NEET 2021. Take a look, my dear NEET aspirants. Let's suppose potential of this point is A and potential of this point is B. Don't say AB. Let's suppose this is X. Potential of this point is, or let's suppose potential of this is Vx. Potential of this is Vy. Now, when you reach this point, here also potential is going to be Vy. Here also potential is going to be Vy. When across a load, potential is same, that load will be short circuit. Means you have to remove that from the circuit because same potential here, same potential here. So this diagram will look something like this. something like this. This is C, this is C. Potential across, this is X, potential across, this is Y. Now tell me, what is the equivalent capacitance in this particular case? C plus C, this is 2C. So from this, you got to know when potential across the load is same, that is short circuit. Guys, is this clear? Tell me in the chats. Is this question clear? Tell me in the chats. Let's move on to the next chapter, that is current electricity. Tell me, guys. Is this clear? Okay. So the next chapter, boys and girls, we have is the chapter known as current electricity. Is the chapter called current electricity. Okay. Yes. Let's dive into this. Now, guys, let's dive into the chapter that is current electricity. Current electricity. Everybody of you listen to me very, very, very carefully. Sir, how important this chapter is? Extremely important. How many questions every single year? I would say 4 questions to 5 questions. Every single year from this chapter. One chapter, 4 to 5 questions. Okay? Yes. Absolutely. Now, boys and girls, what I want you guys to understand in this particular case is, listen. First topic that we need to discuss over here is that is electric current. What does electric current mean actually? See, guys. Let's suppose you have a conductor over here. This is a conductor. Or you say wire. And in this wire, in this conductor, there are large number of free electrons. Free electrons move in a conductor. Now, these free electrons, let's suppose they are moving in a proper direction. Let's suppose these electrons are moving in a proper direction. So we say then current is produced. Whenever free electrons move in a conductor, current is produced. Whenever, I would write over here, whenever free electrons move in a conductor, current is produced. And if somebody says, sir, how much will be that? So current is what? Flow of charge. More electrons will flow, more will be the current. And that current will be, we say, charge upon time. How much charge has flown in time. Now guys, you have the concept average current. Average current means, let's suppose this is a wire. From 9 a.m. to 1 p.m., let's assume charge was flowing continuously. If I say what is the current produced from 9 a.m. to 1 p.m., that is going to be the average current. Current flowing produced from this time to this time, that is called average current. If I say what was the current exactly at 10:30, current at particular instant is called instantaneous current. Between the two intervals, it is called average current. So average current will be simply delta Q by delta T. That is Q2 minus Q1 upon T2 minus T1. Final charge minus initial charge. And instantaneous current means dQ by dt. What is the difference between instantaneous average? Average gives us how much is the current produced from this time to this time. Instantaneous means how much is the current produced at a particular instant. Like, question is over here, a basic question. This is a charge. They ask you to find the current at t is equal to 2 seconds. When they say at t is equal to 2 seconds, means instantaneous, at this time. So you would be simply saying I is equal to dq by dt. Differentiation of charge gives you the current. What is the differentiation of charge? So 2 into 2 is 4t minus differentiation of 3t is 3. They say at t is equal to 2 seconds. We say at t is equal to 2 seconds. So current is going to be 4 into 2 minus 3. 4 into 2 is 8. 8 minus 3 is 5 ampere. Like you have this. I is equal to 4 plus 2t. Find the charge from 0 to 2 seconds. Now guys, see. We say current is equal to dq by dt. Differentiation of charge with respect to time gives you the current. Now here current is given, you have to find the charge. Take it over there. So dq will be equals to I dt. Now integrate both sides. Integration means addition of small things. When you add small charge dq, it will give you the total charge q. This integration of I dt. So this q will be equals to integration of I dt. What is the value of I? 4 plus 2t into I would say dt. So q will come out to be, guys, okay, you have to find the charge flown from 0 to 2 seconds. So this will be 0, this would be 2. What is the integration of 4t, guys? It is, what is the integration of 4? It will be 4t plus, what's the integration of t? 2t. It will be 2t square divided by 2. From where to where? From 0 to 2. 2 will be cancelled. This charge would be, now in this 4, you have to first put the upper limit, then minus lower limit. Sorry, in this t, you have to first put the upper limit minus lower limit. Similarly here. So it would be 4 into 2, upper limit minus lower limit 0. 2 minus 0 is 2 plus. In this t, you have to put 2 square, minus 0 is 2. 2 will come on to 4 into is 8. 8 plus 4 is 12. So 12 coulomb. 12 coulomb charge. Okay. Absolutely. Now these are few basic questions. Now what is important in this one? Take a look at this. Drift velocity. Now guys, listen to me very carefully. Let's suppose this is a conductor, wire, cylindrical in shape. You are connecting a battery to this. This is the positive terminal of the battery, this is the negative terminal. Now, my dear NEET aspirants, this positive terminal is going to create positive charge on this side. Negative terminal will create negative charge on this side. And I have already told you, electric field is set up from positive charge to negative charge. Electric field will be set up from positive charge to negative charge. Now, due to this electric field, these electrons will experience force, because whenever a charge is placed in the external electric field, it experiences force. Now, due to that force, these will start moving and they will gain some velocity. That velocity is called drift velocity. The velocity with which electrons are drifted in a conductor to produce current, that is called drift velocity. And the value of that drift velocity is this. E divided by m into tau. E divided by m into tau. This is the drift velocity. E is the charge on an electron. Capital E is the electric field. M is the mass. Tau is the time or relaxation time. Now, from now onwards, if I say, sir, current is flowing in this one, so means electrons are moving. Electrons are drifted due to move. Electrons are moving due to which velocity? Drift velocity. Yes. Now, guys, relation between drift velocity and current. Tell me one thing. If I say electrons flow in a conductor with drift velocity, when electrons flow, current is produced. So how much is the current produced? You would be directly writing this. I is equal to NEAVD. This is the relation between current and drift velocity. Guys, it is simple. If I say this is the conductor. In this conductor, electrons are flowing. Electrons flow because of which velocity? Drift. So if electrons flow because of drift velocity, so current is produced. So that current will be I is equal to NEAVD. Now, what is this small n? This small n will be number of free electrons per unit volume. Number of free electrons present in the unit volume. Okay. Like this electron, this conductor has got immense number of electrons. If I say what are the number of electrons in a unit volume, that is called number of free electrons per unit volume. E is the charge on an electron. A is area of cross section. Area of cross section. VD is the drift velocity. Okay. Yes. Now take a look at this particular question. Now take a look at this particular question. See. Question is the drift velocity of free electrons in a conductor. The drift velocity of free electrons in a conductor is V. If the radius of the conductor is doubled and current is doubled, find new drift velocity. Take a look. There is a conductor. There is a conductor. Radius is R. And drift velocity of free electrons is V. Current is I. I can say I is equal to NEAVD. Can you tell me the value of drift velocity from this? VD will be equals to I upon NEA. A is the area of cross section. You can write it like this. VD will be equals to I upon NE. Area will be pi r square. The area of cross section of the wire is pi r square. Now, finally, my dear NEET aspirants, what does it say? Question says, finally, if the radius of the conductor is doubled and current is also doubled, finally it says, if R dash becomes 2R and I dash becomes 2I. So, drift velocity would be I upon NE. Instead of I can write 2I and this would be V dash. New drift velocity is V dash 2I upon NE pi into R square. R will be how much? 2R whole square. Okay, that is 4R square. 4R square. So what can I say in this particular case? So this 2 1s are 2 2s are 4. I upon, I can say 2, take it out, NE pi into R square. Now NE pi R square, I upon NE pi R square is VD. So this new VD dash will come out to be VD divided by 2. VD divided by 2. So drift velocity would be halved. One more important question. A wire carries a current of 1.6 ampere. There is a wire, it carries a current of 1.6 ampere. And free electrons per meter. Free electrons per meter. What does it mean? It means a number of electrons per unit length. Number of electrons per unit length. It is given as 2 into 10 raised power 24. Means, guys, this is a wire. If I say how many number of electrons are present in the unit length, of this wire. So in the unit length of the wire, number of free electrons is 2 into 10 raised power 24. Calculate the drift velocity. You have to find drift velocity. See guys, you would say, sir, drift velocity would be I upon NEA. Current is given, no problem in this. Okay. And area is not given. And N, this N is also not given. N means number of free electrons per unit volume. So what I can say here, this N will be total number of electrons divided by total volume. The number of free electrons per unit volume. Now tell me, this would be N into N divided by volume. Volume of a cylinder, that will be area multiplied by length, A into L. Okay, yes. Now boys and girls, you tell me one thing in this particular case. Can I say over here, listen carefully. So this drift velocity will become, that is I upon, instead of small n, I can write N divided by A into L. And E, this A and A will be cancelled. So this is I upon N divided by L into E. What is the value of N divided by L? 2 into 10 raised power 24. So you can write over here, drift velocity will come out to be current 1.6 divided by N divided by L, 2 into 10 raised power 24 into 1.6 into 10 raised power minus 19 charge on an electron. Now solve, this is going to give you the answer. I hope this question is crystal and clear to each and every single student. Guys, tell me quickly in the chats. Quick. Is this clear? Smash the like button. Okay. Now, next topic that we have is called the current density. What does current density mean? Let's suppose this is a conductor over here. In this conductor, let's suppose current is flowing. And this is area of cross section of the conductor is A. So current density will be simply how much current is flowing through this area of cross section. If I say more current is flowing, density of current would be more. Less current is flowing, density of current would be less. So we simply say this current density is equal to current upon area. How much current is flowing divided by area. Simply, if in a conductor current is flowing, somebody asks you what is current density, how much current is flowing with respect to the area. Now current density in terms of drift velocity. You can say J is equal to I divided by A. Current density is. Now what is the value of current? You recently studied NEAVD. Now A and A will be cancelled. So current density will come out to be NEVD. Okay, now guys, take a look. The current density drift velocity at A, B and C will be. You have to tell me current density at A, B and C. Guys, first of all, if I say 3 electrons are entering this conductor, how many electrons will be leaving, sir? Obviously 3 electrons would be leaving. If 3 are entering, 3 would be leaving. So I can say the amount of current at A would be equals to amount of current at B would be equals to amount of current at C. Without a shadow of doubt, I can say it like this. Then, my dear NEET aspirants, next point, current density. When I say current density, you say current density is I divided by A. J is equal to I divided by A. Now, current density depends upon current and area. Here, area here area. At all the 3 points it is same. Current at all the 3 points it is same. So current density at A is equal to current density at B is equal to current density at C. So this is the ratio of current density. Drift velocity, J is equal to NEVD. Now, my dear NEET aspirants, current density depends upon drift velocity. So drift velocity depends upon current density. If current density here is same, so drift velocity VA is equal to VB is equal to VC. Take a look at this question. When I say current, current will always remain the same. Current at A is equal to B is equal to C. It will not change. But when I say current density, I divided by A. Now tell me, current density is inversely proportional to area because current at all the 3 points is same. If I say 3 electrons are entering, 3 electrons will cross B, 3 electrons will cross C. So that's why current is same. Now current density. So current is same, but current density is inversely proportional to area. So here area is less, more. So here current density will be large, here less, here less. So current density at A is greater than current density at B is greater than current density at C. Because area at A is less. And this current density is directly proportional to drift velocity. So similarly, drift velocity at A is greater than drift velocity at B is greater than drift velocity at C. Yes. Ohm's law. Ohm's law. Okay. Let's understand Ohm's law, my dear NEET aspirants. Let's suppose you have a conductor over here. This is a conductor that you have. This is the positive side of the conductor. This is the negative side of the conductor. How? Because this is connected to positive terminal. This is connected to negative terminal. Now guys, see. We always say battery has potential difference. Let's suppose it is a 10 volt battery. It will create some positive charge here, some negative charge here. So some electric field will be created. If I say this is a 100 volt battery, it will create large positive charge here, large negative charge here, strong electric field. Okay. So basically this electric field depends upon this potential difference. Now I can write, I can say due to the potential difference of the battery, if EMF of the battery is large, I can say electric field is going to be large. If I say if potential difference of the battery is large, due to that I can say electric field is going to be large. If electric field is large, these electrons are going to experience large force. So force would be large. If force would be large, so flow would be large. More electrons will flow. So I can say if flow is large, I would say current would be large. So I can say this current is directly proportional to force. It is directly proportional to electric field. It is directly proportional to V. So can I not directly say this potential difference is directly proportional to the current? More is the potential difference, more electrons will flow, more current will be produced. 100%. Absolutely, sir. And we are replacing this proportionality with the constant R into I. V is equal to R into I, where R is what we call the resistance. Resistance of the conductor. And this is what we call the Ohm's law. V is directly proportional to I. That is what we call the Ohm's law. Okay, now guys, take a look. Let's suppose we have potential difference. Now, okay, so Ohm's law is what? V is directly proportional to I. If power of V is 1, power of current is 1. This is Ohm's law. Okay, so potential difference varies linearly with current. This is Ohm's law. If I say V is proportional to I square, this is not Ohm's law. Now guys, see, slope of VI graph. Let's suppose this is V versus I graph. This angle is theta. This is V versus I graph. Okay. Now in this particular case, I ask you to tell me the slope. Slope is tan theta. Slope is tan theta. Tan theta is perpendicular by base. Perpendicular is V. V. Base is I. V by I. Now tell me as According to Ohm's law, V is equal to IR. R will be equals to V divided by I. This is equation first, this is equation second. So can I not say from first and second? From first and second? Guys, here V by I is slope, here V by I is R. I can say from first and second, this resistance will be directly proportional to slope. So from now onwards, if somebody asks you the resistance from V versus I graph, you'll find what? Slope. IV graph. This is slope of IV graph. This is IV graph. Take a look. Tell me slope here. Slope is tan theta, perpendicular by base. If this is theta, perpendicular is I, base is V. This is equation first. Now guys, we say as V is equal to I into R. E divided by I is equal to R. Do the reciprocal. I divided by V is equal to 1 by R. This is equation second. Now don't you think that from first and second? From first and second. Guys, here 1 by R is I by V. Here I by V is slope. So slope is directly proportional to, inversely proportional to resistance. So I can say slope is inversely proportional to resistance. So from now onwards, if you have to find the resistance in case of IV graph, you will find the inverse of slope. Now take a look. Compare the resistance of wire A, B and C. Compare the resistance of the wire A, B and C. Compare the resistance of the wire A, B and C. Now guys, this is V versus I graph. In case of VI graph, I can say slope is directly proportional to resistance. Okay. So you can say clearly over here, slope is directly proportional to resistance. The one which has more slope will be having more resistance. Which of the three graphs have more slope? A as compared to B as compared to C. So I can say resistance of A is greater than resistance of B is greater than resistance of C. Okay, here you have to compare the temperature. Compare temperature T1 and T2 of two wires. Now temperature is directly proportional to resistance. The one which has large resistance will be having large temperature. Now this is VI graph. I can clearly say in this particular case, resistance of first is greater than resistance of second. Bro, because first one has more slope. So temperature T1 is greater than temperature T2. Okay, tell me here. IV graph. So in this case, I can say resistance is inversely proportional to slope. So this has large slope. This has less slope. So I can say a resistance of one is less than resistance of second. Okay. So I can say temperature of first is greater than temperature of second. The one which has, oh sorry, less than. It is directly proportional. No? So if resistance of first is less than resistance of second, this is going to be the graph. Guys, is this clear till over here? Tell me quick. Now comes the resistance. Now comes the resistance. Now guys, see, listen to me very carefully. When we talk about the resistance, see, let's suppose this is a conductor. This is one more conductor. This has length L1, this has length L2. What is resistance actually? When electrons flow in a conductor, they have to face the different number of collisions with the atoms, ions, molecules. When electrons flow in a conductor, they face different types of collisions with atoms, ions, molecules. That creates the hindrance or opposition to the flow of electrons. That is called resistance. Now, if I say this has got large length, here electrons has to face large collisions in order to travel. Here electrons has to face less resistance. So I can say more is the length of a conductor, more will be resistance. Okay, if area of cross section is bigger, electrons can cross easily, electrons can flow easily. So we say resistance is inversely proportional to area. Okay, so I can say now combine this and this. You can say this resistance will be equals to rho L divided by area, rho L by A, where rho is called the resistivity of the material. Resistivity basically gives the idea how much resistance a material can create. Like if I say this is a conductor, this is also a conductor, but this material has got large resistivity. It means this can create large resistance. This can create large resistance. And this can create less resistance. Why? Because it has got less resistivity. So resistivity gives you an idea. See how much a material is capable of in creating the resistance. Resistivity is also called specific resistance. And this resistance does not depend upon the length, area, or resistance. Okay, no. This resistivity does not depend upon the length, area, and resistance. But resistance does depend. Resistivity is the property of a material. Okay, yes. Resistivity is the property of a material. Is this clear? Now guys, tell me, let's suppose you have to find the resistance over here. Resistance will be simply R is equal to rho L divided by A. Now L is the length of the conductor that is given. Area, which area you guys are supposed to take? Now see guys, this is a wire in which only current is flowing through this portion. Current is not flowing through this portion. Current in the middle portion, I is 0. Because this is air, this is hollow. Current flows through this portion only. This portion. So only this portion is going to create the resistance. This and this. Now when we define resistance over here guys, R is equal to rho L by A. Now if you find area, guys do one thing. You need to consider only this much of area. Let's find the entire area. This entire radius is given as 3R. And this inner radius is given as R. So we can say entire area, whole area of the wire, pi R square, pi. Instead of R, I can say 3R whole square. Minus pi R square. So I am basically finding the whole area from here to here. Then I am subtracting this much of area. So you will be getting this much of area. So this would be area is equal to 3 square is 9 pi R square minus pi R square. So area will come out to be 8 pi R square. So this much of area is going to create the resistance. So I can say in this case resistance is equal to rho L divided by area. Area is 8 pi R square. So you cannot take the entire area over here. You have to consider that area only through which current is flowing. Find resistance. Find resistance. Now see, this is a cubical conductor. In this case, current flows something like this. This side is A. This side is C. This side is B. Resistance will be same, rho L divided by area. Now here you need to consider the length as if is the current flowing along A, along C, or along B. It is flowing along A. So here length will be A. And if I say area, you need to consider that side through which current is crossing. Current is crossing this area. Its area would be length C, breadth B. So area would be B into C. So resistance would be rho L. L is A. Area is B into C. Is this clear? Is this clear, guys? I hope this is clear. Okay, that's great. Now, guys, now let's move on to the next topic. Okay, let's suppose if you have a cuboid, something like this. Let's suppose if you have a cuboid, something like this. Take a look, my dear NEET aspirants. Take a look. If you have a cuboid, something like this. Okay. In this particular case, if they ask you to find the maximum resistance and minimum resistance, maximum resistance would be along rho L divided by B into H. Maximum resistance would be along length. Keep that thing in your mind. And minimum resistance would be along this height, this height. If the current flows like this, it faces maximum resistance. Minimum resistance if the current flows something like this. This is the minimum. This is the ratio of maximum by minimum. You can understand it like this. Now I need to show you something else. Now guys, take a look. See this. This is very important. I want you guys to focus. I told you the formula of resistance R is equal to rho L divided by A. This is the resistance in terms of length and area. But if I say resistance in terms of mass and length, okay, guys, see, this is the formula which you guys are supposed to remember directly. This is the resistance formula. Sir, how do we derive it? I don't want you guys to do that. I want you guys to basically directly remember it in this particular case. Okay. So resistance is equal to rho L square divided by M into, I would say, D. Here this rho, this is called, I would say, resistivity, and this D is the density of the material. So this D is density and this rho is resistivity. This is resistivity. So if I say resistivity and density of the material is constant, then I can say rho R is proportional to L square by M. This is the resistance in terms of L square length and mass. Now guys, see, resistance in terms of mass and area. This would be the value of resistance in terms of mass and area. Here, rho and d, if you consider constant, resistance is proportional to m square by a. Let's take a look at the question on this one. Now, guys, see. Now, guys, see. Masses of the three wires are in the ratio of 1:3:5. Okay. And the length ratio is given as 5:3:1. Okay. Find the ratio of the resistance. Guys, see. Mass ratio is given and length ratio is given. So can I say mass ratio and length ratio? Mass and length, mass and length. So I can use this relation. So I can say, and three wires are made of same material. I can say as a resistance is proportional to L square divided by M. Now tell me, in this particular case, resistance of first wire is to resistance of second wire is to resistance of third wire. It will be L square by M. L square by M. What is the length of first one? 5. 5 square divided by 1. So you can say over here, this is 5 square divided by 1 is to resistance of second wire, 3 square divided by 3. So 3 square divided by 3 is to resistance of third wire. So that is going to be 1 square divided by 5. So it would be 1 square divided by 5. So this will come out to be 25 is to 3 3s are 9. 9 by 3 is to 1 divided by 5. 3 1s are 3 3s are 9. Okay. So 5 into 25 is 125 is to 5 into 3 is 15 is to 1. So this is going to be the ratio in this particular case. This is going to be the ratio in this particular case. Okay. Now a master concept that I would want you guys to remember. Please, you have to remember this directly. See, guys. You know the formula I is equal to NEAVD, relation between current and drift velocity. You know the formula of drift velocity, Vd is equal to EE by M into tau. Now from these two equations, my dear NEET aspirants, listen carefully. Listen carefully. Can you do one thing? Can you find the value of drift velocity? Drift velocity will be I upon NEA. Now drift velocity, here is I upon NEA, here it is EE by M into tau. Okay. So basically with the help of these two, my dear NEET aspirants, you get this equation. You don't have to derive. With the help of these two, you get this equation. This is what we call microscopic form of Ohm's law. You have to directly remember this. Form of Ohm's law. And from this microscopic only, guys, V is equal to ML, mass, length, current, number of free electrons per unit volume, charge on an electron, relaxation time, area. Now you can see V is equal to I into R. Compare it with V is equal to I into R. This is current. So this will be the value of resistance. So value of resistance is ML upon NE square tau into A. This is the actual formula of resistance. Now you compare it with R is equal to rho L by A, which I told you. R, L, L, A. What is the value of rho? Rho will be M N E square into tau. Rho is equal to M upon N E square into tau. This is the actual formula of resistivity. Actual formula. Then we define conductivity. Conductivity is the inverse of resistivity. So resistivity is inverse of conductivity. So conductivity is inverse of resistivity. So do the reciprocal of this. That is going to be the conductivity. So with the help of these two formulas, my dear NEET aspirants, we got this. Okay. This is the microscopic form of Ohm's law. When you compare this equation with V is equal to IR, you get the value of resistance at this. This is the actual formula of resistance. When you compare it with rho L by A, this is the value of resistivity. And from the resistivity, you get conductivity. So you have to remember this directly. That's it. Okay. Yes. Yes. midpoint potential. Midpoint potential. Guys, see, the same midpoint potential you studied recently in capacitors, same midpoint potential you guys are supposed to study here. Take a look. Let's suppose you have resistance R1 and it has a potential V1 of this side. You have resistance R2. This has got the potential V2. You have resistance R3. This has got the potential V3. And this is the midpoint, or we say common point of all the three resistors. You have to tell me what is the potential. You have to tell me what is the potential of this midpoint. Potential of this midpoint will be simply V1 by R1 plus V2 by R2 plus V3 by R3 upon 1 by R1, 1 by R2, 1 by R3. It's not like capacitors. In capacitors, it was V1, C1, C2, V2, C3, V3. No. Okay. Okay. This is the midpoint potential. Let's take a look at certain number of questions over here. See, guys. In the particular question, you guys are supposed to find current I. Find current I. In this particular question, you have to find the value of current I. Current in this branch. Always remember, whenever you have to find the current in a resistor, you say V is equal to I into R. V is the potential difference. Okay? And I is the current, R is the resistance. First of all, in order to find current here, you must know the potential difference across the resistor. In order to find current, you must know the potential difference across the resistor. Now take a look. I guess similar type of question I have shown you recently in capacitors. Assume the potential at a point to be 0. Let's assume here. Let 0 volts. Potential of this point is 0. If this is 0, could you please tell me what is the potential of this point? That is 20 volts. Why, sir? Because higher potential minus lower potential. This is higher, this is lower. Because this is, guys, simple, higher minus lower. VA minus 0 volt must be equal to 20 volts. This minus this must be equal to this. So VA will come out to be 20. If this is 20, what is the potential of this and 20? Because it's a simple wire. If this is 0, what is the potential of this end? 10 volts plus 10. So what is the potential here? Plus 10 volts. Absolutely cool. Now, guys, I want you to redraw. A redraw. When you redraw this diagram, it would look something like this. So this is 10. This is 20. This is 5. Potential of this is 20 volts. Potential of this is 10 volts. Potential of this is 0 volts. Potential of this common point you have to find. Midpoint potential or common potential. Tell me what is the value of VC. Recently you studied V1 by R1, V2 by R2, V3 by R3 and so on. Now see, V1 R1, V2 R2, V3 R3. So you can say V1 by R1, 20 divided by 10 plus V2 by R2 plus upon R1, R2, R3. Solve this, it will come out to be 50 by 7. So potential of this point came out to be 50 by 7. Now, done. Now, in which resistor you want me to find the current? Sir, I want you to find the current here. Cool. Well, let's first find here. I would say current in 20 ohms. Please listen. This is 20. So I would write over here. So potential of this is 50 by 7. Potential of this is 10 volts. Resistance is 20 ohms. Now current I is equal to delta V divided by R. Current I is delta V. Delta V means higher potential minus lower. Higher, 10 is greater than 50 by 7. If you divide 50 with 7, it is less than 10. So higher, 10 minus 50 by 7 divided by R, resistance is 20. This is going to be 70 minus 50, 20 by 7. 20 by 7 upon 20. This and this will cancel, so it will be 1 by 7 amp. Sir, now I would want you to find the current here. And current always flow from higher potential to lower potential. So this cannot be the direction of current. This is the correct direction of current. Oh. Now, what if I ask you to find the current here? 10 ohm. This is 50 by 7. This is 20. Okay. Again, I is equal to delta V by R. Delta V will be higher minus lower. 20 minus 50 by 7. R is 10. This would be the value of, call this as I1. Here it would be I2. 70. This is 20. 70 minus 50. Oh, 7 2s are 14. 140 minus 50 divided by 7 divided by 20. Okay. Just a second, guys. Just a second. Okay. So now how much is this? 140 minus 50, that is 90. 90 by 7 into 20. Okay. 9 by 7. Because 0, 0 will cancel. In this particular case, 9 by 14. Correct, na? Are you getting me? Oh? Okay, this is 10. This is 10. Sorry. This is 10. 10. So this will be 9 by 7. This is 10. Sorry. Delta V divided by R. Delta V divided by R. This is 10. So this will come out to be 9 by 7. Now I hope you got the idea. I hope you got the idea how you can find the current in a resistor. Okay. If you know the potential difference across the ends of the resistor, you can find the current. Absolutely. Okay. Cool. One more question I want to show you over here. This is an amazing question. This is. Now see, guys. In this particular case, I would want you guys to focus on one thing. This is a circuit. You have to find the current I in this resistor. Find current I. Even I will find current in all the resistors. Now, before that, I would want you guys to do one thing, boys and girls. What is that? That is redraw this circuit. Because when you redraw this circuit, you will get a crystal clear idea in this particular case. Redraw means make the see, this one and this one are in series. Even if you change the position of these two, it is not going to create any sort of difference. You can put it over here, you can put it over here. I'll make it here. Keep the batteries from one side and resistors from another side. Okay, something like this. Do like this. Put it here, put it here. Interchange the position. You can do this also. Take it here, take it over there. It's one and the same thing. So this is 5 ohm resistor. This 20 volts. This 10. This is 4. This is 8 volts. Now guys, see. Take a look. What is the first thing we do? Assume the potential at a point is equal to 0. 0 volt let. If this is 0, what is the potential of this point? 0. What is the potential of this point? 0. If this is 0, this is 8. This would be how much? Plus 8. 8 minus 0 is equal to 8. 8 minus 0 is equal to 8. Yes. If this is 8, this would be plus 8 volts. If this is 8, this would be plus 8 volts. This is 0. This is 0. If this is 0 volts, guys, this is 10. What would be the potential of this point? Take a look. This is 0 volts. 10. This. You always say higher potential minus lower because this is connected to positive terminal. This is higher. So this is 0 minus V is equal to this 10. So V will be equals to minus 10. This is 0, this is 20. This would be plus 20 because this is connected to higher potential. Okay. Now take a look, my dear NEET aspirants. Let me give you the crystal clear view. You got the potential of every point. This is the only thing that you guys are supposed to do. Find the potential of every point. Now find current. Let's find current in this. 5 ohm. 8 volts plus 20 volts. This is 5 ohms. Now tell me one thing. If you have to find the current here, what would you do? I is equal to delta V by R. Delta V is what? Higher potential minus lower potential. Higher is what? 20 minus 8. The resistance is 5. 20 minus 8 is 12 by 5. Oh. And what is the direction of the current? Direction of the current is from higher to lower. This is the direction. Okay, can you find in this one? Can you find in this one? This is plus 8 volts. And here it is minus 10 volts. And this is 4 ohms. Now tell me, I is equal to delta V divided by R. Higher minus lower. So that is 8 minus of minus 10. R is 4. A higher minus of minus lower. This would be 18 divided by 4. That is 9 by 2 amp. 9 by 2 ampere. Now see, and direction of the current here is something like this. This is I1, this is I2. I1 and this is I2. Okay, now see, boys and girls, in this particular case, this is I1, this is I2. Let's assume the current in this one is I3. Because current always leave from the positive terminal. See, current is leaving from the positive terminal. Here current is leaving the positive terminal. Here current is entering the negative terminal. So don't you think that this current plus this current is equal to I2? So you can say I1 plus I3 is equal to actually I2. This current plus this current, because this current comes down, this current goes up, and then they will meet and go as I2. Now, if you have to find the value of I3, take it over here. So I1 minus I2 will be equals to I3. Oh. Now I1, what is the value of I1? 12 divided by 5 minus I2, 9 divided by 2 is equal to value of I3. This is how you find the current in each resistor. Tell me guys, is this clear? Boys and girls, everybody out there. Is this question clear? See, there are only two things they can ask. Either find the potential of a point or find the current in a resistor. Once you get the potential of every point, you can find the current in each resistor. Clear? One more I just want to show you on the same pattern. One more. That is this. That is this one. Guys, smash the like button if you have not liked the session yet. That is this one. This is a question from JEE 2019. Take a look. Take a look. You have to tell me the potential difference between the point A and B. Means you have to find VA minus VB. Potential difference between this point and this point. Now see. If you see this resistance, this battery and this resistance, they are connected in series or parallel? Series. It is like, guys, it is like a resistance. It is one and the same thing. Both are same. So this and this are in series. Similarly, this and this are in series. Don't say this and this is series. No, because here is a joint. This joint, 3 joints. Here, no joint, no joint. So I can say in this particular case, if I redraw, please redraw this. Take a look. If this and this are in series, guys, when two resistors are in series, we add the resistances, R1 plus R2. So 10 plus 10 is 20. So I'll make this 20 over here. And then this battery, that is 2 volts. And then the second branch, I'll make it as it is without any changes. This is 20 ohms. This is 4 volts. And then my dear NEET aspirants, 20, 10, 30. And this 4 volt battery. Yes. And this is point A. This is point B. Now, what is the first thing we are supposed to do? Assume 0 volt potential at a point. Okay. Assume 0 volt potential at a point. We are assuming 0 volt potential at a point. This is lead. Okay. Now, if this is 0, what is the potential of this end? 0 volt. What is the potential of this end? 0 volt. If this is 0, this is 2 volts. What is the potential of this end? Plus 2 volts. If this is 0, what is the potential of this end? Plus 4 volts. If this is 0, what is the potential of this end? Plus 4 volts. Now redraw again. Or you don't have to redraw it again. You can directly do it. Now see, this resistance has got one end potential 2 volts. This resistance has got 2 ends. This end and this end. This end has potential 2 volts. Another end is VA. This resistance also has one end A. Another end has got potential 4 volts. This resistance also has one end 4 volts. Another end is VA. So VA is common. So you can apply common potential. VA will be V1 by R1, V1 by R1, V2 by R2, V3 by R3. So V1 by R1, that is 2 divided by 20 plus 4 divided by 20 plus 4 divided by 30 upon 1 by R1 plus 1 by R2 plus 1 by R3. This will, I guess, come out to be 3.12 volts. This will come out to be 3.12 volts, VA. So if I say VA came out to be 3.12 volts, can I write it like this? VA minus 0 is equal to 3.12 volts. Now 0 is the value of VB because you assumed VB as 0. So VA minus VB will come out to be 3.12 volts. This is the answer to the question. It has one more question, JEE 2019, but I would give you this as homework. This I would prefer to give you as homework, my dear NEET aspirants. Okay? Absolutely, sir. 100%, sir. 100%, sir. 200%, sir. 500%, sir. Bulb. Is this clear? Tell me in the chats, is this clear? Smash the like button if you're not like the session. Quick, 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 quick. What is going on? Wait. Well, let me see the chats. I don't see the chats at all. Na, 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 na. Na, 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 na. Guys, block, sir, please block spammers. No, let them like the session first, okay? After the end of the session, we'll block them. The rest, focus over here. Hmm? These are the nibba nibbis in the chats, okay? Let them enjoy, but make sure they like the session. That is mandatory. Now, let's take a look at this particular topic, my dear NEET aspirants. That's a bulb. What does bulb actually mean? What does bulb actually mean? Listen to me very carefully. Listen to me very carefully. Let me just write over here. Bulb. Bulb. Guys, see. When it comes to the bulb, we say bulb is a pure resistance. It is a pure resistance. Bulb is a pure resistance. Bulb means resistance. Like you have, guys, you have inside your room different number of bulbs. If you go to the market and you buy this bulb, listen to me very carefully, please focus over here. If you go to the market and you buy the bulb, it would be mentioned on the bulb that, like if it is a 100-watt bulb, it would be mentioned 100 watts and 220 volts. This is what we call rated power, PR. This is what we call rated voltage, VR. What does rated power and rated voltage actually mean? It means that if you give a supply of 220 volts potential difference to the bulb, it will give you 100-watt power. Like if I say I'll buy a 50-watt bulb from the market. This is a 50-watt. So here power rated is 50 watt and voltage rated would be here 220 volts. Voltage rated is same for all the bulbs because in India government sends us 220 volts of the supply voltage. So it means that if you give 220 volts to this bulb, it gives you 100-watt power. Sometimes you would have experienced, like if you are inside the room, you got 150-watt bulb, you got 200-watt bulb. You were assuming, okay, that the bulb is going to give you the great light, huge light inside your room. But it didn't. Why? Because you are not providing it the supply of 220 volts. So if you supply a voltage of 220 volts, then only it can give you 100 watt. If you do not supply 220 volts potential difference, it cannot give you the power of 100 watts. So that's why we say this is voltage rated, this is power rated. Now, with the help of this voltage rated and power rated, you can also find the resistance of the bulb. Guys, one formula I would want you guys to remember, we say that is as. We say power is what we call power. Power means how much energy it is giving every second. Light, how much light it is giving. Energy per second. Power is V square divided by R. This is the formula of power. Please remember this directly. If you have to find the power of a bulb, it is V square by R. Now, my dear NEET aspirants, if I say power rated over here will be voltage rated square divided by resistance of the bulb. So take it over here. Resistance of the bulb would be, that is voltage rated square divided by power rated. This is what we call the resistance of the bulb. Now, if I say, could you please tell me what is the resistance of this bulb? Sir, it is VR square. VR is 220 square and divided by PR. PR is 100. So 220 square divided by 100, you will get the resistance of the bulb. So with the help of this rated power and rated voltage, you can find the resistance of the bulb also. Rated power simply means how much power this bulb can give you if you provide a supply of 220 volts. If it is not providing this much power, then that is what we call the power supplied. Guys, this is power rated. This is rated power. I'll mention over here, rated power. This is rated voltage. rated voltage. Okay. Now, my dear NEET aspirants, if I say second over here is power supplied. Power supplied. Power supplied means how much power is supplied by the bulb. So power supplied will be simply that is voltage supplied divided by resistance of the bulb. Bro, if I say rated power is rated voltage square divided by resistance of the bulb, power supplied will be voltage. See, if this bulb has a capability of providing 100 watt power, and that is only possible if you give 220 volts. If you do not give 220 volts, then let's suppose you are giving 160 volts of voltage. That is what we call the voltage supply. And the power which the bulb is going to give you, that will be called as power supply. That will be called as power supply. Now, guys, what do we have to understand in this particular case? What do we have to understand in this particular case? That is nothing but if you have bulbs connected in series and parallel. Take a look. Take a look. Let's suppose if you have bulbs in series. If you have bulbs in series, like you have this bulb, this bulb, this bulb, it is connected to the battery. Power of this is P1, power of this is P2, power of this is P3. This is the rated power, 50 watt, 25 watt, 100 watt. And if they ask you, what is the net power supplied by these bulbs, or what is the net power consumption by these bulbs? Net power consumption by the bulbs in this particular case, my dear NEET aspirants. Okay. In series combination, my dear NEET aspirants, net power consumption would be calculated by this net power consumption. 1 by P net. It is going to be 1 by P1 plus 1 by P2 plus 1 by P3. See what I'm trying to say. Guys, 3 bulbs in a room are used in series. You are supplying the voltage to this, to this, to this. I'm asking you the simple thing. What will be the net power consumption? How much net power they have consumed, or the amount of power they consume, the same amount of power they supply. How much will be the net power supplied by these 3 bulbs when they are connected in series? So this is the way by which we can find the net power consumption. Okay. If you have identical bulbs or identical bulbs, means this is P. So we can say P net in that particular case will be 1 divided by P plus 1 divided by P plus 1 divided by P. How many? Up to N. So 1 by P net in that particular case would be, that is N times of 1 by P. Now do the reciprocal. So P net in this particular case would be P divided by N. If you have bulbs in parallel, take a look. Bulbs in parallel. Let's suppose this is a bulb. This one more bulb. This is one more bulb. It is connected to a battery. This has power consumption P1, this has P2, this has P3. When the bulbs are connected in parallel, so we say net power consumption, it is going to be P1 plus P2 plus P3 and so on. Simply addition. Simply addition. Take a look at the question which was asked in NEET 2019. This was the question asked in NEET 2019. 6 similar bulbs are connected with a DC source of EMF E and 0 internal resistance. The ratio of power consumption by the bulbs when all are glowing. Guys, first, when all the 6 bulbs are glowing, these are the identical bulbs. When all are glowing, means when all the 6 bulbs are glowing, when all the 6 bulbs are working. When all the 6 bulbs are working, my dear NEET aspirants. Okay. When all the 6 bulbs are glowing. Okay. When all the 6 bulbs are glowing, guys, P, this is P, this is P, and this is P. What will be the net power consumption? Guys, P, and P, this is the section A. These 3 are in parallel, these 3 are in parallel. How do you find the equivalent power consumption parallel? P1 plus P2 plus P3, that is 3P. So this 3P, this 3P, it would look something like this. This is 3P and this is 3P. Now, these two are in parallel. How do you find the equivalent power consumption in parallel? Guys, 1 by P net will be equals to 1 by P1 plus 1 by P2. Now do the cross. 1 divided by P net would be this, or simply, guys, for n identical bulbs, you can say P by n, or this only, na? Do the cross. P1 plus P2 divided by P1 P2. Do the reciprocal. So P net will come out to be P1 P2 upon P1 plus P2. So if you have 2 bulbs in parallel, in series, you can find this P net. So this will be P1. Okay, or this is P net. Or call it P1. Power consumption when all are glowing. So it would be P1 P2, this into this. So 3P into 3P upon P1 plus P2, 3P plus 3P. So this would be 9P square divided by 6P. P and square will be cancelled. So P1 will be 3 2s are 6, 3 3s are 9. So 3P divided by 2. So when all the 6 bulbs are glowing, net power consumption will be 3P by 2. Then it says when 2 from section A and 1 from section B are glowing. 2 from this, 1 from this. When 2 from section A and 1 from section B are glowing. Okay. In that particular case, you guys are supposed to tell me what will be the net power consumption. Tell me. Guys, 2 from section A, P plus P, 2P. 1 from section A, that is P. So it would look something like this. This is 2P. This is P. Now tell me, P2 in this particular case will be net power consumption. So that would be this into this, 2P plus P, 2P into P upon 2P plus P. So this would be 2P square upon 3P. This and this would be cancelled. So 2P divided by 3. Now you have to find the ratio. Basically, ratio of when all are glowing and when 2 from section A, 1 from section B are glowing. Now you can say P1 divided by P2 will come out to be P1 is 3P divided by 2 upon P2 is 2P divided by 3. So it would be 3P by 2 into 3 divided by 2P. P and P will be cancelled. So this would be 9 by 4. So ratio is 9 by 4. The ratio is 9 by 4. Okay, there is a question over here. A filament bulb of 500 watt and 100 voltage is to be used in a 230 volt supply. Okay? Is to be used in a 230 volt supply. There is a bulb. It has 500 watts power rated and 100 volts voltage rated. What does it mean? It means if you provide a 100 volt supply to this bulb, it can give you a power of 500 watts. Is to be used in a 230 volt main supply. Means a battery of 230 volt is connected to this. This is the meaning. Sir, don't you think that maximum potential difference it can take is 100 volts? And the potential difference that you are giving over here is 230 volts. Don't you think that it is going to burn the bulb? Yes. The maximum is 100. If you provide 230, it is going to burn the bulb. So that's why the question says when a resistance R is connected in series. So resistance R is connected in series. It works perfectly fine. Now, my dear NEET aspirants, when resistance R is connected in series, it works perfectly fine, my dear NEET aspirants. It works perfectly fine, my dear NEET aspirants. Okay. So I can say in this particular case, 230 volt supply you are sending. This will take the voltage of how much? 100 only, because this is the maximum capability it can take. And rest of 130 is going to go in this. 130 volts will go in this. You are supposed to find the value of resistance. Guys, see. There are three formulas of power. First one is power is equal to V into I. This is in terms of voltage and current. Second is V square by R. Third is I square into R. These are the three formulas of power. So I can use this over here. So I can say what is the power? Power is equal to V into I. Let's find the current here. What is the power of this bulb? That is 500 is equal. What is the voltage given? That is 100 into I. 0, 0, 0, 0. So current came out to be 5 amperes. Now see, it says that in the bulb 5 ampere current is flowing. And in series combination, my dear NEET aspirants, always remember same current flows through all the resistors. So whatever is the current here, same will be current here. Now in resistor, guys, can I say R? V is equal to IR. You are supposed to find R. R will be V divided by I. What is the potential difference of this? 130. How much is the current flowing in this? That is 5. 5 divided by 130, that is 26 ohms. So 26 ohms is the resistance in this particular case, my dear NEET aspirants. 26 ohms is the resistance of this resistor. 26 ohms is the resistance of this resistor. Now comes the concept of galvanometer. We are about to finish the chapter. Once we finish the chapter, we'll take a break. We'll finish the chapter and we'll take a break. Now, guys, take a look. Galvanometer. We say galvanometer is a device which is used to detect the current. Galvanometer is a device which is used to detect the current. Okay. Which is used to detect the current. And it also measures the small range of currents. But galvanometer has a problem. Why? First one is it measures small currents. Range is small range. Okay. And it produces large error. It has a small range and it produces large error. This is the problem with the galvanometer. So if we have to measure the big currents, heavy currents, okay, and error must be also less, what are we supposed to do in that particular case? Then we do the conversion of galvanometer into an ammeter. We basically convert galvanometer into an ammeter. We make ammeter. How? See, this is the galvanometer. You have to make, and what is the maximum current that can flow through the galvanometer? IG. IG has some value. Let's suppose IG is 0.1 ampere. 0.1 is the maximum value of the current that it can measure. We do one thing, we connect a resistance in parallel. That is what we call shunt resistance. When you connect a shunt resistance parallel to the galvanometer, it becomes an ammeter. Now guys, see, if you send a large current over here, so IG will go through this galvanometer. What is the current which can flow through this one? I minus IG. Oh, Now, previously, if there was only galvanometer and you would send large current, this current is going to burn the galvanometer. Now, even if you send the large current, through galvanometer only Ig will flow. Through here, I minus Ig will flow. Now, they ask you to find the value of shunt. What is the value of the shunt? Shunt will be Ig into G. Ig is the current in the galvanometer. G is the resistance of the galvanometer divided by I minus Ig. This is the value of shunt resistance in galvanometer. Conversion of galvanometer into an ammeter. Connect a shunt resistance in parallel. Okay, so the value of shunt resistance will be Ig into G upon I minus Ig. Take a look. A galvanometer of resistance 100 ohms. There is a galvanometer. It has resistance 100 ohms. Value of G is 100. Is used to measure 10 ampere current. This can only measure 10 ampere current. So value of Ig is 10. Find the value of shunt resistance connected in parallel. If we connect the shunt resistance in parallel, so that its range becomes 50, so that it should measure the current of 50 ampere. Oh. Tell me, what is the value of shunt? Shunt is Ig into G upon I minus Ig. I minus Ig. So I can say Ig into G. Ig is how much? 10. G is 100 upon I minus Ig. That is 50 minus 10. That is 40. This will cancel. So 100 by 4. That is 25 ohms. So if you connect a 25 ohm shunt resistance in parallel, it is going to measure the 50 ampere current. Its range will become 50 ampere. Its range will become 50 ampere. Guys, try this question. Just a second, I'll come. Try this question. Now guys, take a look. In an ammeter, 0.2% of main current passes through the galvanometer. This is an ammeter. Galvanometer plus shunt. 0.2% current passes through the galvanometer. That is 0.2 I. This is the value of Ig. So if this is I, 0.2 will pass through the galvanometer. What will be the rest? I minus Ig will be how much? 99.8. 99.8 plus 0.2 is I, 100 I. Okay. If the resistance of the galvanometer is G, resistance of the galvanometer is G, resistance of the ammeter will be, means resistance of the whole ammeter is, guys see. Before finding the resistance of ammeter, can you find the resistance of shunt? Can you find shunt resistance? You would simply say, sir, in order to find the shunt resistance, listen carefully. In order to find the shunt resistance, I can say shunt is equal to Ig into G upon I minus Ig. Ig is 0.2I into G upon I minus Ig. That is 99.8I. I and I will be cancelled. 0.2 will be 2 by 10G upon 99.8 will be 998 divided by 10. This and this will cancel. 2 ones are 2, 499s are. So shunt will come out to be G by 499. Now, ladies and gentlemen, boys and girls, what I want you to understand in this particular case is, you got the value of shunt, you got the value of G. G is already known. So this is one resistance galvanometer. This is shunt. G divided by 499. You are supposed to find resistance of ammeter. What will you say? Resistance of ammeter would be resistance of this plus, means equivalent of this and this. When two resistors are in parallel, guys, directly remember, net resistance would be R1, R2 upon R1 plus R2. Now tell me, resistance of ammeter will be R1, R2, G into G divided by 499 upon G plus G divided by 499. Now this would be G square divided by 499 upon 499G plus G, that is 500G divided by 499. 499, 499, G square G. So resistance of the ammeter came out to be G divided by 500. G divided by 500. Conversion of galvanometer into a voltmeter. Voltmeter is a device, my dear NEET aspirants, which can measure the potential difference. Galvanometer is the device which can measure the current. So, in order to convert the galvanometer into a voltmeter, you connect the shunt resistance in series. In order to convert the galvanometer into an ammeter, you connect shunt resistance in parallel. Here you connect in series. Now, when you connect shunt resistance in series, you have to find, listen carefully, you have to find the value of shunt resistance. So, in voltmeter, value of shunt resistance is V divided by Ig minus, I would say, G. V divided by Ig minus, I would say, G. Where V is the potential difference of the voltmeter, Ig is the current in the galvanometer, G is the resistance of the galvanometer. Take a look at the question. A galvanometer of resistance 100 ohms. There is a galvanometer, it has resistance 100 ohms. Okay. G, 100 ohms. Gives a full scale deflection of 30 milliampere, means it can measure the current of 30 milliampere. If it is to work as voltmeter, if you convert this into a voltmeter, you connect the shunt resistance in series. Of how much range? Of 30 volt range. Of 30 volt range. Of 30 volt range. If you connect this to a, If it is to work as a voltmeter of 30 volt range, so potential difference across voltmeter is 30. The resistance required to added will be, how much is the shunt it is asking. So shunt will be V divided by Ig minus G. This is the value of shunt, V divided by Ig minus G. Now S is equal to, what is the voltage? What is the potential difference? How much is the range? That is 30. Ig, what is the value of Ig? 30 milliampere. 30 into 10 raised power minus 3. Because when you convert milliampere to ampere, you multiply with 10 raised power minus 3. Minus G, G is 100. Now 30 will cancel. So S will come out to be 10 raised power minus 3. When it goes into numerator, it will become 10 raised power plus 3. So it becomes 1000 minus 100. Shunt will come out to be 900. 900 ohms. Okay. Now guys, there is a concept called Wheatstone bridge. There is a concept called Wheatstone bridge. See, what does Wheatstone bridge concept actually say? Listen carefully. Let's suppose you have a resistance over here. You have one more resistance over here. You have one more resistance over here. You have one more resistance over here. And there is one more resistance. This is R1. This is R2. This is R3. This is R4. And this is R5. My dear NEET aspirants, we say if R1 by R2 will be equals to R3 by R4. If R1 by R2 is equal to R3 by R4, if this ratio by is equal to this ratio of this resistance by this resistance is equal to this by this, then no current flows through R5. Then no current flows through R5. Means if no current flows through R5, you can remove R5 because there is no use of this. Then remove R5. So if you remove R5, the circuit would look something like this. This circuit would look something like this. It will look something like this. And then, my dear NEET aspirants, you can find the equivalent resistance of this circuit. These two will be in parallel. These two will be in parallel. Now, let's suppose if we assume the value of this is R. Okay, let's suppose if I give you value of this R1 is R, value of this R2 is R, this is R, this is R, this is R. Now, can I say this ratio R by R is 1 is equal to this ratio R by R is 1? So you can remove the middle resistor. Now, what will be the net resistance in this particular case, guys? What will be the net resistance in this particular case? You can say net resistance will be R1, R equivalent. Guys, these two are in series, so their equivalent would be 2R. These two are also in series, so this is also 2R. Now this and this in parallel, so R equivalent in this particular case will be R1 R2 upon R1 plus R2. So that is 2R into 2R upon 2R plus 2R. So this would be 4R square divided by 4R. R and this will be cancelled, 4 and 4 will be cancelled, so net resistance is R. This is the concept of Wheatstone bridge. If potential difference across, if this R1 by R2 is equal to R3 by R4, you can remove the middle resistor because no current flows through the middle resistor. You can say it's reverse also. If no current flows through the middle resistor, then R1 by R2 must be equal to R3 by R4. Yes. On this concept, there is a bridge, there is a device that is called a meter bridge. On the same concept, we have a device that is called meter bridge. We say meter bridge is an instrument. Okay, meter bridge is an instrument used to measure the unknown resistance. It's a device used to measure the unknown resistance. Okay, now see, I will tell you. Now it is based on the concept of Wheatstone bridge. This is a meter bridge. This meter bridge actually has a known resistance. Known resistance means whose value we know. We know this is 15 ohms, 20 ohms, 17 ohms, whatever it is. And there is an unknown resistance which we have to find out. And there is a meter wire. Meter wire means 1 meter wires, 100 centimeter wire. And there is a galvanometer connected to this, and there is a jockey, means it is slidable, and there is a battery. Now take a look. If I say in this particular case, my dear NEET aspirants, this jockey is slidable on this meter wire. We can slide this jockey. Okay, one more important thing. This wire, we say resistance of this wire is R. Resistance of this wire is R. And length is L. Now we define resistance per unit length. Resistance per unit length. Resistance per unit length. Okay. That is what we call lambda. Lambda is equal to R divided by L. Okay. This is resistance per unit length. Now from here we can say resistance will be lambda into L. Now my dear NEET aspirants, if I say this is the wire, it has length L and resistance R. If I say this jockey is slidable, you keep on sliding this jockey until and unless you get the balance point. Keep on sliding the jockey until and unless you get the balance point. Balance point means when no current flows through this galvanometer. Sir, will I get that balance point? Yes. Let's suppose I'm sliding the jockey, I'm using the hit and trial method. At this point, we got the balance point. So when we place the jockey here, we saw the galvanometer showing that no current is flowing in it. So current through the galvanometer is 0. Now, could you please tell me what is the resistance of this portion of the wire? Resistance is how much? R into L. This balance point is at L1 distance. So the resistance of this would be lambda into L1. This is R1. Resistance of L1. Resistance of L1. So that is R1 is equal to lambda into L1. So what about this one? So resistance of guys, if total is 100 centimeter, this is L1. How much will be this? 100 minus L1. 100 minus L1. This would be R2. That is 100 minus L1 into lambda. Because lambda into 100 minus L1. Na? What I'm saying is that you keep on sliding this jockey until you get the balance point. Balance point means when no current flows through the galvanometer. Now, let's suppose you got the balance point at L1. So this L1 is the balance point. Balance point. When no current flows through galvanometer. L1 is the balance point when no current flows through the galvanometer. Okay. Now, boys and girls, listen to me very carefully. Now, don't you think it looks like a Wheatstone bridge? Now, it looks like a Wheatstone bridge. If it looks like a Wheatstone bridge, boys and girls, like this, a resistance, this resistance, this resistance, this resistance, this resistance. Take a look. This resistance P, this resistance Q. This resistance lambda into L1, this resistance 100 minus L1 into lambda. This is P, this is Q. This is lambda into L1. This is lambda into 100 minus L1. Now tell me, in this case, through the middle resistance galvanometer, this is actually galvanometer, current through the galvanometer is 0. What does Wheatstone bridge concept says? If current through the middle part is 0, if current through the middle branch is 0, then R1 by R2 is equal to R3 by R4. So we say here, I can say, sir, P divided by lambda into L1 will be equals to Q divided by lambda into 100 minus L1. Yes, this is the equation of meter bridge. That's it. With the help of this equation, you can find out the unknown resistance in the galvanometer. Let me show you how. Let's suppose you have the question over here. You have the question over here. This is a meter bridge. Okay, balance point, balance length. L1 is given as 20 centimeters. Okay. Now you have to find the value of X. You have to find the value of X, unknown resistance. What will you say? P divided by Q. Okay, sorry. P divided by lambda into L1 is equal to Q divided by lambda into 100 minus L1. Now tell me, what is the value of P here? I. So balancing length in the meter bridge will be given from there only. Divided by lambda into L1. Lambda L1 is how much? 20. Because L1 is 20. Is equal to Q. Q is X upon lambda into 100 minus L1. 100 minus 20, that is 80. Lambda, lambda will cancel. 0 and 0 will cancel. 2 ones are 2 fours are 8. 5 fours are 20. X will come out to be 20 ohms. Guys, give me the signal in the chats. Is this clear? Quick. Give me the signal in the chats. Is this clear? Everybody, guys. Quick. Quick. So we are done with this. Next chapter is magnetic effects of current. We'll take a break. Okay, and break is still. It's 5 o'clock approximately. Okay, 5:40. Because then we have to go scratch. Not 1 hour break, it's 40 minutes break. Instead of Kirchhoff's laws, I have shown you the midpoint potential. That is the easiest method by which you can do all the work, okay, without using the Kirchhoff's laws. Now, guys, let's dive into the session. Let's move on to the magnetic effects of current. Guys, smash the like button if you're not liked the session yet. So the first topic that we need to discuss over here is that's Biot-Savart's law. This is the first thing that we need to discuss. That is Biot-Savart's law. Biot-Savart's law. Now, boys and girls, listen to me very carefully. One thing I would want you guys to remember, that is, whenever a current flows through the wire, it produces magnetic field around it. Okay? Whenever a current flows through the wire, it produces magnetic field around it. Like this is a wire, current is flowing, it produces magnetic field here, 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 here. Now, what I want you guys to understand in this particular case, Biot-Savart's law helps us to find magnetic field due to a small current carrying element. So I'll write over here, magnetic field due to a small current carrying element. Magnetic field due to a small current carrying element. That's what we call the Biot-Savart's law. So Biot-Savart's law helps us to find the magnetic field due to a small current carrying element. Yes, sir. Now, my dear NEET aspirants, let's suppose we have got a wire over here. And in this wire, current is flowing. We know that a current carrying wire produces magnetic field around it. So you have to tell me, we'll consider a small element over here, that is dl. Now, if the current flowing is I, so we consider this as IDL, small current carrying element. Small element with current I in it. That's what we call the small current carrying element. So due to the small current carrying element, you have to tell me magnetic field at a distance r, at an angle theta, at this point P. So due to this, my dear NEET aspirants, small current carrying element, magnetic field at this point would be, that is dB is equal to mu naught I divided by, or I'll write it like this, mu naught by 4 pi IDL sine of theta divided by r square. This is the magnetic field due to a current carrying element at r distance. Mu naught by 4 pi is constant. Mu naught is what we call the permeability of free space. Current I is the current. DL is the small element. IDL means current carrying element. Theta is the angle between r and IDL. And in vector form, we write it like this. dB is equal to mu naught by 4 pi. I can say I dl cross r. Mu naught by 4 pi I dl cross r divided by, I would say, r cube. Divided by, I would say, r cube. I dl cross r divided by, I would say, r cube. This is the magnetic field due to a small current carrying element in vector form. This was asked in NEET 2020. Guys, from now onwards, you'll remember one thing. A current carrying wire produces magnetic field around it. And if somebody asks you, find the magnetic field due to a small current carrying element, not due to the entire wire, small current carrying element, That is mu naught by 4 pi I dl sine theta by r square. This mu naught is what we call permeability. Permeability of free space. And value of this mu naught divided by 4 pi, it is 10 raised power minus 7. Even you can say value of mu naught will be, take this 4 pi over here, 4 pi into 10 raised power minus 7. So Biot-Savart's law helps us to find the magnetic field due to a small current carrying element. Now guys, direction of magnetic field. How do you find the direction of magnetic field? See, place your thumb along the direction of current. Please do remember this method. This is thumb. Place, if this is a wire, place your thumb along the direction of current. Curl your fingers. That gives the direction of magnetic field. Then curl your fingers. When you curl your fingers, it is inward. So direction of magnetic field is in. At this point, my dear NEET aspirants, direction of magnetic field is outward. Place your thumb along direction of current. Curl your fingers, it is outward. So magnetic field due to this wire at this point is inward. At this point, it is outward. This is the magnetic field. Now, magnetic field due to finite wire. My dear NEET aspirants, with the help of Biot-Savart's law, you can find the magnetic field due to a current carrying element, small element. Now, if you want to find due to the entire wire, you integrate. But we'll not do that, we'll directly write. This is a finite wire in which current I is flowing. At r distance at point P, you have to tell me magnetic field. Join this point with one end of the wire. Join this point with another end of the wire. This angle is theta 1, this angle is theta 2. So due to this entire wire, magnetic field is going to be mu naught I divided by 4 pi r. I is current, r is the distance, perpendicular distance. Then you say sine of theta 1 plus I would say sine of theta 2. This is the magnetic field due to a current carrying wire, due to a finite current carrying wire at r distance. Let's suppose if you have an infinite wire. Let's suppose if you have an infinite wire, my dear NEET aspirants, I would want you guys to do one thing. In case of an infinite wire, its end is at infinity. From this side, it is at infinity. Join this with one end of the wire. Is that here? No. That is at infinity. So that is at infinity. So this would be theta 1. This would be theta 2. So in case of an infinite wire, theta 1 is 90. And I would say theta 2 is also equals to 90 degrees. Directly remember. And this expression is the general expression. So you can say magnetic field is going to be, that is mu naught I divided by 4 pi r sine of 90. Because sine of theta 1 is 90. Guys, directly remember, for infinite wire, theta 1 is 90, theta 2 is 90. Sine of 90 plus, I would say sine of 90. Now, sine 90 is 1, sine 90 is 1. You can clearly say 1 plus 1 is 2. So magnetic field is going to be mu naught I divided by 4 pi r, and this is 2 over here. This is 2 over here. 2 1s are 2, 2s are 4. So this magnetic field will come out to be mu naught I divided by, I would say, 2 pi into r. This is the magnetic field due to a finite wire. Due to an infinite wire, mu naught I by 2 pi r. What is the direction? Place your thumb along the direction of current, curl your fingers inward. And graph will be rectangular hyperbola because B is inversely proportional to R. Due to a semi-infinite wire. Semi-infinite wire means which goes till infinity from one side only, from one end only. Another end is finite. Guys, see, here in this particular case, we say theta A1 is, I would say, 90. Theta 1 is 90. And theta 2 in this particular case is 0. Guys, one end is at infinity. Join this end with one end of the wire. So that is at infinity. So theta 1 is 90. Another end is here. So join. Now theta 2 will be 0. Directly remember. So you can say magnetic field will be B is equal to mu naught I divided by 4 pi r. Then sine of theta 1, that is sine of 90 plus sine of theta 2, that is sine of 0. Sine 0 is 0, sine 90 is 1. So magnetic field is going to be mu naught I divided by 4 pi r. So this is the magnetic field due to an Semi-infinite wire, due to a semi-infinite wire. Okay, yes. Let's suppose this one. Guys, in this particular case, theta 1 is 90. Why? Because this is going till infinity. And theta 2 is not 0 right now. Theta 2 is given as theta 2. Theta 2 in this particular case is given as, let's suppose this is alpha. This theta 2 is alpha. Sir, can we consider this also as semi-infinite? 100% we can consider this as semi-infinite. Yes. So you can say magnetic field is going to be mu naught I divided by 4 pi r. Then you can say sine of theta 1, that is 90, plus sine of theta 2, that is alpha. So this is going to be mu naught I divided by 4 pi r. Then sine of 90 is 1 plus sine of alpha. 1 plus sine of alpha. Find the magnetic field due to the square loop at its center. Guys, see, the simple logic here is, if we want to find the magnetic field due to a square loop, it is better to write directly. See, logic is, in this square loop, it is made up of 4 wires. 1, 2, 3, 4. Okay. You find magnetic field due to one wire. How? Let me show you. Let's suppose you find magnetic field due to this wire and multiply that with 4. You find magnetic field due to one wire, multiply that with 4. Now tell me, this point join this with one end, this point join this with another end, and this is the perpendicular distance r. This is r. This is theta 1, this is theta 2. Now in case of square, this total angle is 90. So theta 1 will be 45, theta 2 will be 45. Okay, this is theta 1, this is theta 2. And this r, if the total length is L, so this will be, r will be equals to L by 2. R will be L by 2. Now, if you have calculated this, now can you tell me what is the magnetic field due to this one wire? So magnetic field due to this one wire, mu naught I divided by 4 pi r. Then you say sine of 45 plus sine of sine of 45. This is the magnetic field due to one wire. Put the values. So I can say magnetic field due to one wire, that is mu naught I divided by 4 pi r. 4 pi r means L by 2. Sine 45 is 1 by root 2. 1 divided by root 2. So 2 1s are 2 2s are 4. So magnetic field due to one wire is mu naught I divided by 2 pi into L. This is 2 by root 2. 2 and 2 will be cancelled. So mu naught I divided by root 2 pi into L. This is the magnetic field due to one wire. Now see, direction of magnetic field due to this wire is inward. Due to this also inward. Due to this also inward. Due to this also inward. So you can say net magnetic field in this case will be 4 times of magnetic field due to one wire. So you can write 4 times of mu naught I divided by root 2 pi into L. Now rationalize. Multiply with root 2 and divide with root 2. Now guys, we can write it like this. So this has to be 4 root 2 mu naught I divided by root 2 into root 2 is 2 pi into L. 2 1s are 2 2s are 4. So this is 2 root 2 mu naught I divided by pi into L. So better is to remember it directly, guys. It is better to remember directly. Magnetic field due to a square loop at its center is 2 root 2 mu naught I divided by pi into L. It is better to remember directly. Okay. Now see, magnetic field on the axis of a circular loop. Magnetic field on the axis of a circular loop. Magnetic field on the axis of a circular loop. Take a look, my dear NEET aspirants. Magnetic field on the axis of a circular loop. See, this is a circular loop. And in this circular loop, radius is r. You have to find the magnetic field at x distance. Current is I flowing. Due to this circular loop, magnetic field at x distance will be mu naught I into r square divided by 2 into r square plus x square whole raised power 3 by 2. This is the magnetic field due to a circular loop at x distance. At x distance from the center. If I say at center, what is the value of x? 0. So I can write over here at x, at center, value of x is equal to 0. If you put x is equal to 0 over here, magnetic field will come out to be mu naught I into r square divided by 2 into, this term would become 0, r square whole raised power 3 by 2. So I can say this 2 and 2 will be cancelled. So it will come out to be mu naught I into r square divided by 2 into r cube. Cube and square will be cancelled. R square and cube will be cancelled. So it will come out to be mu naught I divided by 2r. So basically, my dear NEET aspirants, magnetic field due to a circular loop at its center will be mu naught I by 2r. Magnetic field due to a circular loop at its center will be mu naught I by 2r. Yes. 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 Mu naught I divided by 2r. Is that clear? Is that clear? Yes, this is important. Magnetic field due to a segment of ring. This is a segment of ring. Segment of ring means some part of the ring, some portion of the ring. Let's suppose in this segment of ring, current is flowing as I. And from here to here, radius is R. If you join this one end of the ring, sir, is this a semicircular ring? No. Some portion of the ring. If you join this another end of the ring, this is also radius R. So this angle is theta. Magnetic field due to this segment of ring at the center would be mu naught I by 2r, theta by 2 pi. Let's find the direction. Let's find the direction. Let's find the direction. Direction would be, in case of a circular ring, direction would be, curl your fingers along the direction of current. Curl your fingers along the direction of current. Thumb gives the direction of magnetic field. Thumb gives the direction of magnetic field. So I would write over here, direction. So curl your fingers along current. Curl your fingers along current. Thumb gives the direction of magnetic field. Curl your fingers along the direction of current. Thumb gives the direction of magnetic field. So in this particular case, magnetic field is outwards. So this dot means outwards. Cross means inwards. Due to a semicircular loop, let's suppose current is flowing in a semicircular loop I. This is the center. From here to here, this is radius R. From here to here, this is radius R. Angle between the two is 180. So in this case, theta is 180, or I would say pi. So if I say, my dear NEET aspirants, magnetic field, you would say magnetic field would be mu naught I divided by 2r, theta by 2 pi. Because the expression of the arc we consider as the general expression. So magnetic field in this case would be mu naught I divided by 2r. Theta over here is pi. Pi divided by 2 pi. Pi and pi will be cancelled. 2 into 2 is 4. So magnetic field is mu naught I divided by 4r. So this is the magnetic field due to a semicircular ring. Let's find the direction. Curl your fingers along the direction of current. Thumb is pointing outwards. So this is dot. Okay, this is due to a chord. In one complete ring, you have got 4 chords. Now, join this with one end of the ring. This is radius R. Join this with another end of the ring. This is radius R. Angle between the two is theta. So in case of a chord, theta is 90, or we say pi by 2. Pi by 2 radians. So magnetic field expression would be mu naught I divided by 2r, theta by 2 pi. Theta is pi by 2 into 2 pi. Theta is pi by 2 into 2 pi. Now this pi and pi will be cancelled. So this is mu naught I divided by 2 into is 4, 4 into is 8R. So magnetic field would be mu naught I divided by 8R. This is the magnetic field due to a cord. This is the magnetic field due to a cord. Let's take a look at this. One more important thing. If let's suppose this is a wire in which current I is flowing. If they ask you to find the magnetic field at this point lies along the axis of the wire. Magnetic field at this point would be 0. If the point lies on the same line upon which wire is present, then the magnetic field would be 0 in that particular case. Then the magnetic field would be 0 in that particular case. Take a look. If I say you have to find the magnetic field due to this structure at this point. See guys, due to this structure at this point. See, magnetic field, this is a semicircular wire. This is a straight wire. This is also straight wire. Let's consider this 1, 2, this is 3 and 4. Now the center lies along the same line upon which this is present. This is also along the same line. So can I say magnetic field due to this third wire will be equals to magnetic field due to this 4 wire and it will be 0? Yes. So magnetic field will be due to the semicircular wire, due to the semicircular wire. Now let's find the direction. Curl your fingers along the direction of current. Thumb is pointing inwards. Magnetic field of this is inwards. Curl your fingers along the direction of current. Thumb is pointing inwards. So the direction of magnetic field of both is inwards. So I would say net magnetic field would be B1 plus B2. B1 plus B2. This is also inwards cross. This is also inwards. Now due to a semicircular wire, how much is the magnetic field? Mu naught I by 4R. So you would write over here, due to this mu naught I divided by 4R. What is R? R is the radius of this, that is 2R. Plus magnetic field due to this mu naught I divided by 4R. So if I say net magnetic field in this case, guys, you can take mu naught I by 8R plus mu naught I by 4R. How much will be that? 3 by 8. 3 divided by 8 mu naught I divided by R. Please do check this from your end. So, and direction would be inwards. Okay, what about this? Magnetic field, find the magnetic field at point O. Listen carefully. At point O, magnetic field will be due to this semicircular wire, sorry, semi-infinite wire, semicircular wire, semi-infinite wire. Let's find the direction. Direction of this. Place your thumb along the direction of current. Curl your fingers at this point, inward. Direction due to this. Curl your fingers along the direction of current. Thumb is pointing inwards, inward. Direction of this. Place your thumb along direction of current. Curl your fingers inward. So magnetic field net in this particular case would be B1 plus B2 plus I would say B3. Because all the 3 magnetic fields are inward. So this is inward, this is inward, this is inward. Now, due to the semi-infinite wire, mu naught I by 4 pi R, this distance R, plus due to the semicircular wire, mu naught I by 4R, due to this semi-infinite wire, mu naught I divided by 4 pi R. So this is twice. 2 times mu naught I divided by 4 pi R plus mu naught I divided by 4R. This is going to be the net magnetic field in this case. Is this clear? Is this clear? And this would be inwards. Now further also you can simplify this. Further also you can simplify this. Now comes the Ampere-Circuital law. Ampere-Circuital law. Now guys, when it comes to the Biot-Savart's law, Biot-Savart's law was the law by which we can find the magnetic field. Ampere's law is also the law by which we can find the magnetic field. Now this has got the different rules. Biot-Savart's law has got the different rules. So my dear NEET aspirants, what I want you guys to understand in this particular case is, if I ask you, you have to find the magnetic field due to this infinite wire using Ampere's law. We know that will come out to be mu naught I by 2 pi r. That we know. But I have to tell you, I have to make you understand, how do we use the Ampere's law? What are the rules by which we can use the Ampere's law? Take a look. First and the foremost thing, let's suppose this is a current wire I. This is a wire in which current is flowing. We have to find magnetic field at r distance. Ampere said, draw an Amperean loop such that the loop must pass through that particular point. Draw a loop known as Ampere's loop, and the loop must pass through that particular point. So the loop must pass through that particular point. And then assume the magnetic field at this point as B. Assume the magnetic field at this point as B. Okay, what is the first thing? Draw a loop such that the loop must pass through that point. Then assume the magnetic field due to this wire at this point B. Then take the small element of this loop. Small element of this loop is dl. Okay, what does Ampere say? Draw a loop such that the loop must pass through that point. Then assume the magnetic field due to wire at this point B. Then take the small element of the loop as dl. Then do the line integral of B and dl. Means then do the integration of B and dl, B dot dl. Okay. And make this equal to mu naught times of I enclosed. That's it, my dear NEET aspirants. This is Ampere's law. Ampere's law says that if you have to find the magnetic field at a point, you draw an Ampere's loop, imaginary loop, through that point. Assume the magnetic field B at that point. Take the small element of the loop at that point. Then do the integration of B and dl. Then make it equal to mu naught times of enclosed current. Enclosed current means the current present inside the loop. Now see, the point over here I'll write, I'll show you, wait. If magnetic field and dl are in the same direction, okay, it's mentioned here. If magnetic field and dl are in the same direction, then consider current as positive. If magnetic field and dl are in the opposite direction, then consider current as negative. Then consider current as negative. Now take a look. Use Ampere's law. Ampere's law says that closed line integral B dl is equal to mu naught times of enclosed current. Now, this is the loop. Enclosed current is which one? I1 and I2. I3 will not be considered as enclosed current. So this is I1 and this is I2. Now you have to mention which current is positive and which current is negative. Listen carefully. If B and dl are in the same direction, then current is positive, otherwise opposite, otherwise negative. Let's suppose this is the current I. Due to this current, what is the direction of magnetic field at this point? Place your thumb along the direction of current, curl your fingers. So direction of magnetic field due to this current is in the same direction of dl. Sir, this dl will be given in the question, 100%. The direction of dl will be given in the question. So magnetic field due to this wire at this point will be like this, upward. Either you say upward or you say inward. Inward or upward. So both are in the same direction. If B and dl are in the same direction, so its current due to which B1 is created will be considered as positive. I is positive. Now see, what is the direction of magnetic field due to this wire at this point? Place your thumb along direction of current, curl your fingers. So magnetic field due to this at this point, B2 will be outwards or downwards. So magnetic field and DL are in the opposite direction. So this current will be negative. That's it. You have nothing else in the Ampere's law. You have nothing else in the Ampere's law. Let's suppose if I give you this question. Apply Ampere's law. Apply Ampere's law. This is I1. This is I2. This is the direction of the loop. This is the direction of the loop. So integral BDL is equal to mu naught times of enclosed current. Enclosed current is I1, I2. Let's find the direction. This is the direction of DL. This is the direction of current. Place your fingers along the direction of current, inward. Curl your finger. Sorry, place your thumb along the direction of current. Curl your fingers. So this would be the direction of magnetic field B1 due to this current. Now B1 and DL are in the opposite direction. So this would be negative. Okay, due to this, place your fingers, thumb along the direction of current, outward. Dot means outward. Curl your fingers. So this is the direction of B2 magnetic field. B2 and DL are in the opposite direction. So this current would be negative. Magnetic field due to a hollow cylinder. Is this clear till over here? Let me know in the chats. Everybody out there. Is this clear? Is this clear? Magnetic field due to a hollow cylinder. Magnetic field due to a hollow cylinder. My dear NEET aspirants, let's suppose this is a hollow cylinder over here. Pipe. And current is flowing through this hollow cylinder. Since it is hollow, current cannot flow through its cross section because nothing is present inside. Current will be flowing through the surface. So current inside is 0. Radius of the cylinder is R. Now since current is flowing, it is creating the magnetic field. You have to tell me the magnetic field outside at small r distance. You have to tell me the magnetic field on the surface. You have to tell me the magnetic field inside. Inside also small r. My dear NEET aspirants, magnetic field outside, and this is an infinitely long hollow cylinder in our syllabus. Magnetic field outside, my dear NEET aspirants, this is going to be the magnetic field outside. Mu naught I divided by 2 pi r. So this is the magnetic field of infinite wire. Yes, because from a very large distance, this hollow cylinder will appear to us as an infinitely long wire. It will appear to us as an infinitely long wire. That's the reason we say outside it would be like this. And my dear NEET aspirants, if I say at surface, what is the value of small r? That is capital R. Put small r is equal to capital R. So magnetic field on the surface would be mu naught I divided by 2 pi into capital R. This would be the magnetic field on the surface. And what about the current inside? Zero. So magnetic field inside would be zero. Why? Because if there is no current inside, so magnetic field inside is zero. Now, if I say, my dear NEET aspirants, graph. This graph was asked in 2021. Graph between magnetic field versus R. From center to surface, that means inside, magnetic field is zero. Outside, magnetic field is inversely proportional to R. So from, I would say, center to surface, this is center where R is equal to 0. And this is R is equal to capital R surface. So I would say from center to surface, magnetic field is 0. And outside, magnetic field is inversely proportional to R. So this would be the graph, rectangular hyperbola. Magnetic field due to solid cylinder. Okay. Take a look. Outside, my dear NEET aspirants, magnetic field is mu naught I by 2 pi R. This is a solid cylinder. Solid cylinder means which is not hollow from inside. It's filled. So current is flowing through its cross section. In case of a solid cylinder, current flows through its cross section. And its radius is R. You have to tell me magnetic field outside. You have to tell me magnetic field on the surface. You have to tell me magnetic field inside. For outside point, small r is greater than capital R. Radius. For inside point, small r is less than capital R. This is the magnetic field outside. Because from a very large distance, both hollow cylinder or solid cylinder, it will appear to you as a infinite wires. These are infinitely long. Infinitely long. Now, if I say at surface, what is going to be the magnetic field? Mu naught I divided by value of small r is capital R on surface. That is 2 pi into capital R. And if I say inside, boys and girls, magnetic field inside would be mu naught I into R divided by 2 pi R square. R is the distance, small r is the distance from the center to that point. Capital R is the radius. And clearly, if you see B inside is directly proportional to small r. And you can clearly see B outside is inversely proportional to small r. So the graph, very important. So the graph would be, guys, this is center where R is equal to 0. This is surface. From center to surface inside, I would say magnetic field is directly proportional to R. And outside, magnetic field is inversely proportional to R. Is this clear? Is this clear, boys and girls? Tell me. Tell me, is this clear? Nibba nibbies in the chats. You are a flirt. Can you? Somebody is writing. I gave you my number. You didn't call. Huh? Enjoy, enjoy, enjoy. Make sure you smash the like button. Huh? Okay. After NEET examination, you will cry. You will cry. Okay. Okay. Magnetic force. Magnetic force. Now, my dear NEET aspirants, what does magnetic force actually mean? If a charge is placed in a magnetic field and is given some velocity, magnetic force acts on it. Whenever you place a charge in an external magnetic field and some velocity is given to it, it experiences the magnetic force. It experiences the magnetic force. Like, this is the magnetic field in this region. Okay. This is the magnetic field. And there is a charge placed over here. And this charge is given some velocity, my dear NEET aspirants, V. Whenever some velocity is given to a charge in a magnetic field, it experiences magnetic force. And that magnetic force is equal to, F is equal to Q into V cross B. Q is the charge, V is the velocity, B is the magnetic field. V cross B is VB sine of theta, where theta is the angle between velocity and magnetic field. Let's suppose, okay, QV, let's suppose if the charge is at rest, velocity is 0, so magnetic force would be 0. So in order to, like if you place a charge in the external magnetic field, if you want the magnetic force should act on the charge, then you must give some velocity. Now guys, see, case 1. If this is the magnetic field and this is the charge, my dear NEET aspirants, in this magnetic field, charge is moving with certain velocity, but velocity and magnetic field are parallel. So angle between velocity and magnetic field is 0. How much will be the force? QVB sine of 0. Sine 0 is 0. In this case, force will be 0. My dear NEET aspirants, if theta is 180, means magnetic field is backward and charge is moving in the forward direction. So theta is 180. So you can say QVB sine 180. Sine 180 is also 0. So magnetic force would be 0. Okay. And if theta is 90, my dear NEET aspirants, if theta is 90, like here, charge is moving in the upward direction, velocity is upward, magnetic field is inward. Inward and upward, how much is the angle? 90. So in that case, you will write QVB sine 90. Sine 90 is 1. So QVB. Let's take a look at this particular question. This is a very good question, I must say. A charged particle of specific charge means charge per unit mass. Charge per unit mass means Q by M. Value of Q by M is given as 0.2 coulomb per kg. Means on 1 kg charge, how much, on 1 kg mass, how much charge is present? 0.2 coulomb. Has a velocity, this is the velocity, that is 2I minus 3j cap. At some instant in a uniform magnetic field, and magnetic field is 5I cap plus 2j cap. Find the acceleration of the particle at this instant. You are supposed to tell me acceleration of the particle. Guys, see, when you say acceleration of the particle, acceleration is force upon mass. Now, there is a charge placed in the external magnetic field and velocity is also given. So we say magnetic force will act. that magnetic force will be Q into V cross B divided by M. Now, value of Q by M, you already know that is 0.2. You have to find the value of V cross B. Now, guys, see. V vector cross B vector. Cross product of V and B. Now, V and B, how do you find the cross product of two vectors? Listen. First, you have V vector. Whenever you do the cross product of two vectors, you make a determinant, means draw these two lines. Then write over here I cap, J cap, and K cap. First, you'll be mentioning the coefficients of V, then B, because it is V cross B. So that is 2, -3, and 0. So 2, -3, and 0. Then you would be mentioning the coefficients of this 5, 2, and 0, because K is 0 now. 5, 2, and 0. Now you have to solve. First, you solve it for I cap. Now, how do you solve for I? Write I over here. Now, my dear NEET aspirants, hide that column in which I is present and hide that row in which I is present. First column and first row. Now, what are the remaining elements? 3, 0, 2, 0. Do the cross. Do the cross of the remaining elements. 3 into 0, 0, minus. 2 into 0, 0. Then minus J. Solve it for J. But in front of the J, you put negative sign. In front of I, you put positive. Hide that column in which J is present and hide that row in which J is present. First row and second column. Now, 2 into 0, 5 into 0. Do the cross. So 2 into 0 minus 5 into 0. Then plus. Now solve it for K, my dear NEET aspirants. Hide that column in which K is present. Hide that row in which K is present. Now do the cross. 2 into 2, 5 into -3. So you would say 2 into 2 is 4, minus 5 into -3 is -15. So this is 0, this is 0. Minus into minus is plus 15 plus 4 is 19. So it will come out to be 19 K cap. This is V cross B. Now guys, acceleration will come out to be Q by M. Q by M is how much? 0.2 into V cross B. V cross B is 19 K cap. 0.2 into 19, it would be 3.8 K cap meter per second square. This would be the acceleration of the particle. This would be the acceleration of the particle. This would be the acceleration of the particle. Okay. Now, case 3. If theta is equal to 90 degrees. Guys, directly remember. If a charged particle enters the magnetic field at an angle of 90 degrees, magnetic field is inward, velocity is forward. Whenever charged particle enters the magnetic field at an angle of 90 degrees, it moves in a circular path. It moves in which path? Circular path. Whenever charged particle enters the magnetic field at 90 degrees, it moves in a circular path. Directly, remember. If it moves in a circular path, if somebody says, what is the radius of that circular path? Radius of that circular path would be mv by qb. M is the mass, V is the velocity, Q is the charge, B is the magnetic field. Even from this, you can find the velocity of the charge also. This velocity will be, take it over there, QBR divided by M. Now, if somebody says, this is the radius in terms of mass and velocity, momentum. In terms of kinetic energy, my dear NEET aspirants, okay, this was mentioned over here, velocity. Radius in terms of kinetic energy is under root of 2mke divided by qb. 2m is mass, k is the kinetic energy, qb, q is the charge, b is magnetic field. This is the radius in terms of, I would say, this is the radius in terms of kinetic energy. Okay, one more expression is there. Radius in terms of potential difference under root of 2mq delta V. Delta V is the potential difference divided by QB. This is the radius of that circular path in terms of potential difference. This is the radius of that circular path in terms of in terms of kinetic energy. In terms of kinetic energy. This is the time period. Time period is the time in which it completes one cycle. This is the time period. And frequency also. Frequency is inverse of time period. That is QB divided by 2 pi into m. Frequency means number of cycles per second. In 1 second, how many circles it will complete. So what do you remember over here? If a charged particle enters the magnetic field at an angle of 90 degrees, it moves in a circular path. Radius of that circular path would be, in terms of mass into velocity, it would be mv by qb. In terms of kinetic energy, under root of 2m kb by qb. In terms of potential difference, under root of 2m q delta v divided by qb. Time period would be, in how much time it is going to complete one cycle, 2 pi m divided by qb. Frequency would be qb divided by 2 pi m. Okay. Now guys, take a look. Take a look. Okay. One more important thing I just want to mention over here, direction of force. Direction. This is important. Direction of magnetic force. Direction of magnetic force. You'll be using right hand palm rule. Place your fingers along magnetic field. Thumb along current. Thumb along current. Place your fingers along magnetic field. Thumb along current. Palm gives the direction. Palm gives the direction of magnetic force. Palm gives the direction of magnetic force. Okay, palm gives the direction of magnetic force. Like, this is the magnetic field. In this magnetic field, charge is present. This is moving with a velocity v. Let's find the direction of magnetic force. Place your fingers along the direction of magnetic field. Thumb along the direction of velocity. This is called palm. Palm is facing upward. So this is the direction of magnetic force. This is the direction of magnetic force. Okay, this is a question, an important question. A proton and an alpha particle accelerated through same potential difference in a region of uniform magnetic field. Guys, see. This is a magnetic field. In this magnetic field, a proton and an alpha particle is placed. A proton and an alpha particle is placed. Okay. This is a proton. Okay. It will follow the circular path, and alpha particle. It will follow the circular path. They have the same potential difference. Accelerated through same potential difference, enter in the region of uniform magnetic field. They enter in the region of uniform magnetic field. Okay, yes. With their velocities perpendicular to the field. Now, when their velocity is perpendicular to the field, they will follow which path? Circular path. Compare the radius. You are supposed to find the radius of proton divided by radius of alpha particle. Now, guys, which of the three formulas you are going to apply over here? Which one? Momentum one, kinetic energy one, or the potential difference one? Obviously, potential difference one, because same potential difference is given in this question. We say radius is equal to under root of 2mq delta v divided by qb. Now, boys and girls, tell me one thing. If I talk about proton, if I talk about alpha particle, we know mass is m, mass is 4m. Charge is E, charge is 2e. Already I have told you. Now, those quantities which are same for both, eliminate those from the equation because those become constant. See, guys, both are placed in the same magnetic field. Same magnetic field. Magnetic field is same. Both have got the same potential difference. So delta V magnetic field is constant. So this radius will only depend upon what? Under root of m, mass is different, q, charge is different, divided by q. Now let's try to make the equation bit simple, because here in numerator root q, in denominator q. Do one thing. Multiply with root q and divide with root q. Do the rationalization. Root q into root q is q. That q and this q will be cancelled. Now what remains over here? Radius will only depend upon under root of m divided by this charge q. Now if I say, my dear NEET aspirants, radius of proton divided by radius of alpha particle, it depends upon root of m by q. What will you say? Under root of, what is the mass of proton m, charge of proton e? So m divided by e upon under root of, what is the mass of alpha particle? 4m, charge is 2e. So this is 4m and charge is 2e. So radius of proton divided by radius of alpha particle is equal to, tell me one thing, boys and girls. This would be under root of m divided by e into under root of 2e divided by 4m. Now guys, root e, root m will cancel. So it will be root 2 divided by root 4 is 2. Now rationalize. Root 2 multiply root 2. Divide with root 2, multiply with root 2. Root 2 into root 2 is 2. That will be cancelled with this 2. So 1 divided by root 2 is the final answer. So radius of proton divided by radius of alpha particle, 1 divided by root 2. This is actually a very good question. Okay. Is this clear, or tell me in the chats? Just a second, I will come. Now guys, let's take a look at this one. Let's take a look at this one. Force, force on a wire. Force on a wire placed in the external uniform magnetic field. Force on a wire placed in the external uniform magnetic field. Take a look. Guys, see, let's suppose you have a magnetic field over here. This is the magnetic field inward, in which a rod is placed. This rod is placed. Length of the rod is L and current flowing in the rod is I. If a rod is placed in an external magnetic field, force acts on it. Force on it will be, whenever you place a current carrying rod in the external magnetic field, it experiences force. And that force, my dear NEET aspirants, is going to be F is equal to I into L cross B. I is the current, L is the length, B is the magnetic field. Or we can say LB sine theta, ILB sine theta. Theta is the angle between length and magnetic field. Now, case 1. If, my dear NEET aspirants, let's suppose this is a magnetic field and this rod is placed something like this. This is length. Now, length and magnetic field are parallel. What is the angle between the two? Theta is equal to 0. Or if I say theta is equal to 180 degrees. In that particular case, force on the rod will be ILB sine of 0. Sine 0 is 0. So force will be 0. Now, how do you find the direction of force? Now guys, see, I'll tell you the direction of force. I'll tell you the direction of force. Listen. Direction of magnetic force. FB means magnetic force. In case of a wire placed in the external magnetic field. So it is, boys and girls, it is place your fingers along magnetic field. Place your fingers along magnetic field. Thumb along current. Right hand, palm rule. Place your fingers along magnetic field. Thumb along current. Palm gives the direction of magnetic force. Palm gives the direction of magnetic force. Take a look. Like guys, this is a wire over here. You have to find the direction of magnetic force. Take your right hand. Place your fingers along the direction of magnetic field. It is inwards, so place inwards. Thumb along the direction of current. Current is upward. This palm is facing towards left. Palm gives the direction of magnetic force. See, this is the direction of magnetic force. Yes. Yes. Now, one more important thing, my dear NEET aspirants. Let's suppose you have a question something like this. So, magnetic field is given as 1 Tesla. This is the question. Yes. Magnetic field is given as 1 Tesla. You are supposed to find the force on the given loops as shown. Find the force on the given loops as shown. Now guys, listen to me very carefully. This is a loop over here. In this loop, current is flowing 2 ampere, and then this current comes back something like this. Now, my dear NEET aspirants, if you want to find the force, whenever a wire, current carrying wire is placed in external magnetic field, it experiences force. It experiences force. You want to find the force on this one. Listen carefully. I want you guys to focus exactly over here. This structure is made up of two wires. This one, okay, and this one. Let's first find the force on this one. Whenever you have a wire which is not straight, like this, in this particular case, if you have to find the force, force is I, L, B sine of theta. Listen carefully. Sir, what is the current is I? Current is I. Magnetic field is B. What is the length you are supposed to take? Sir, shall we consider this length? No. You are supposed to consider effective length. This will be the effective length. Join one end of the wire with another end. This will be effective length. If this is R, this is R. So L effective is 2R. So here it will be L effective. So I can say F is equal to I. L effective is 2R. Magnetic field is B. Sine of theta. Theta is the angle between L and B. This is L effective. And magnetic field is inwards. So angle between this and this is 90. So sine 90 is 1. Sine of 90. So you can write magnetic field will be 2IB into R. Absolutely, sir. Okay, direction. Let's find the direction. Place your fingers along the direction of magnetic field. And thumb along the direction of current. Guys, if current is basically going from this end to this end, from left end to right end, so here also you are supposed to make current from left to right. So place your fingers along the direction of current. Sorry, place your fingers along direction of magnetic field, thumb along direction of current, palm is facing upwards. So force on this will be upwards. This is the magnetic force and this is upwards. Now let's take this structure. Let's take this wire. This is the wire. Now this wire has the length. This is R and R, 2R. Its length is 2R itself. What is the magnetic force? That is ILB sine of theta, and theta is 90. Why? Because this is the length and magnetic field is inward. Angle between length and magnetic field is 90. So this would be magnetic force in this case. I, L is 2R. Then we say B, sine 90 is 1. Same force. Now let's find the direction. Direction on this wire would be, place your fingers along direction of magnetic field. Thumb along the direction of current. Palm is facing downwards. So force on this would be downwards. So on this force is upwards. On this force is downwards. Don't you think force is similar? Equal and opposite. So what is going to be the net force on this one? Net force is 0. Net force is 0. Okay, in the second portion, in this one. Now, boys and girls, listen to me very carefully. It is exactly the same. If we take the upper portion, this, we already calculated force on this upper portion. How much is the force on this upper portion? 2IB into R. And direction also here, direction of current, same direction of current. So direction of force would be upwards. Yes. Now, on this portion, now the current here is like this. Now, on this also we have calculated the force, that is F is equal to 2IB into R. Okay. Let's find the direction. Magnetic field is inward. Place your fingers along the direction of magnetic field. Thumb along the direction of current. Palm is facing upwards. So on this also force is upwards. So here, force on this is upward. Force on this structure is upward. It is because the direction of the current is, here also it is like this, here also it is like this. Now, boys and girls, when the two forces are acting in the same direction, we say net force will be 2 times of this plus this. That's 2 times 2IB into R. So this would be 4IB into R. So this would be 4. What is the value of current? Current is 2 ampere. Magnetic field is 1. Radius of this loop is also 1. So current is 2, magnetic field is 1, radius is 1. 4 and 2 is 8. So this is going to be 8 Newton. So one thing I would want you to focus, sir, in this case, magnetic force came out to be 0. So you'd remember one thing. If let's suppose you have a loop, let's suppose this loop, current is flowing in this loop and it is placed in the magnetic field. Always remember net force on the loop is 0. If the direction is unique, unique means if it is only clockwise or it is only anti-clockwise. But here, only clockwise. See here, clockwise, anti-clockwise. That's why net force does not come out to be equal to 0 in this case. If I say this one, what would be the net force? Net force is 0. Even if you calculate, it will be 0. But direction must be unique. Either only clockwise or only anti-clockwise. Then net force would be 0. Okay, what about this one, sir? Let's suppose this, here current is flowing, here current is flowing. Okay, in this case, net force will not be equal to 0. Keep this thing in your mind. Next, force on a wire, or you can also say this is force between two parallel wires. Force between two parallel wires. Force between two parallel wires. Is this clear till over here? Tell me. Now, guys, let's take a look at this particular question over here. Take a look. What does it actually say? Listen to me very carefully. What does it actually say? It says force on I2 wire due to I1 wire, or you can say force between two parallel wires. Force between two parallel wires. Okay. It is, or you can directly remember it, force between two parallel wires. Okay, force between two parallel wires. My dear NEET aspirants, you have got a wire over here. This is infinitely long. And in this infinitely long wire, I would say current I1 is flowing. Now, there is another wire over here, which is having the length L, in which current I2 is flowing at our distance. Now, if I directly say, without any discussion, sir, this wire is going to apply the force on this wire. Even this wire will also apply force on this wire. Now, if I say force on wire 1 due to force on wire 2 due to wire 1, that would be F is equal to mu naught I1, I2. I1 is the current in first wire, I2 is the current in second wire, divided by 2 pi r. R is the distance, into L. L is the length of the second wire. So this is the force on second wire due to first wire. This is the force on second wire due to first. This is the force on second wire due to first. Now, if I say, you tell me force per unit length. Force per unit length means this expression. This is the force on the entire wire of length L due to wire 1. If I say force on the unit length, consider unit length over here. What is the force on this unit length? So force on the unit length will be, that's what we call force per unit length. This is F divided by L. Total force divided by total length. What is the total force acting on the wire? Mu naught I1, I2 into L divided by 2 pi r. Divided by L. L and L will be cancelled. So this is mu naught I1, I2 divided by 2 pi r. This is the force on the unit length of wire 2. Force per unit length. So one thing you would remember in this case, just a second. One thing you would remember over here, my dear NEET aspirants, listen to me very carefully. If let's suppose you have two wires, this is a wire, this is wire. Okay. Current in this wire is given as I1. Current in this wire is given as I2. And both the currents are flowing in the same direction. Both the currents are flowing in the same direction. Both the currents are flowing in the same direction. Okay. Distance between them is R. Whenever two wires current is flowing in the same direction, always remember they apply a force on each other. That would be attractive. They attract each other with a force. And if I say, what is the force per unit length? Force per unit length on each wire. That is going to be mu naught I1, I2 divided by 2 pi r. Okay, this is going to be force per unit length. That is force divided by L. Now take a look, guys. This is a figure over here. This is a previous year question. In this case, you are given three wires. Wire A, wire B, and wire C. And the direction of the current in the three wires is outward. See, this is the direction of the current outward. Here direction is outward. Here direction is outward. Direction in all the three cases is outward. Now you have to find the net force on the middle wire. This is the question it is saying. Magnitude of force per unit length on the middle wire B is given by. What is the net force on middle wire B in this case? Guys, tell me. Whenever you have two wires parallel to each other, current moving in the same direction, like here outward, they attract each other. So force on the middle wire, force on B due to C, it would be like this. So force on B due to C, it would be like this, F. Force on B due to A, it would be like this, F. Now if this is F, this would be the resultant F. That is a root 2 of F. This is net, a root 2F. So if I say net in this particular case is root 2F, F would be what? That is force between this wire and this wire. Mu naught I1, I2, mu naught I into I becomes I square, divided by 2 pi into R, 2 pi into D, because D over here is the distance between the two. D over here is distance between the two. Now multiply with root 2 and divide with root 2. Root 2 into root 2 is 2. So this root 2 is 2, multiply it, cancel with this 2. So it will become mu naught I square divided by root 2 pi into D. So this would be the net force. This would be the net force on the middle wire due to other two wires. Next. Okay. Now guys, magnetic field due to solenoid. Magnetic field due to a solenoid. I would want you guys to focus exactly over here. Magnetic field due to a solenoid. Solenoid is this wire. This is what we call the solenoid. This solenoid. And if the current is flowing in this wire, it creates magnetic field. So my dear NEET aspirants, if you have to find the magnetic field due to a solenoid, how much is going to be the magnetic field due to a solenoid? Understand this very carefully. Magnetic field due to a solenoid would be simply, magnetic field due to a solenoid would be simply mu naught N into I. This is the magnetic field due to a solenoid. This N means number of turns per unit length. On the unit length of the solenoid, how many number of turns are there? How many number of turns are present on the unit length of the solenoid? And this N will be N divided by L. N divided by L. N means total number of turns. Total number of turns divided by total length. Divided by total length. Total number of turns divided by total length. So I can say this magnetic field due to a solenoid would be mu naught, instead of small n, I can write capital N, I divided by L. This would be the magnetic field due to a solenoid. Okay, yes. And my dear NEET aspirant, this magnetic field which I have gave you, this is at the center of the solenoid. Magnetic field at the ends of the solenoid is 1 by 2 times of mu naught N into I. Means whatever is the magnetic field at center, at the ends, it will be half. It will be half. So graph, variation of magnetic field with distance. Now guys see, magnetic field inside the solenoid is constant. So this is a solenoid, magnetic field inside is constant. So means if this is a solenoid from here to here, inside it will be constant. At the ends of the solenoid, magnetic field is going to decrease. At the ends of the solenoid, magnetic field will be half. So that's why at center it is constant. At the ends, you see this magnetic field is B by 2. Whatever is at the center, it's half B by 2. Okay? Yes. Then comes the toroid. Then comes the toroid. A toroid is considered as a ring-shaped closed solenoid. Now guys see, let's suppose you have a solenoid over here. This is a solenoid. You want to convert it to the toroid. You want to convert it to the toroid. You'll make it like this. You'll make it a ring-shaped structure. This is a toroid. Okay. Now see, this is the toroid. This is the center line. From center line to here, this is R. What is the magnetic field due to a toroid? Solenoid. Sir, same will be due to the toroid because toroid is made from solenoid only. So magnetic field due to toroid, mu naught Ni divided by L, same. But what is the length of this? L means length of this toroid, that is 2 pi R. So magnetic field due to toroid, mu naught Ni divided by 2 pi into R. Yes. Okay. And here we define one more thing. Guys, see, this we say inner radius, this we say outer radius. This is R1, this is R2. So we say magnetic field, guys, magnetic field is inversely proportional to R. Magnetic field is inversely proportional to R. If R increases, magnetic field decreases. So magnetic field at this point end will be less as compared to this. So I can write B maximum, maximum magnetic field, mu naught Ni divided by 2 pi into R1. This is the maximum. And minimum would be, B minimum would be mu naught Ni divided by 2 pi into R2. Minimum would be at the end. Now see, there was a question which was asked in NEET 2020. A long solenoid of 50 centimeters in length. Length of the solenoid is given as 50 centimeters. 50 centimeters means 50 into 10 raised power minus 2 meters. This is a length of the solenoid. Having 100 turns, this is the value of capital N, 100 turns. Carries a current of 2.5 ampere. Current is 2.5 ampere. The magnetic field at the center of the solenoid is, guys, what is the magnetic field at the center of the solenoid? Mu naught Ni divided by L. Because when total number of turns are given, then you can use this formula. So magnetic field would be mu naught. What is the mu naught? Value of mu naught? 4 pi into 10 raised power minus 7. N 100. Current is 2.5 divided by L. L is 50 into 10 raised power minus 2. Now solve this and get the answer. Okay. Solve this and get the answer. Okay. Absolutely. Okay, yes, absolutely. Now guys, see, take a look. Now there are two small concepts over here. Current carrying loop as a magnetic dipole. Okay. Yes. Take a look. Now guys, this concept, I would directly show you this one. I would directly show you this one. Take a look. Moving coil galvanometer. This is important. Galvanometer is a galvanometer is a device which is used to detect the current. This is the working of a galvanometer. This is the working of a galvanometer. Galvanometer is a device. Okay. Galvanometer is a device which is used to detect the current. Okay. Or it measures the current. Now, how does this galvanometer actually look like? That is what I want to show you. This galvanometer has got two magnets in it. This is the north pole of the magnet. This is the south pole of the magnet. This is a magnet. Magnet has got two poles, north pole and south pole. When you buy a bar magnet from the market, it has got north pole, it has got south pole. North and south. Okay, yes. It has got north pole and it has got south pole. Now, my dear NEET aspirants, what I want you to understand over here is, if this is a bar, if this is a galvanometer, it has got north pole, it has got south pole. And direction of magnetic field is always from like this. Okay, leave that. And there is a coil placed inside this. Okay, there is a coil placed inside this. And a helical spring is attached to the coil. Helical spring. This is a helical spring. Helical spring is attached to the coil. And then a jockey is attached to this helical spring, something like this. Please listen carefully. I will show you how does this galvanometer actually work. We say it measures the current. When current flows in this coil, listen carefully, when current flows in this coil, okay, due to that current, this rectangular coil rotates. So if it rotates, my dear NEET aspirants, this jockey is connected to this coil only. This jockey also rotates. So when this rotates, torque is produced, because whenever there is rotation, there is torque. And that torque, my dear NEET aspirants, would be, that is NIAB. What is N? N is the number of turns in the coil. This coil has how many number of turns? I is the current. A is the area of the coil. B is the magnetic field. Magnetic field due to this magnet. What did I say? When current flows through this coil, this coil rotates. And this jockey is connected to this coil only. So the jockey also rotates. So this jockey shows you the reading. So means torque is created. Now see, if coil rotates, if let's suppose rotation is large, means torque will be large. What does that mean? Current is large. So if you send large current, we say torque will be large. So coil will show large deflection. So this jockey will rotate. Let's suppose you are sending 2 ampere current. Due to 2 ampere, little torque will be created. So coil will not rotate that much. So it will show less reading. Let's suppose you are sending now 10 ampere current. Okay. Now large torque will be created. Now there will be huge rotation. So it will rotate the jockey and it will show you 10 ampere. Now let's suppose, my dear NEET aspirants, jockey has reached this position. Now let's suppose if you remove the current, the jockey has to come back to the original position now. It won't remain here only. So to bring the jockey back, we use this helical spring. This helical spring creates restoring torque. Guys, due to the current, jockey basically moves forward. Due to the helical spring, the jockey is brought back. So which creates the restoring torque. Torque restoring. And that restoring torque is called C theta. Theta is how much it has deviated, angular deflection. C is the spring constant. Now tell me, guys, there are two things. When the current flows in the coil, it rotates. Due to the rotation, jockey rotates. If current is large, torque will be large. If torque is large, we say jockey will rotate more. It shows you large deflection. Okay. Now, to bring the jockey back, we use helical spring. Due to this helical spring, restoring torque is created, which brings the jockey back. Now, if I say restoring torque is less than the torque which brings it forward, do you think that it is going to bring it back? No. So this restoring torque has to be equal to this torque. Then only it can bring the jockey back. So this C theta has to be equal to NIAB. This is called the equation of galvanometer. This is called the equation of galvanometer. That's it. So in case of galvanometer, we say when current flows through the coil, it rotates the jockey and jockey shows you the reading. Okay. And to bring the jockey back, we use helical spring, which creates a restoring torque C theta. So C theta has to be equal to NIAB. Then only it can bring the jockey back. Now we define galvanometer sensitivity. Galvanometer sensitivity means SI, sensitivity of the galvanometer. It means how much sensitive the galvanometer is. We say, let's suppose your friend, he is very sensitive. What does that mean? He is very sensitive. That means you cannot mess with your friend. If you crack a joke with him, he's going to smash you. Why? He's very sensitive. Okay. So that means sensitive. So sensitive galvanometer means even if the small current enters the galvanometer, it shows the deflection. It shows you the current is flowing. Sensitivity of a galvanometer is a good thing. Now see, how do we define sensitivity? Listen carefully. Sensitivity of a galvanometer. Voltage sensitivity and current sensitivity. Take a look. We say C theta is equal to NIAB. So this theta divided by I is equal to NAB divided by C. This theta divided by I is what we call the sensitivity of a galvanometer. Now see, if current is large, even if less current flows, sensitivity will be large. So if theta is large, sensitivity is large. If deflection is more, so sensitivity is more. This is the sensitivity of the galvanometer. Current sensitivity. Now voltage sensitivity. Voltage sensitivity will be SV or delta V. It will be theta divided by V. Now guys, tell me one thing. We say C theta is equal to NIAB. Can you tell me the value of current here? Current will be C theta upon NAB. Now tell me what is the value of potential difference. V is equal to I into R. V will be equals to I. C theta R divided by NAB. Okay. This is V. Put it over here. This is first. We say put in first. Put in first. When you put this in first, so this voltage sensitivity will be C theta upon C theta R divided by NAB. C theta R divided by NAB. Now this theta and theta will be cancelled. So this will be NAB divided by CR. So SV will be NAB divided by CR. So this is voltage sensitivity. Can I write it like this? SV will be equals to NAB by C. What is NAB divided by C? SI. SI divided by R. This is called voltage sensitivity of a galvanometer. Now take a look. Current sensitivity of a galvanometer is 5 division per milliampere. So SI is given as 5 diV per milliampere. So you can convert this. 5 diV per milliampere means 10 raised power minus 3 ampere. So take this in the numerator, it will become 10 raised power plus 3. So it will be 5000 division per ampere. Its voltage sensitivity SV is equal to 20 volts, 20 division per volts. resistance of the galvanometer will be, guys, SV is equal to SI by R, where R is the resistance of the galvanometer. We say SV is equal to SI divided by R. Take it over here. R will be SI divided by SV. SI is how much? 5000. SV is how much? 20. This and this will cancel, so 250. So the resistance of the galvanometer came out to be 250 ohms. Is this clear? Or tell me in the chats, everybody. Okay. In order to increase the sensitivity of a moving coil galvanometer, okay, sensitivity means current sensitivity. SI is equal to NAB divided by C. This is equal to theta divided by I. Okay. In order to increase, if you want to increase the sensitivity of a galvanometer, one should decrease. What should we decrease? The strength of the magnet. If magnetic field is increased, sensitivity will increase. No. The torsional constant of the suspension. If C increases, this decreases. If C decreases, this increases. Yes. The number of turns in the coil. If number of turns in a coil increase, this increases. If this decreases, this decreases. Area of the coil. If this decreases, this decreases. So I can say this one. B. Next chapter is EMI. Next chapter is EMI. Guys, let's take a break of 10 minutes. Break till 7:40. Break till 7:40 p.m. Okay. Small break. Yeah, small break. Okay. Now, guys, let's dive into the session. In electromagnetic induction, the first topic we need to understand is magnetic flux, that is 5e. How did we define electric flux? Electric flux is defined as the number of electric field lines crossing the surface perpendicularly. Number of electric field lines crossing the surface perpendicularly, that is what we call electric flux. We say it is defined as the number of field lines passing through a surface perpendicularly. Okay. And it is denoted by phi b. Like if I say this is a magnetic field crossing through this surface. How many field lines? 2. So we can say magnetic flux here is 2. If I say through this surface, how many field lines are crossing? 3. So we say flux is 3. So magnetic flux is simply the number of field lines crossing the surface perpendicularly. Now if you write the formula over here, you say, sir, this magnetic flux will be equals to B, okay, A, then we say cos of theta, where theta is the angle between B and A. So you can write this also like this. Magnetic field is B vector dot A vector. B vector dot A vector. B vector dot A vector. So this is BA cos theta. So how do you define magnetic flux? B dot A, or you say BA cos of theta, where theta is the angle between magnetic field and area vector. Yes. Now, my dear NEET aspirants, what I want you guys to understand in this particular case is, listen carefully. That is, let's suppose I say you have a wire over here, circular wire, in which current I is flowing. And there is a square loop present at the center. Square loop is present at the center. This square loop has got length L. Radius of this is, I would say, R. You are supposed to tell me, find the flux through the square loop present at the center. Flux through this square loop, which is present at the center. Flux will be only created when magnetic field crosses through the loop. Now tell me, sir, due to this circular loop, magnetic field will be present at the center. Sir, how? B is equal to mu naught I by 2R. So due to this, magnetic field at the center will be mu naught I by 2R. Direction. Curl your fingers along the direction of current. And thumb is pointing outward. So magnetic field here would be outward. This magnetic field is due to this. And how much is the magnetic field at the center? Mu naught I divided by 2R. And this magnetic field is crossing the loop, square loop. So flux is created. So how much will be the flux? Flux is magnetic field into area. So if I say magnetic flux will be magnetic field mu naught I divided by 2R. Area of the loop, you have to consider area of this loop. That will be length into breadth. L into L becomes L square. So this is going to be L square. This will be the flux through the square loop present at the center. This is the flux through the square loop present at the center. Next. Now you have the opposite of the previous question. You have a square loop in which current is flowing. This is the current flowing in the square loop. And there is a circular loop present at the center, which is having radius R, such that R is given much less than L. Radius of this is a very small loop. Now tell me, due to this square loop, what is the magnetic field at the center? We know magnetic field due to square loop at the center. It is 2 root 2 mu naught I divided by pi into L. If you remember, I have told you this. 2 root 2 mu naught I divided by pi into L. Now direction. So direction in this particular case will be, I have told you, Place your thumb along the direction of current, curl your fingers. So direction of this would be inwards. Since it is crossing this loop, what is the area of the loop? You say it will be pi r square. So what will be the value of flux? Magnetic flux will be magnetic field into area. BA cos theta, na? Theta would be 0 only, na? Because direction of area and magnetic field will be parallel. So I can say magnetic flux is equal to 2 root 2 mu naught I divided by pi into L into area. Area is pi r square. Pi and pi will be cancelled. So this magnetic flux I can write over here 2 root 2 mu naught I into r square divided by L. This is going to be the magnetic flux, my dear NEET aspirants, at the center. Now comes the concept that is called Lenz's law. Lenz's law. What does Lenz's law actually mean? What does Lenz's law actually state? Okay. What does Lenz's law actually state? My dear NEET aspirants, you have got a loop over here. Okay, coil. And there is a magnet placed at this point. Okay. Yes. Okay, let me show you with this. My dear NEET aspirants, there is a concept that is whenever the magnetic field through a loop changes, current is produced in the loop. Whenever the magnetic field through the loop changes, current is produced in the loop. Take a look. Let's suppose, boys and girls, I have got over here magnetic field, and this is an inward magnetic field. This is an inward magnetic field. And this magnetic field is actually increasing. This is increasing. And in this increasing magnetic field, you are placing a loop. So can I say through this loop, magnetic field is actually increasing, changing? 100%, sir. Whenever the magnetic field through the loop changes, current is induced in the loop. Current flows. Okay, current flows. So I can say this magnetic field is increasing and is inwards. Inwards. So we can say current is produced. Current is produced. Now you have to make the direction of that current. Sir, will that current be clockwise or will that current be anti-clockwise? That is the question. My dear NEET aspirants, if the magnetic field through the loop is increasing, then this current, it will be in such a way so that it will oppose this increasing magnetic field. Lenz's law says that if the primary magnetic field in the coil is increasing, this current will oppose the increasing magnetic field. This Lenz's law. Now guys, we say current is produced. For a second, you assume current in this coil is like this, anti-clockwise. For a second, you please assume it is anti-clockwise. Now, if the current in the coil is anti-clockwise, don't you think that whenever current is flowing in a coil, it produces magnetic field? Yes. So due to this current, another magnetic field is produced. Could you please tell me the direction of that magnetic field? Curl your fingers along the direction of current. Thumb is pointing outward. So magnetic field due to this secondary current, that will be secondary magnetic field. This is B primary, this would be B secondary. And this direction would be outwards. So outwards. So this is the direction of secondary magnetic field. Now guys, if primary magnetic field is inwards, secondary magnetic field which was created due to this current is outwards. Tell me, is this supporting the primary or opposing? It is opposing. Means the direction of current which we have taken is 100% correct. The direction of current which we have taken is 100% correct. Why? Because Lenz's law says the direction of current must be in such a way so that it opposes the primary magnetic field. Now, if you are taking the direction of current as anticlockwise, it creates the outward magnetic field, which opposes the primary magnetic field because that is inwards. Like one more question. Take a look. Take a look, boys and girls. I'll make you understand each and every single point here. Let's suppose I say, in this particular case, this is the magnetic field, and this magnetic field primary is decreasing, changing, and it is inwards. It is decreasing and it is inwards. Absolutely, sir. Now, what I'm trying to say is that you have placed a loop over here. There is a loop over here. There's a loop. Yes. Now, through this loop, magnetic field is decreasing. Decreasing means changing. So, current will flow. Let's make the direction of the current as, okay, what will be the direction of the current? Direction of the current must be in such a way so that it supports the decreasing magnetic field. Lenz's law says that if primary magnetic field is increasing, you have to oppose it. If primary magnetic field is decreasing, you have to support it. Like, if you see a person in a society, you see the person is working hard, okay? The person is making good money, but what do? You get jealous. Hey, why is he making so much of money? Why is he working hard? You try to oppose him. You try to oppose him by any means. Okay. But you are a good person also. If another person is dying in a society, he is poor, not able to afford living, in that particular case, you support him. Same is the case over here. Same is the case over here. If primary magnetic field is increasing, secondary magnetic field created by the current, it must be supportive to the decreasing magnetic field. Secondary magnetic field must be inwards here. How is that possible? That is only possible when the direction of the current here will be clockwise, when current is clockwise. So if you consider the current clockwise, due to the clockwise current, we say here magnetic field secondary would be inwards. I hope this is clear. I hope this is clear. Now take a look at this question. Take a look at this question. Find the direction of the current. Primary magnetic field, this primary magnetic field is increasing and it is outwards. Tell me, if primary magnetic field is inwards, increasing and it is outwards, what should be the secondary magnetic field? It should oppose. So secondary magnetic field must oppose it. So that must be inwards. How is that possible? That is only possible when the direction of the current in this must be clockwise. So current must be clockwise. Current must be clockwise. Okay, let's take a look at this. Find the direction of the induced current. This is a wire in which current is flowing as I. Now, due to this wire, do you think it is going to create the magnetic field here? Yes. In which direction? Place your thumb along direction of current, curl your fingers. So that is outwards. So here magnetic field would be outwards. So this would be magnetic field primary. So I can say B primary is increasing and is outwards. So this primary magnetic field, my dear NEET aspirants, which is created due to this, and it is outwards and it is increasing. It is outwards and it is increasing. Now tell me, secondary magnetic field must oppose it. When primary magnetic field through the coil changes, it creates the current in the coil. So secondary magnetic field in this case must be inwards. That is only possible if the direction of current is clockwise. So direction here must be clockwise. This I'll give you as homework, this question. I would want you guys to do it from your end. This one I'll show you. Find the direction of induced current at A, B, C, and D. This is moving with a velocity V. This magnetic field inside is uniform. This magnetic field inside is uniform. If inside is uniform. Now tell me, boys and girls, one thing. Listen carefully. This is the loop. This loop is entering the magnetic field. This loop is entering the magnetic field. Okay. This loop is entering the magnetic field with velocity V. Now, when it is outside, is there any field which is crossing the loop? No, sir. There is no field which is crossing this loop. No field which is crossing this loop. No field. So, if no field line is crossing the loop, what will be the current? Current is zero. Why? Because no magnetic field is crossing. Current only flows through in the loop when there is a magnetic field. While it was going in, as it is moving inside, we say more number of field lines is crossing. So at point B, we say magnetic field primary is inwards. Magnetic field primary is inwards and is increasing. Why? Because while it is moving in, magnetic field will increase now. More number of field lines will cross. Now, secondary magnetic field, my dear NEET aspirants, must be outwards. Why? Because then only it will oppose the increasing magnetic field. That is only possible if the direction of the current in this is anti-clockwise. If direction is ACW. If the direction of the current is anti-clockwise. Okay, let's talk about this one, guys. When this is inside, now the loop is completely inside in a uniform magnetic field. So inside magnetic field is uniform. So when the magnetic field inside is uniform, I would say current would be zero, because current only flows when there is change in magnetic field. Okay. Now, when it is coming out, my dear NEET aspirants, listen carefully. We say, now less number, as it keeps on coming out, less number of field lines will cross. So now magnetic field, which was inwards, because it is inwards, it is decreasing. So secondary magnetic field must support it. So that must be also inwards. How is that possible? When the direction of the current is clockwise. So here direction of the current would be like this, clockwise. I hope this is crystal and clear. Okay, one more important question. Guys, this is very important. Listen carefully. You have an observer over here. And there is a coil A. And you have a bar magnet. Bar magnet means this magnet. It has got south pole and it has got north pole. It is moving with a velocity V. Now, my dear NEET aspirants, when this bar magnet moves something like this, it is moving away from coil A and it is moving towards coil B. Bar magnet is moving away from coil A and it is moving towards coil B. Something like this. Away from coil A and towards coil B. You have to find the direction of the current in the coil, in each coil. Now see, remember this. This coil would never want that bar magnet should move away from this, because Lenz's law says that magnetic field should never decrease through the coil, or magnetic field should never increase through the coil. Okay. Now see, this coil will never want that this bar magnet should move away from the coil. So it will try to attract this bar magnet by creating an imaginary bar magnet, which will have north pole from this side, south pole from this side. Why? Because then only this north will attract this south. This is an imaginary bar magnet. And this coil would never want that the magnet should come towards the coil. So it will create an imaginary bar magnet. It will create an imaginary bar magnet, which will be having north from this side, south from this side. Why? Because then only north will repel. So basically, a coil never wants magnet should move away from the coil, and it also does not want the magnet should move towards the coil. That's why here it is attracting, here it is repelling. Now see, how do we find the direction here? If the observer sees north pole in the coil, now this observer is looking at the imaginary bar magnet. He is directly facing south pole. Here he is directly facing north pole. If he is facing north pole, then current will be anti-clockwise. If the observer sees south pole in the coil, then current is clockwise. Now tell me, in this particular case, what will be the direction of the current in the coil 1 where it is facing south pole? So current will be clockwise. What will be the direction of the current here? It would be anti-clockwise. ACW. Because here it is facing north pole. Now let me give you one more example of this. Let's suppose I say find the direction of current with respect to observer. See, this is the observer, this is north pole, this is south pole, and it is moving with a velocity v. This is coil 1 and this is coil 2. Now tell me, in this particular case, boys and girls, what do you think? If this bar magnet is moving towards the coil, this coil will repel it. How does it repel? It will create an imaginary bar magnet. So this will be having north pole from this side, south pole from this side. And this coil will try to attract it. It will have north pole from this side, south pole from this side. Now tell me, if the observer is facing directly north pole, here also north pole, so we say current in this is ACW and current in this is ACW directly with respect to the observer. Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction. Take a look, my dear NEET aspirants. What does Faraday's law of electromagnetic induction mean? It states that the magnitude of induced EMF in a circuit is equal to the rate of change of magnetic flux through the circuit. See guys, I'll make you understand. See guys, let's suppose you have a coil over here. This is a coil. Okay. Yes. This is a coil. Now, my dear NEET aspirants, what I'm trying to say is that let's suppose there is a magnet. You are taking this magnet close to the coil, away from the coil. So we say magnetic field through, or let me give you this example. This one. My dear NEET aspirants, listen. If let's suppose there is a magnet, there is a coil which is placed in the external magnetic field, and this magnetic field is increasing. It is increasing. Now, whenever a coil is placed in the changing magnetic field, current flows in the coil. And I would say, this is the current. This is the current. For an instance, I would say this is the current. Okay. Okay. Let's make it decreasing. Yeah, this is the current. Now, my dear NEET aspirants, when the magnetic field through the coil changes, magnetic field when crosses, it means flux changes. So we say when magnetic field changes. Okay, when magnetic field changes, my dear NEET aspirants, listen carefully. When magnetic field changes, okay, I would say flux changes. And when flux changes, we say current is induced. Current is produced. And current will not be there, listen carefully, when there is not an EMF. Current is always there where it is EMF. Means if there is EMF, there will be current. So means if there is current, so means EMF is there. EMF is potential difference. EMF is produced. So basically what I'm trying to say is that by changing the magnetic field, you change flux, current is produced, due to which EMF is produced. So basically it is the EMF which is actually being produced due to this, and due to EMF only current flows. So what I can say, by changing the magnetic flux, that is d phi divided by dt, EMF is induced. EMF means potential difference is induced in the loop, in the wire, in the circuit. So that's why minus d phi. Minus is because of Lenz's law. If the primary magnetic field is increasing, secondary magnetic field will oppose it. If primary is decreasing, secondary will support it. This is what we call Faraday's law of electromagnetic induction. So basically, when flux through the coil changes, you say current produces. Current is produced. In reality, first EMF is produced. Then we say because of that EMF, current is being produced. That's Faraday's law of electromagnetic induction. Now, if I say, my dear NEET aspirants, through a coil, magnetic field was changing continuously from morning to evening. If I say how much is the EMF induced from morning to evening, how much is the total EMF induced from morning to evening, that EMF is what we call, that EMF is what we call the, that EMF is what we call that EMF is what we call the average EMF. That EMF is what we call the average EMF. Okay. So my dear NEET aspirants, what I'm trying to say in this particular case, if the flux through the coil changes from morning to evening, the EMF induced will be average EMF. That will be delta phi by delta t. And EMF induced at a particular instant, that is called instantaneous EMF. That will be d phi by dt. When the time was exactly 10:30, what was the EMF induced? That is called instantaneous EMF. Now guys, see. Let's find average current. Average current, I is equal to V by R. V means EMF. EMF divided by R. Instead of EMF, can I write delta phi by delta t? Yes, into R. This will be average current. If I say instantaneous current will be d phi divided by R dt. Now guys, Can I write one more thing also? If you say average EMF is equal to delta phi divided by delta t, or delta t, what is current? Current is total charge flown upon total time, delta q by delta t. It is delta phi divided by r delta t. Delta t will cancel. So this total charge flown will be, that is delta phi divided by r. Change in flux divided by r. This will be total flux, total charge flown. Okay. Now, if you could take a look at this particular question. Radius of a circular loop placed in a perpendicular uniform magnetic field is increasing at the rate of r naught. There is a circular loop, boys and girls. This is a circular loop. It says its radius is increasing, means dr divided by dt is given as r naught meter per second. Every second its radius is increasing by r naught. If I say every second its radius is increasing by 1 meter, so means every second radius becomes 1 meters, 2 meters, 3 meters, and so on. Okay. If at any instant its radius is r, then the EMF induced in the loop will be, EMF will be minus d phi by dt. Now, what is phi? Phi is flux. So minus d divided by dt of magnetic field into area. Now, guys, in this particular case, radius of a circular loop placed in a perpendicular magnetic field, it is placed in a uniform magnetic field B. Area of the loop will be pi r square. So this EMF will be minus d divided by dt of, instead of magnetic field, it is B only. And then it is pi r square. So this EMF will be, take this B out, minus B, pi out, d divided by dt of r square. Now you cannot do differentiation of r square with respect to t. Do one thing, multiply with dr and divide with dr. Now interchange the position. Take it here, take it there. Minus pi into b, dr square divided by dr into dr divided by dt. Now, what is the differentiation of r square with respect to r? That is 2r. It is minus pi b into 2r dr by dt. What is the value of dr by dt? That is r naught meter per second. So this would be minus pi b to r naught. This is going to be the net magnetic. This is going to be the EMF induced. Okay. Take a look, guys. This is a question. A conducting rod of radius r is placed perpendicularly in a time varying magnetic field. So there is a magnetic field over here. That is B naught plus alpha t. And a ring is placed in this time varying magnetic field. Okay, this is having the radius r. EMF induced will be, EMF will be minus d phi by dt. Minus d divided by dt of magnetic field into area. B into A. So this EMF in this case will be minus d divided by dt. How much is the magnetic field given? B naught into alpha t. B naught plus alpha t. Area of the loop will be pi r square. Now, what can you take common? Minus pi r square you can take common. Now, differentiation of d divided by dt of, I would say, B naught plus alpha t. So minus pi r square. Then differentiation of B naught. B naught is constant. So differentiation of constant is 0. And differentiation of alpha t is alpha. So it would be minus pi r square alpha. Now you have motional EMF. Now you have motional EMF. Take a look. Boys and girls, motional EMF means, let's suppose you have a rod. It has length L and it is moving with a velocity V. Whenever a rod is placed in the external magnetic field and it moves with certain velocity, it has length, EMF is induced in the rod, that is BLV. Now, if any of the two are parallel, BLV, if any of the two are parallel, EMF will be 0. Now see here, this is magnetic field, this is length, this is velocity. Now velocity and magnetic field are parallel, EMF is 0. Here, this is length, this is velocity, velocity and length are parallel, EMF will be 0. Here, this is length, this is magnetic field, they are parallel, EMF will be 0. If any of the two are parallel to each other, EMF will be 0. Means all the three must be mutually perpendicular to each other. All the three must be mutually perpendicular to each other. Okay. Now guys, take a look. Let's suppose if I say, what is the EMF induced in the rod of length L? You tell me one thing. In this particular case, boys and girls, if I say, what is the EMF induced? You say, sir, EMF will be simply, that is B, L and V. Now tell me in this case over here, what is the magnetic field? Guys, due to this infinite wire, magnetic field at A distance, because at A distance rod is present, mu naught I by 2 pi A. Mu naught I divided by 2 pi into A, then L into V. This will be the EMF induced. If the rod is moving something like this, this is the length in Y direction, velocity in Y direction. So magnetic EMF in this case will be 0. EMF will be 0. Because length and velocity are parallel. What about this one? Guys, see, this is the magnetic field. This is length L. This will be one component of the length. If this is 120, this would be 60. Now this component of the length will be what? L sine 60. Okay. This component of the length would be what? L sine 60. Why? Because this is also 60. This is L. This is L. This is 60. This would be L sine 60. Now, whenever you have a structure like this, you say EMF will be simply B L effective. You take effective length into V. Now see, magnetic field is B L effective. L sine 60 plus L sine 60. The effective length is join one end of the structure with another end. So L effective, you say 2L sine 60. Sine 60 is root 3 by 2. 2L sine 60 is root 3 by 2. 2 and 2 will be cancelled. So this would be root 3L. So this would be L effective is root 3L into V. So this is root 3 BLV. Root 3 BLV. Now comes self-induction. Now comes self-induction. Now guys, see, what does self-induction mean? Let's suppose this is a wire, solenoid. Okay. In this wire, current is flowing. Okay. Due to the current, magnetic field will be produced inside. So that is B. We have studied recently magnetic field due to a solenoid inside is mu naught N into I. Now this magnetic field is crossing the area of the loop. It is crossing this coil. So flux is being created. So can I say, guys, if current is flowing, due to the current, magnetic field is produced. Due to the magnetic field, flux is being produced. Because magnetic field crosses the coil, flux is produced. Can I say if current is large, magnetic field would be large? Absolutely. If current increases, magnetic field increases? Yes. So I can say this magnetic flux is directly proportional to the current. Replacing the proportionality with a constant, so this flux will be equals to L into I. Where L is called the self-inductance. Where L is called the self-inductance. And this self-inductance is actually equals to, its value is mu naught N square A into L. N is the number of turns per unit length. N is the number of turns per unit length. A is the area of cross section. L is the length of the coil in this case. Okay. Now tell me guys, if the current in the coil is changing, If this current which is flowing in the coil is changing, we say then magnetic field will change, because magnetic field is made because of this current only, due to which flux will be changing. Now, how do you write flux, my dear NEET aspirants? So flux, how do you write change in flux? So from this, guys, from this, how do you write change in flux? d phi by dt is equal to L. L is constant. How do you write di by dt? Current, change in current, di by dt. So d phi by dt will be equals to L di by dt. Now we know according to Faraday's law, EMF is equal to minus d phi by dt. So you can say instead of this, we can write minus EMF. So minus will take here. So EMF is equal to L di by dt. This is called self-induction. Production of the EMF in the same wire. Guys, see, this is the wire. In this wire, current is flowing. In this wire, magnetic field is changing. In this wire, current flux is changing. In the same wire, EMF is being induced. So that's why we call it self-induction. Now see, question on self-induction. The current passing through a choke coil of 500. L is equal to 500. Self-inductance is 500. At the rate of 2 ampere per second. Is decreasing at the rate of 2 ampere per second. Means di by dt is given as 2 ampere per second. Means every second it is 2 ampere per second is decreasing. The current which is passing through a coil is decreasing 2 ampere every second. EMF induced in the coil would be, you have to find EMF. EMF would be minus L di by dt. This is also negative, na? Because it is decreasing. So it would be minus L. L is 5. Di by dt is minus 2. So this would be 10 volts plus 10 volts. There is a question. A long solenoid so I hope you got the feel of this question, guys. So basically there is a coil. In this coil, this has the inductance of 500. In this coil, current is decreasing, di by dt. With what rate? 2 ampere per second. So whenever the current, see, what does self-inductance say? Whenever the current through the coil changes, it means flux changes. And when flux changes, EMF is induced. Okay. That is Faraday's law. And that EMF here will be L di by dt. Why do we call it, see, production of EMF means induction. Why do we call it self-induction? Because this happens in the same coil. 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 Okay, so that's why self-induction. Now take a look. A long solenoid has 1000 turns. There is a solenoid, it has 1000 turns. When a current of okay, a long solenoid has 1000 turns. There is a solenoid, it has got 1000 turns. Okay, there is a solenoid, it has got 1000 turns. When a current of 4 ampere flows through it, current is 4 ampere. The magnetic flux linked with each turn is this. So if I say magnetic flux through one turn, it is 4 into 10 raised power minus 3. Now how many turns are there? 1000. So can I say magnetic flux through 1000 turns? It would be 1000 into 4 into 10 raised power minus 3. 1000 means 10 raised power plus 3, 10 raised power plus 3, 10 raised power minus 3. So flux would be 4. Okay, then it says the self-inductance of the solenoid will be, guys, what is self-inductance? Will be flux is equal to L into I. Net flux is 4. L, you have to calculate how much current is flowing. That is 4. 4 and 4 will be cancelled. So L will be 100. 100 is the value of L. Okay, yes. Now there is a concept of mutual inductance, guys. See, concept of mutual inductance. You have a coil here. In this coil, current is flowing. In this coil, current is flowing. Radius of the coil is R. Now, due to this coil, magnetic field will be produced at this x distance. We know if the current is flowing in a coil, it produces magnetic field at x distance. Now, that magnetic field is crossing the coil too. So, can I say flux will be created through coil 2? So, flux through coil 2 is equal to, so I'll write it like this. Flux through coil 2 is proportional to the current in coil 1. Because when the current flows through the coil 1, it produces the magnetic field at x, which crosses the coil 2. So you replace this with a proportionality. So that is M into I. So this M is called the coefficient of mutual inductance. This is called a mutual inductance. Now, the value of this mutual inductance is this. Mu naught R1 square R2 square pi divided by 2x cube. R1, R2 and distance between them is x. Now, if I say, my dear NEET aspirants, this current changes. If I changes. If current changes, magnetic field changes. Magnetic field changes, flux through the coil, second coil changes. So flux di divided by dt into M will be equals to d phi divided by dt. It is second, it is first. Now, when the flux through second coil changes, so EMF is induced. So that EMF will be minus M di by dt. So this is what we call production of EMF is called induction. But in this particular case, current is changing in one coil. EMF is producing in another coil. So this is called mutual induction. Self-induction means when the current is changed in one coil. Okay. EMF is also induced in the same coil. That's called self-induction. But mutual induction means different. I hope this is crystal clear to each and every single student. There is a question on this one. So the question is, a coil, okay, the decrease in the primary, decrease of current in primary coil is 2 ampere to 0 value in 0.01 seconds. Okay. So basically, change in current, delta I, it is 2 ampere. Or you can say DI. DI is 2 ampere. Current changes from 2 ampere to 0 value. So that is going to be 2 ampere. Time. What is the value of time dt? That is 0.01 seconds. Okay. EMF induced in the coil 2 is 1000 volts. EMF is also given 1000 volts. You have to find the value of mutual inductance. We can say EMF is equal to M di by dt. EMF is given as 1000 volts. M. Di is 2 upon dt is 0.01. 0.01 means 1 divided by 100. Take this in the numerator. This will become 1000 is equal to 2 into M into 100. 0, 0, 0, 0. So M will be 2 ones are 2 5s are. M will be equals to 500. Is this clear? Or tell me in the chats. Is this clear? We are done with the chapter EMI. Now next is AC. But I don't think we'll continue the AC in part 2, second portion. AC is a small chapter. With this, I'll end right now. Okay. So that's all for today. Please do let me know in the comments later on how was the session. Take care and bye-bye. Thank you so much.